Oh god, I did the thing where I forgot to unmute the first time I gasped, and then I unmuted, and now I already have a lung full of gasp. Hi! Welcome! Thank you very much, Cat! Hi, Cat! Also, thank you very much for the bit secret cake. Oh my god, and the resub, Devnal. Holy crap, how has it been? 18 months. That's a double Twitch baby. Did you know that? It's a double Twitch baby.
okay. Dumb Fox 0, Dumb Fox 0, Dumb Fox 0, okay.
Hi!
Dumb Fox 0, Dumb Fox 0.
Hi, Cat! Hi, Cat!
Dumb Fox 0, Dumb Fox
0,
Dumb Fox 0, okay.
She's gonna go on for a while. She'll cut herself off after a minute though. I think. Oh, there she goes. She actually finished. Hi! Welcome! Holy crap. Tier 3 as well, Devnal. Oh my god, Dara, thank you very much for the resub! I'm flipping tier 2 as well. Bread 20 as well. I swear to god. If I get muted when I'm talking, all I can do is do Morse code through the music volume control. Hi! How the hell's it been 20 months, Dara, as well? And Mocha as well, thank you very much for the resub. Holy crap. Hi. Oh my goodness. Hi. Welcome everybody to a strange cat. Hi, I'm waving. Oh, it's actually tracking. Holy crap. Hi. Oh god. You got your 1 year. Wait, it was actually, wait. Hold on a second, I understand. Actually, thank you for a very spooky retro. Give this up the top. Oh my god, I'm struggling to catch up. Thank you for hydration this whole corridor. I actually have coffee, but it's decaf coffee, so I can drink as much as I like. Wow, those retro swallows sounded very interesting. But hi, welcome everybody. Yeah, I super appreciate the ratings. I'm very spookily gonna say welcome to GD and the Liquid Cake, who I nearly called Liquid Cat because you said cat in your message. Welcome in, Sea of Tranquility, and Nexu, and Pig, welcome back. Hi, and Maggie. Hi. Thanks for rolling on in. That's a nice, very vibey mode. Is it called a vibe? No, it's called VO. And Yan. Welcome in Smash as well, and B-Top, holy crap. The whole gang is here. Exia, hi, Dara, Irid even, Jesus. Mocha. Alright, you said thanks for the resub, Mocha, but hi. And hi, Dara. And hi, Commodore. Thanks again for the flipping hydration. Not the Neko Uke. Hell yes, the Neko Uke. That is the thing drawn by Cat. And speaking of things drawn by Cat, with permission, I will be using some of her stuff today to see Nude. To see Nude. Yes. I don't think Cat would appreciate me using her stuff for anything to do with newting. She doesn't appreciate the nudes. To see how well stuff is working, I'll be testing stuff on something. Anyway, welcome in Devnal as well. And Erin already said, Nexia already said, Liquid Cake, I'm contributing. You are contributing. Thank you very much for the bits. I super appreciate it. Somehow we're at level 3 high train. Or is it? No, 52% of level 3, right? Yeah. No, is that how the scam train works? I think so. I very much appreciate Liquid Cake. Thank you.
Dumb Fox Newt.
Dumb Fox and the Newt. Wow, I actually pronounced it like Newt. The Dumb Fox no Newt plus Newt. Let's quieten this music down just a touch. That was it. That was a touch. Is that everybody? I think I've mentioned everyone. I think. Oh, see ya! Hi! Welcome. I don't know. You are cheating with time. Man, I have absolutely zero idea what I was talking about. Oh, right. The 20 months. How it's been 20 months. Yeah, I don't know. It wasn't me, I promise. I don't have time manipulation abilities. Oh, you got your 1 year as a Uke sub. Oh my! Been a sub for 1 year, huh, Cat? Only a year? I thought you were a sub for like life. Anyway, welcome to Sonic Castle as well. Hi, and Natalie, welcome. Hi, welcome everybody. I'm joking. It's a pun. It's not a bribey thing. It's the sub and Dom, even though it's actually bottom. Also, I'll be right back. No! Why's my thing so quiet? Do I have it turned down? I do not hear it turned down. That eating sound was like super quiet. I'm back now though. Hi. That's what someone with time manipulation abilities would say. Yeah. Well, if they wanted to remain you know, undercover, then yes, sub for a sub. Curious. Sub for a... yeah, it was a subscription for a submissive.
The word definitely doesn't feel like it's been that long since I found your stream.
Yeah. Something's wrong with time, I swear to God. Someone needs to patch that. But thank you very much, Natalie. Holy crap. I feel a bit guilty being thanked for that. Thanked that much for what amounts to a 7 pence donation? Oh, don't worry, it's actually more like 3 pence, but I appreciate it very much. Hi. You know, like, it's not a thing that anyone needs to do. However, I feel more guilty that Jeff Bezos just stole 75% of what you paid for that, but it's very much appreciated.
Indeed.
This is why I call it a scam train.
Shut up.
Why is there so much cheese being thrown at me? Omni, hi. Hi. This is too much cheese. I said it's too much. I said too much. That means you don't continue.
Cheese.
Hi, Suave Zombie and Sophie as well. You can donate cheese. You can and you are, but you don't need to.
Cheers.
Neil as well. Holy crap. Hi. And Longer had to. Got a gift sub from Flipping Liquid as well. Sheesh. Thank you again, Liquid. You don't need to keep doing it. I promise.
Cheese.
I can only thank so much, but I but I do appreciate it. Stop.
Cheese.
This is crazy. Do you have some?
Cheese time.
Cheese.
I do have some cheese. Yes. Do you have some favorite food, or is a cookie all right?
Asking for
You know.
reasons. I like cookies. I don't have them very often. Like what over here would be called cookies. I don't have them very often. But I like them though. Can you see that much cheese? I cannot! Look! If I can see, then you can see my red eyes. You see those tiny little flashes of red? That's the moment when I can see. If I shake it off, or like, you know, push it like off the side, then I can see. But now I can't.
You know.
I cannot see.
Cheese time.
Spooky, high-pitched, I like cookies. It's probably my favorite thing of the day. I like cookies. There you go. That's a new soundboard sound for you, Cap. As far as I know, Twitch takes their cut of the bits when you initially buy them. Yes. That's the thing.
Twitch takes 50% when you pay to get like a bit budget, if you like. I don't know what the word is. And then when you give the bits to the streamer, they take 50% of that as well. So there you go. That's why I do read the scam stream. But either way, I bet they charge different currencies, different amounts, and pay out only the minimum. I think everything is done in dollars, and then they convert the dollars to at least their rates up. Wait, no, there was actually a thing recently. They put out an announcement recently saying they're changing how much stuff costs as well. So, anyway, glad I only bought £1 of bits. I feel like every time I open my mouth about this, I'm risking being banned by Twitch, so I'm gonna stop. Anyway, I appreciate that you chose to throw some of them at my head, especially when I wasn't even on the screen. I think I accidentally left my thing unmuted though, so you did hear it, right? The best way to support streamers is just to donate them outside. True. Yeah, true. Ko-Fi takes a very, very small percentage. I don't remember what. I think it's less than 20%. It's different depending on. I haven't been able to work it out exactly. I think it's like possibly like a fixed amount plus a percentage or something. Because it's never the same amount when it's paid the same. I don't remember how it works. The recent changes are only related to Prime subs, I think. Oh, it's only related to Tier 1 subs for me. they're only changing the price of tier 1 subs in my country from variety. They're changing the price of tier 1, 2, and 3 in Turkey, though. Like a crazy increase, like 3 or 4 times the cost now for what it used to be in Turkey. Anyway, I don't mind paying Twitch a bit of money. Hosting streams isn't cheap. I mean, that is also true. Yeah, it's very true though. Like the best use of money if people are wanting to throw money to a streamer is either through stream elements, because they take very small amounts. I can't remember, do they take any if you're doing it via PayPal? They must take a small amount, right? I know if you're doing it via the se.pay thing, which is for cards, they charge like a tiny single-digit percentage on payouts. I can't remember. Anyway, I should probably look all this up beforehand instead of saying things. Anyway. And then I think Ko-Fi, yeah, they take a bit more. I don't know what Throne takes. I can't remember what Throne takes. In any case, it's going to be way less than 50%, that's for sure. Okay. Jeff could also help out with the bills. I'm sure he can afford it. Yeah, you know, he might have a couple of pence, like, slid down the side of the sofa or something. Also, I have to say, Nyan! For Zytol. And thank you for the pats. I think I might also have missed some earlier. Hold on, let me just have a quick look. Be patted for Suave Zombie 4 minutes ago. Holy crap. Okay, wait, did I never catch up on all of the redeems? Okay, one sec. Let me just go back to the very beginning of today.
Käse.
Wait, Stewie did a posture check and hydration 2 days ago. I wasn't even streaming 2 days ago. What the hell? Ow, 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 ow. Donk, dink, donk. Thank you very much, Mug Attack. You've also stopped buying bits. Only have some left. I do like the pride bits though. Well, oh my god, I can't stop hiccuping. I very much appreciate it. There was a neon from us for myself testing the redeems. Hydration I've done. Patty cat, throw cheese. Nyan. I've been yeeted. I've had a lot of cheese thrown. There was a bee patted from Suave Zombie now 5 minutes ago. Okay, let's actually do the damn thing. Pat, pat. Oh god, it can't track me at all. What the hell? That was weird. Pat, pat. There you go. Sorry, the slightly scuffed pats. Also, holy yuck! Why am I now holy? Okay, I think I've caught up. What are we auto-encoding today? Images. Yeah, let me give you a quick rundown of what I'd like to do. I'm probably going to require, you know what, maybe I'll get Unity loaded up, right now. Cheese. Actually, no, I know, you know what? No Unity today. No Unity today. I'm going to have a bit more of this caffeine-free coffee because I can. I'm sorry, I don't have a, like a mug modeled. Do a barrel roll? I actually can't rotate on that axis. I can rotate on this axis. Wait, that's it. That's the only axis I can rotate on. I mean, I can do this. I guess I can, like... Whoa. Oh, if I were playing Trackmania, then yeah, and I just, like, flew over an edge, like somersaulting, then yeah, my model would start somersaulting a little bit. Hi, Dusticles. Is this French? Well, I was able to read it, so I think it's English. Also, I'll be right back, because I'm being yeeted off the screen. Hi. I'm back. You probably rotated a bit during that. Yeah. I sure as hell tilted. Okay, let me give you a quick look at what I'm working on today. Actually, should I do this? Is there anything I can do to help? No, I don't think there's anything I can illustrate at this moment, so I won't switch over. Cheese. I'll just stay in this purple box of a room. Why the cheese here, and I swear to God. Whoa, hi Oddly, welcome! Hi. How you doing, Yuki? I'm glad you survived the Ukro apocalypse. Oh yeah. There is a channel in my Discord server called emote spam, where people can just go wild with stickers and emotes. And somebody recently said that it's like the Ukroll sticker that was drawn by Ethics, which is also an emote here, by the way. It's this. Let's get a few of those floating across. Look at them go. Yeah, so someone was saying that basically the ucrawl is an SCP and the emote spam is the containment for it. That's the containment channel for this SCP, and occasionally it breaches containment. And yeah, I as in said, I can no longer see the emote spam channel as anything other than the SCP containment channel. Cheese. What the hell? Where did the cheese go? Huh? Did that like clip underneath my chin, through my neck, and onto the back of my head? Aaron, what are you doing with these strange cheese techniques? Cheese. I feel bullied not being able to spam it here. Aww. Pat pat. Advanced cheesing. Yeah, that was crazy. What the hell? Hi Tengunami as well. Welcome in. Cheese. What did I say?
Cheese flop.
Yes. There you go. Small human just threw that cheese at you and then said again, no! No! God damn it. What are you teaching her? Small human, you don't have to throw cheese at the...
Cheese!
at the weird cat on the internet. I can't believe there's a cat communicating with a small human by having cheese thrown at it. What has technology become? This is 2024. I have the server to spam it. You do. You have the channel to spam it. Human desires cheese to be thrown. She is having so much fun.
Nice.
Well, okay. I'm glad. I feel somewhat slightly uneasy about having small human watching since it's marked as mature, but
Caseri.
I'll try not to swear too much. I swear. Look at this. Look at this. Look at this. Look at this cheese. Look. This is what you did. Ah!
Cheese.
I swear. Yeah, okay, so I was making... What's your fucking language? I'm sorry, I'm trying. There you go, I said it already. And yes, Keza.
Caseri.
I think Aaron knows what he was getting into when he was bringing a small human to the stream. Okay, how difficult would it be to have each cheese have a message written on it? I don't know, in mayonnaise or something. Getting
Cheese.
getting cheese. Getting text onto a material is fine. I've made a dedicated system for that, which I still haven't even used in this setup yet. But it's in this setup. It's invisibly taking up VRAM and stuff above my rim somewhere. Is where it's positioned in the scene. But yeah, I'm not so sure about... I would need to like make a new material, not just modify an existing one. Which is certainly a thing that can happen at runtime. I don't know if that would result in a memory leak though. I have thought about that as well though. Well, actually originally I thought about having people's avatars be on the cheese. Like the avatar of the person who throws it. I also thought about having the name of the person who speaks, but the name is actually chosen after the cheese lands on my face. The sound is only chosen at the moment that it plays. Well, you know, immediately before. I thought you just said that you weren't going to swear. Look, I literally just read the message. That's all there's worth. I swear. Wait. Oh, I see. Because I said I swear, right? I swear. I mean, I see. I mean, I just said I swear instead of I see. Switching to lurkers, I'm not actually entirely willing to let Twitch parent my child. Okay, I'm glad. Thank you. I would hate it if I became, like, one of those goddamn videos that children get addicted to when their parents just give them an iPad and set them free on the very weird world. I was about to say weird and wonderful, but no, it's just weird and quite disturbing world of YouTube children's videos. Anyway, bye, Erin. Bye. Small Human says thank you. Well, you're welcome. Like Peppa Pig having her teeth pulled out. That sounds very horrible, but exactly like the kind of thing that would be on there, yes. So, when I'm on... This isn't a children's video? It's not. I'm sorry. Also, I'm having a tiny bit more of this caffeine-free coffee. It's so nice being able to drink it because I like the taste. but it's not going to make me like super shaky from, you know, the caffeine and making my anxiety worse and stuff. Hashtag not sponsored, by the way. If it was sponsored, it would be sponsored by Nyan Juice. Friendly reminder to stay hydrated. Anyway, the fuck was I talking about? Oh yeah, right. Drink water. I do have water as well. Next to me. I also have Nyan Juice next to me. I now feel so adult, such forbidden act watching you now. Speaking of that actually somehow relates to what I was going to do today as well. And the fact that I'm not going to be doing that because it's against Twitch's TOS, but I had to go out of my way to make sure that I don't accidentally do it on today's stream. Because here's an idea that I had. So I don't remember who, but wait, I just switched over to Twitch on Firefox and it's suddenly saying you received a level 2 hype train emote. I guess it's only just showing that notification now because I only just switched over to it. Interesting. I didn't know it sort of queued up notifications to show when I switch over. Hi Rosemaster, welcome! Trying out half decaf. Feels nice. Wait, is that a thing? Wait, now I'm wondering why is there not coffee sold that's 100%, 90%, 80%, 70%, 70, like 69%, 68%? By the way, I was not actually trying to joke with 69. I was trying to just start going down more gradually, and I realized that after 70 comes 69, so nice. Yeah, I mean, they'd have way more products to sell, right? Thank you for the hydration. I will... Shall I open up a new... You know what? Let's open up the bottle of Nyan Juice for this. Let's do it. The trouble is I was trying to have the coffee first because the coffee is, you know, still lukewarm and I was trying not to let it become cold. But sure, I'll open up a brand new Nyan Juice bottle. Alright, here we go. Let's do the ceremony. The opening of a brand new Nyan Juice bottle. Are you ready? My hands are not tracking, but it doesn't really matter. Wonderful. Holy crap, let me try that again. No, it doesn't track at all. Amazing. Well, hi. Thank you for the hydration. I got it from Dunkin'. They have literally just put half in regular decaf. Interesting. Just miss decaf and caf in whatever proportions you... That's true, that's true. Having caffeine as a powder and pouring it in kind of terrifies me. Because I've never done it before, but just the idea of it. Because, you know, that's kind of easy to have a very unpleasant death if you mess up. And put in a lot more. Because we are missing so many products in the average supermarket. I know, right? You should just have the entire aisle of 100% caffeine coffees, and then another aisle of the 90% caffeine coffees, etc. Oh, that's true. You could do that as well, liquid cake. Yeah, just mix it. Yeah, that would work. Are you? Nyan! We need Nyan Juice e-made. Yeah, actually, that's totally possible. I should do that. I took a Pro Plus. What is a Pro Plus? On a bike ride once. Because I heard it give me power. I know I had such a high heart rate on a bike ride. I did go fast. Oh my god. 99.9% caffeine. Unless you have a caffeine sensitivity, you'd be surprised how much caffeine a person can survive. I mean, there are recommended limits. Like, people can survive things that are past the recommended limits, but I wouldn't recommend it. Pro Plus or caffeine pills. It sounds like part of an Apple product name. This is the Caffeine Pro Plus X. Imagine black text on a white background. With a full stop after everything. Right, so here's the thing. Is there a recommended limit for Eucarol? Nah, it's alright. If it's an emote spam, it's alright. One Panera lemonade. Oh, is that the lemonade that was killing people? Unless you have amputation sensitivity, you'd be surprised how much amputation a person can survive. Okay, hi Center, welcome. Right, so what a friend of mine, somebody in a community, I can't remember if I'm, like, I would call myself friends or they're just a person in the community. I'm, like, spending much less time in that community than I used to be now, and I'm unfortunately falling a bit out of touch with everybody in there, and it kind of sucks, but anyway, nobody asked. But also, so what somebody did in a VRChat community that I'm part of, that was the weirdest grammar ever. I hope you understand what I'm trying to say. Is they made like a kind of a thing in VRChat for their avatars. For their avatar. Cheese. Unless you have cheese sensitivity, you'd be surprised how much cheese a person can survive. Is this becoming a copy pasta?
Cheese.
Fromage.
Fromage.
Cheese.
Hi, Chaos. See, I survived that. What was I trying to say? Oh yeah, right. So VRChat avatars. I don't know, for those who don't know much about VRChat avatars and like making them, VRChat gives you as an avatar maker 256 bits to spend on your avatar if you like, however much you want. Basically every avatar, this is a really weird way of saying it, let me try it again. Every avatar has 256 bits that it can use however it wants, and these bits are automatically synchronized between, like, with every other player in the current world instance, meaning that if the bits on your avatar locally for you change, then the bits on your avatar locally for everybody else, or remotely I could say, change, so that the effect that they have on your avatar locally is reflected on your avatar over there as well. And you can choose to spend these 256 bits however you want, in the sense that you can use individual bits as booleans, which is really nice. You can use them as, in groups of 8s, as bytes, and you can use them as an 8-bit float whose value ranges from -1 to 1. Actually, I think that's it. There might be one other way to use them, I can't remember. But you can spend them however you want. And obviously, if you start getting really, really complicated with avatar animators, which is the way that you define the logic for your avatars, this is just using something called Unity animators and animations. An animator in Unity is like a flowchart, like a state machine, or many different state machines. An animator has layers, and each one has their own state machine. And a state machine can have as one of its blocks another state machine inside it, and there's like conditions about when it moves from one state to another and all this stuff. And you can drive parameters as well as act based on the parameters. The parameters being these bits. And so yeah, through the animator, animations are controlled, and animations can control other things as well. So what a lot of people do who make VRChat avatars is they might have different sets of clothings or different settings for clothings. Like for example, I have a setting where I can like change the amount of glow on my wrist cuffs and skirt, and also change the color of it. And the way that works is I have just defined a parameter, or 2 parameters, and I can change those through like the menu on my wrist in the game, the radial menu. And yeah, one of them drives an animator to go between like the beginning and the end of the animation, and the beginning of the animation has my wrist cuffs at like 0 brightness, and the end of the animation has the wrist cuffs at maximum brightness. And then as I change that dial on my wrist, I'm basically just changing the value of what I've defined to be wrist brightness, and then it changes the position through the animation, like it's paused at a certain position through the animation. And this is when everybody sees that. So when I change the brightness on my end, everybody sees my brightness change. And the same for the hue, that's just done through an animation as well. It's a very kind of not straightforward way of controlling things. And this is because VRChat doesn't let you do actually C# scripts on your avatar. Thank God because otherwise anybody could just be running their own arbitrary code on your computer. They could just like randomly, I think I'm gonna look at these files on this hard drive, maybe upload these ones to this server, delete these files, you know. Yeah. So thank God they can't just run their own arbitrary code. But the flip side of that means that you'll have to jump through hoops to make much more inefficient ways of doing things on Avatar animators. So you have 256 bits for just random stuff? Exactly. None of them are used by default, but you can use them. And like other things will be synced automatically, like the IK, the inverse kinematics. So you'll move and stuff by default. And like your voice is synced and everything. Those don't count towards the 256 bits. And these 256 bits are synced at 5 frames per second. If you're close to the person. I think the update rate might drop to lower when you're far away from the person. Like you will, their things will only be updated more rarely. I think, I'm not sure. And I also think, but I'm not sure, that it might not update at all if they're out of view. But I am not sure about that. I know that in the past, it didn't update if you weren't looking. And I also know that in the past, there were mods that would drop the update rate lower when you're further away. But I don't know if that's one of the things that VRChat copied and then said, hey, look at us, we banned mods. But by the way, look at all this amazing new stuff we're doing that we totally didn't steal from mods. Anyway, people already have poorly optimized avatars. I can't imagine poorly optimized scripts. Yeah, speaking of poorly optimized, what the fuck is my frame rate doing right now? It's like super smooth on my, it's just running super smoothly, but on OBS it's super slow. I guess if I were to switch to a screen capture on my other screen, it would be smooth now? Wait, hold on, let me try capturing through Spout instead. Is this smoother? Is that smoother? I can't tell if that's smoother or not. This is game capture, and this is Spout. It looks identical, and also it looks like it's not running so slowly anymore. I'll never understand why OBS sometimes just drops to low-looking frame rates, but apparently everybody who's watching the stream says it looks smooth still. Anyway, hold on, where was I? Toggle clothing stuff. Yes, people can use them for that. Unfortunately, it has resulted in hugely, way more horribly, VRAM consuming avatars, because people are now like, well, I no longer need to make individual avatars if I want, you know, this outfit and this outfit. I don't need to switch avatars anymore. I will just, put every goddamn 4K texture for every flipping clothing set onto my avatar. Sure, it takes 1/4 GB of VRAM, and I'm only one person in a world that could have dozens of people, and not everybody has a fucking RTX 3090. But that's what VRChat has encouraged. And finally, recently, they started adding VRAM usage as a part of their performance ranking for the avatars, so you will finally now get penalized for the amount of VRAM that you use, and that'll get your avatar marked as, you know, good, excellent, or poor, you know, all that kind of stuff. And you can filter avatars by that. You can also filter avatars, thankfully, by download file size. Anyway, one tiny mod I miss is the one that replaced the loading screen tips with random pics from your VRChat photo filter. Oh yeah, I do remember that one. I remember seeing that one. I didn't use that one, but I remember reading about it. So you want to use the encoder to put more stuff in those bits? No. That's a pretty cool idea, actually, but no. I'll get onto it in a sec. I'm just going to catch up on the chat. But the autoencoder is related to those bits, yes. Wouldn't the correct thing to do just be run the avatar code in a sandbox, like how browser code is run? I don't know how feasible that is in C#. Because C#, you know, is like a language for like a whole OS, and it can like call most functions in the OS can call, so I don't know how you'd sandbox that on a technical level. I mean, I guess like they can make their own scripting language. For worlds, they have what's called Udon, which is like a node-based like visual programming language, and people, some third party has made something called Udon Sharp, which is a way that lets you write scripts in text, and it basically compiles into Udon nodes and stuff, so that the people who are more familiar with writing code out can do logic by typing it. But that's only for worlds, that's not for avatars. So unfortunately for avatars, you're stuck with animator logic. And like, I think the animator is like, what, isn't it like Turing complete or something? Like you can do a huge amount in it. But when you're wanting to do what I'm wanting to do and what some other people who have made like very complex avatars, like what I'd call gimmick avatars, I'm calling what I want to do a gimmick as well. Because it's just for showing off and being like a cool thing. It's not actually a practical thing that I'll use most of the time. And it's like going to use so many bits that I wouldn't use it on my normal avatar either. I'd just make a separate avatar just for this gimmick. But what they often do is they write something that is like an editor script for Unity. It runs in a Unity editor. And the code populates an animator and maybe creates animations and sets it all up. So they don't have to do this like really complicated stringing together of things visually with their mouse and stuff, because you might end up needing like dozens and dozens of layers with complicated logic and stuff, that it kind of is easier to visualize in code, and then the code itself can make the animator, and that's just done, you know, in the editor, and when you upload it, it already exists. So you can make code that makes animators, but your code itself can't run on the animator, so sorry, can't run on the avatar. That's probably what I'll end up doing. But that's a little bit down the line. Java can be sandboxed pretty well. It works by effectively providing a custom class loader, which is used in the security scope. You can pass anything you like into the sandbox, and the sandbox can do what it likes with those things, but the sandbox can't access anything you don't let it. That sounds interesting. Hi, Clockal! I have an avatar I've managed to break a couple of toggles on, and I have no idea how I managed it. I guess that's the logic of the animators having bugs, I guess you could call them. Those 256-bit stuff sound amazingly tight when you're streaming audio and downloading VRChat avatars. Yeah, so, well, the 256 bits are just like aspects of your avatar that work when the avatar is downloaded. The avatar doesn't like download through them. But yeah, it's incredibly tight. If you imagine that you wanted to have all of them be floats, right? The 8-bit floats, 256 divided by 8, that's 32. Which is, then you're just dedicating everything to that. Which is actually a lot more than it used to be. For a long time, it was 128. Anyway, thanks for going to my history lesson. Now let me actually say what I'm planning on doing today. So, I thought it'd be really cool. Oh yeah, right, what a friend did, right. Okay, hold on, we're almost getting there, right, I swear. So, you could even get 2 slices of cheese with only 256, or you couldn't. Well. Okay, so what someone did was, they made like a plane, like a 2D plane, or it might have been like curved, I don't care, it's really not important. And it was like in front of their face, so it looked a little bit like a headset in front of their face, right? And it was visible to other people. Not to them, so they could see through it. I guess it was back-face colored, so they could see straight through it. But if you're looking at their face, you see the plane. And this plane would show what they're seeing on their desktop at a resolution of 16 by 9, not an aspect ratio of 16 to 9, and a resolution of 16 pixels by 9 pixels. And I don't remember exactly how long this took. I think it was like maybe like 40 seconds or a minute or something. I can't remember. It might have been over a minute to send all of that. Because they're sending like the red, the green, and the... So if you work this out, it's 16 times 9 times 3. So it needs to send 432 values.
Cheese.
Hi, Reminisce. So it's needing to send 432 values. Hi, Dummy Zone as well. Welcome. Hi. Oh my goodness, everybody's rolling in suddenly. Hi. So yeah. So that's 432 channels, right? Red, green, and blue. Across 16 pixels horizontally and 9 vertically. So yeah, it took a long time. And I think they said that they could make it much more efficient, but they were doing it one by one and stuff, like not parallelly. But anyway, the very fact that was even possible was so goddamn cool. Because that's just like, it's not like a mod or anything. It's just like, this is actual functionality that's now possible. And you might say, well, how the hell do you get the view of your desktop into like the animator, right? How are you getting this across? So what they do is they have their own, I'm assuming this is what they do, it's what I plan to do. Basically I have, because what VRChat allows you to do is control those parameters that you've defined as part of those 256 bits that every avatar can have, you can control those parameters through OSC, which is like a layer on top of UDP. And it's also how my motion data, by the way, it's getting in from VCFace into my Unity setup. So, and you can also send stuff out from here to externally. That's how I control my StepMania fan. Sorry, not StepMania fan. My TrackMania fan. The other mania. There's also Beatmania that I sometimes get confused with. So many manias. Yeah. So essentially, you can have communication between your avatar running locally and another program running locally on your computer, which is really cool. This is also how people get their heart rates, like real life heart rate, to show up on their avatar in VRChat. Ukemania? But that's just Uke. Uke is manic. So yeah, that's how basically. So essentially the flow of data goes from like something, like some image somewhere, like could be like a view of their screen. In my case, I wanted to be an image. That gets loaded by the external program. The program converts it into like some format that you're expecting, your avatar is expecting to, or your avatar is making available, basically. It's like it's listening for certain parameters. So yeah, your external program sets those on VRChat locally, and then VRChat takes care of syncing those parameters to everybody else in the scene. For your avatar running on everybody else's machine. Also, thank you for the hydration and the posture check. I'm gonna have a little bit more of this coffee. That is getting very cold. Oh my god. Yuki clicker. I read that as Yuki licker or U clicker at first. Wait, that still sounds like Uke licker. What the hell? Thank you, Stewie. Hi, Stewie. What was I saying? Yeah. So then the actual hard part is effectively decoding.
Formaggio.
Decoding those things to visible, something that's visible in your avatar, right? Because you want the image to be visible. And the way that I plan to do that is through a shader. Essentially, the animator will control animations because this is just the way that you can change things in VRChat. That's just the standard way of doing it. And the animation will control sliders on an avatar. That's the way that I'm going to get data into the shader. So the parameters will get set by my external program on my computer, or on other people's computer, they'll get set by, VRChat syncing them. And then those parameters will control an animation, or many animations actually. And the animations will set sliders on the shader, and probably some other logic as well. And then finally, the shader will be actually drawing things to a texture that is used, or rather the shader is controlling how a material looks, which will be on a plane on the avatar. Shader, yes! Yes! Actually shader, but not right now. Will it roll? Absolutely not. This is going to be very, very slow. We have a, the joke about, wow, this image is taking forever to download. It sure is nice being on a 56k modem. Yeah, this is a 1k. This is a 1k modem. So yeah, this is obviously going to take like on the order of like a minute or two or something to upload. And so here's how I want to do it. And here's why I'm using an autoencoder. And here's where the neural net stuff comes in. 1.25k, really? Oh yeah, true. I was thinking it was 200 bytes times 5, yeah. 1.25k, wow, well, we're rolling then. We are on a roll, it will roll. So I want to compress stuff, right? Because as I was just saying, 256 bits, if you want to set red, green, and blue of every single pixel, that's a lot of data. That's a lot of data. That's a lot of nuts. Completely unrelated, but do you wear tracking gloves or does your program just have good camera hand ID? I'm gonna say neither, because right now I'm holding my hands and it's only tracking one of them. And I'm waving and it's still only tracking one of them, and I'm moving them around a lot, and there we are, it finally tracks both of them. That's just a leap motion. It's a leap motion. Leap motion is 2 cameras and some infrared LEDs. That's it. And then the computer's actually running software, unfortunately. Neural nets, funnily enough, with the latest version of the software, Gemini. What about putting the JPEG conversion to the max? Well, then I have to implement a JPEG decoder. So I'm not sure about that one. Also, JPEG is still going to be too big. I really need this to be small. Like, I need this to be bytes for an image, not kilobytes. What? Why? Really done one image format. What's another? Oh yeah, true. No world gets sprayed. No! Stop this! Look, I swear I'm trying. Anyway, so what I've done is I've made an autoencoder. Now I can switch screen. Flipping finally. Except no, I can't quite yet because I need to show the correct logo on the screen. What's it gonna be? It's gonna be... Right now it's set to... Trackmania. Yeah, that's not right. Let's get rid of that one. Do I have a logo for Python? Oh, shit, I don't have a logo for Python. I have a logo for Python. Okay, let's make a really quick one. New. How do I do this? One sec. Okay, I'm gonna start. This is now an art stream. I'm drawing a logo for Python. Okay, let's switch over. It's an art stream. I need 580 by 200. Alright, it's gonna be a dark green background, right? Because it's like a Python, and then it's like a light green foreground because it's like a Python, right? And it says Python. Dada. Okay, that's my Python logo. Let's save this in this folder. As soon as I say this, it'll appear above me. Watch. Ta-da! There we are. Perfect. So now I can actually show you this. Draw a derpy snack. I guess I could. Oh yeah, right. I'm gonna be zoomed in most of the time anyway, so you're not even gonna see the goddamn logo. Oh well. So I've made an autoencoder in PyTorch. And so what is an autoencoder? I guess I should say first. Sag, blue, yellow noises. Blue, yellow noises? Oh yeah, long U could be a Python. So what's an autoencoder? An autoencoder is what's the word? Like a structure of neural network. There's a proper word for it. I used the right word the other day and I've forgotten now. Where you've got an input and you've got an output of typically the exact same type, and then there's maybe some other layers in between, a little layer in the middle, and then some other layers on the other side. It doesn't have to be symmetrical, it typically is. And the goal of it is you put something into it at the first stage, and it tries to learn how to make exactly the same thing in the output. Why, you might say? Well, because this, look, it has to go through a bottleneck. So if it can learn to represent this huge input, which should be the same as this huge output, in a way that can fit into a tiny amount of space, well, what you can do is you can run an image through it, and you can say, ha, yoink, I'm going to take this, ta-da, and you run away with this. And this is now your really nice, small, compressed representation of the image. And then later on, you can say, psych, I'm not giving you an image here, I'm actually giving you something here. And then it just runs through like this, and it decodes that output back to this. Ta-da! Now you know what an autoencoder is. Auto because it's like literally trying to encode it's to itself, you know, the image is trying to become itself. So I made one of those and I trained it on a bunch of stuff, and this is why I need to be careful, because a lot of the images I trained it on would not be safe for showing on Twitch, because I just happen to have some of those saved. But yeah, so at this point I feel like I should mention for Twitter and the Twitter mentality that well, the certain kind of people, this is not a generative network, okay? This is not trying to generate art that other people have made. It's literally trying to remake whatever you put in. So you can take your moral and, you know, like ethical dilemma stuff away. This is not one of those neural nets. Side note, it technically doesn't have to be a bottleneck, but I completely forgot for what reason you might want the central layer to be bigger. Well, you can have it bigger and make it a k-sparse network, and then so a k-sparse network is a type of network where you have not all of the neurons active at one time. You limit it to the ones that are strongly activated, and you force all the others to 0. And this is kind of cool because it can end up helping you make sense of the input a bit. because you're gonna very easily see certain patterns of like only certain neurons lighting up under certain circumstances. Like maybe this neuron always lights up when there's a lot of red in it. Whereas if it's not k-sparse, so all of them can be active at the same time, it's very, very hard to see patterns. Because they're all like interlinked in some very non-obvious way. You know, the weight into every neuron can be different, and it's some can be positive, some can be negative, so this goes on when there's red, but not if there's also blue in this position, and not if this neuron's not on, because, it's like, it's such ridiculous things that you can never really understand easily by looking at it. Anyway, NSFW autoencoder. Maybe? Okay, so I made a thing. And, it's not particularly nice to look at, because it's Python. But it works, and I actually made a comparison image, but this was yesterday, and or a few days ago actually, because yesterday I was dead. But on Freb's stream recently, I showed it. I showed one image, and then since then I actually made a huge improvement to it. I'll quickly show this because I don't. Stuff. I'll just very quickly show it. This is a test image that I ran through it. So this is what it was originally. That's actually what it was originally. What it was originally was this. Yeah, this is an original image. And once it got encoded and back output again, it turned into this. And maybe this requires a little bit of explanation actually. Turn the chat back on. So how this works, how the hell is it going to reduce the number of the bytes that it takes to encode something, right? So the way that I chose to do it is I chose to make it work on blocks. So it works on 12 by 12 blocks. 12 pixels by 12 pixel blocks. And whereas originally you have 3 channels, right? Red, green, and blue for every 1 pixel. This encodes a 12 by 12 pixel region into 56 neuron values, which you can call channels. It's literally 56 values that make up 12 by 12 pixels, just like how this is 3 values that make up 1 pixel. And the way everything works inside PyTorch is it's a 32-bit floating point number. So, and the way that my network works, all the values are between -1 and 1. So already, even just by doing that, it actually compresses it to roughly half the size. But in order to actually make it nice and properly small, it does what's called quantizing to those values, which is basically just snapping them to a nearest value that can be represented. So you can imagine, just like how VRChat has like a float that's 8-bit, right? And the values range from -1 to 1. I think they range from -1 to 1. I'm slightly worried that might be wrong. Then, 8 bits lets you hold 256 different values, right? And so essentially then, instead of having like 32 bits worth of data, you just have 8 bits worth of data. The values still map to values between -1 and 1.0. But yeah, now you've only got 256 different ones of them, so you can squeeze it down into 8 bits instead. And when you do that, the values of these 56 channels become a little bit off what the ideal values are, so you lose a little bit of quality. But you save a lot of space. And so in this example here, it's squashed down to 6 bits per channel. Which is already like 10% of the, slightly better than 10% of the original size when you work it out, right? Because basically you just divide it by the number of pixels, right? Which is pretty goddamn cool in my opinion. Jeez! Why, long kiddo? Hi, Mocha. I was trying to install PyTorch at work, and I think it was 3 gigabytes or something. It's literally bigger than my entire OS. Yeah, it's 2 point something gigs. It's kind of crazy. And that's without CUDA and stuff installed. Hi, Lunketta! And you got to do that for every single Python environment, because you got to make a Python environment for everything you install, because Python is dependency hell. And if you accidentally install like a newer version of, for example, PyTorch. Maybe it will depend on different versions of other packages, and they'll depend on different other versions, and they'll depend on different other versions. So if you don't make a dedicated environment for it, where it can have its own copies of packages, bam! Congratulations, you've just broken every goddamn thing you ever wrote in Python in the past. Good luck trying to find the old versions of everything that you had before. So yeah, 2.something gigs for every Python project that uses PyTorch. Amazing. Anyway, I shouldn't be going on a Python rant this early. It's worse than NPM. Fair enough, I wouldn't know. Anyway, so originally, this is the literal original image, right? If we look especially in this area, because this is where you can see a lot of noise, when it's encoded, you can see it's nice and smooth here, right? After it's been encoded, this is the best it can ever hope to do, because this is before I quantize it at all, before I do the rounding to near values that are not quite perfect. This is like the perfect 32-bit flow. This is as good as it could do, trying to squish 12 by 12 pixels into 56 values. Which is pretty cool, because, I mean, unfortunately you can see like the edges of some of these 12 by 12 regions. But generally it's not that bad. And like the fact that you can still make out these shapes, I think is super, super cool. And it looks like it learned to encode solid colors in some very good way. When it's a block where there's like an outline, there's more noise and stuff. Again, when you zoom out, it's not that bad, right? And then after quantizing it, you can see that there's a bunch more noise in this area now compared to this. But yeah, and so then I made another image where I tested these. Basically, I made one where it's 6 bits per channel, 5 bits per channel, 4, 3, and 2 bits per channel. And this becomes really, really bad. Or it did. It did. But here's the thing. Sneakily, after the Freb stream, which I was part of, where I showed this, I continued working on it. And I made one small change. And now look what we can get. So vertically, this is the same number of bits per channel. At the bottom, it's how it was before I made the change. At the top, it's after I made the change. Look, this is how 2 bits per channel used to look. And this is now how 2 bits per channel can look. 2 bits per channel, which works out to 0.8 bits per pixel, which is just absolutely amazing to me. So, yeah, but it's also better across the board. So if you compare like this 6 bits per pixel, if you look in this little noisy area, it looks like that, compared to this, which is less noisy. It's probably not super easy to see over Twitch. But yeah, it is better across the board. Like 4 bits per pixel looks like this here, compared to this here. I think once you get down to the really, really low bits per pixel, it makes a huge difference. Shrunk my images with this one weird trick. Yeah, I should explain what I did, actually. So, let's go back to the test folder. I've also done the same now, and from now on I'm going to be using Cat's images, because I have permission to actually use their images. So here it is again. I've not trained it on any of Cat's images, so this is like outside the training data at this point. This is like a true evaluation of how good it is. Because I think that picture that I used was actually in the training data. Now this is some other stuff that I was considering using that CAD also drew. So here's the original image. And here's the original image after it has the right and bottom chopped off slightly, because I haven't made it handle things that are not a perfect multiple of 12 by 12 pixels. And this is the best it could ever hope to look, because it's converted to floats. As we crank the compression 6 bits, 5, 4, 3, 2. This is before I made the improvements, okay? Is this also supporting the alpha channel? It's not. And then on the other hand, after I made the changes, we have the 6, 5, 4, 3, 2. So you can compare this to this, which is quite cool. Honestly, this is like, for like a low quality setting, I'd say this is actually usable. Yeah, I did the same for this image of hers as well. Blah, 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 blah. I think this one actually works quite well. At the most extreme setting, that's the 2 bits per channel, or 0.8 bits per pixel, compared to the old way. Okay, so let me actually show you what let's go and poke around a little bit inside it. By which I mean stuff. Hold on, 1 sec. Oh my god, please. Let's just do this once here. We'll set it to 6 bits per neuron. Wait, we screw it and push the boat down, just do 8. And then we'll do a testing code. You also get to see how fast it is now as well. Okay, I'm gonna delete all of this for a sec. Okay, this is gonna run on the CPU, and the most time is taken by initializing PyTorch, by the way. Here it is. When I actually go into a for loop of trying it with all different bits per neuron, it like fires through them super quickly, but there's overhead for the very first image that it does, like this. So now it's initializing PyTorch, now it's loaded the model, and now there's an error. Oh, right, I deleted the image that it's trying to load, huh? 1 sec, that's a little bit silly. Where is the image? Available. Processed. Let's use Enlin again. Should we use Enlin? I'm sorry, Enlin, for using you. Actually, let's use this one. Neko Yuk. Let's use a different one. Test orig. You see how many attempts it took me to press enter? And it's done. So, let's actually, 1 sec. Okay, so this is how it used to look. This is like without my the little extra thingy I did. And the blocks are a result of the model. There's a definite kind of shape. It wants the blocks to be there. They're different colors, but seemingly all the same. Yeah, they're all the same shape. It's just splitting the image into 12 by 12 chunks and treating them completely individually. It's not even attempting to like blur them together at all. It's just trying to get the best representation of any 12 by 12. Oh, look right here. This 12 by 12 happened to be compressed really well. But you have to bear in mind, this is like zoomed in as well. Are you playing around with VAE compression? Not variational autoencoder, just an autoencoder. Hi Arby, Killia as well. This is one that I made in PyTorch. It's very, 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 very simple. And I'm trying to make it simple because I'm going to need to implement the decoding part of it in a shader for VRChat eventually. So it's just fully connected layers, or as PyTorch calls them, linear layers, with tanh activation. That's it. The bits per pixel is the model weights themselves. Yes, exactly. Just on the middle layer. The middle layer where the most compressed representation is. But which obviously floats normally, right? Mia, welcome in. Oh, hi Malphabeth as well. So what you're seeing right here is this is the 56 neurons that make up the each 12 by 12 block, stacked left to right for the blocks that run left to right in the image, and top to bottom for the blocks that run top to bottom in the image. So for example, for this image, I can't easily count. Wait, I don't need to count because it says right here. Size in chunks 21 by 21. So when you look at this image here, it's 21 pixels tall. Because each pixel vertically is the value for one of the neurons. Yeah, anyway. So the width of this is going to be 21 multiplied by the number of neurons in a block, right? So it's 21 times 56, which is 1176. So what you're seeing here is like the internal representation, like the encoded version of this image, spat out into grayscale. These are like the actual values just mapped into the grayscale range. So normally these range from -1 to 1. And here I've mapped them to 0 to 255 so that you can view them as pixel brightnesses. I mean, each 12 by 12 on the super bad seems to have the same kind of tilted V shape in it with different colors. Ah, right. The internet seems to think that V-shape is somehow ideal to whatever metric you're judging it against. Yeah, I guess just by sheer luck, that was a shape that it saw a lot during the training data, which is completely by chance. I guess I should mention how the training code works as well. It goes through a whole folder of images, which I can't show you, and splits those into 12 by 12 chunks as well. And for every chunk, it looks at the contrast of the chunk. If the chunk has very low contrast, it will just add that chunk to the training data and that's it. But if the contrast is high enough, that is, there's enough detail in it, it rotates it by 90 degrees 3 times. So you end up with 4 different copies of that chunk as training data. So you have like a version that's upright, a version turned right, a version upside down, and a version left. So that you can like better, you know, that there's more examples of what images can look like. I just wanted to, because this is called data augmentation. It's kind of very useful to avoid overfitting and just making better use of your training data. Overfitted slide to that type of image. I guess you could say that. Remove orientation bias. Yes. But also, because the 12 by 12 chunks are pretty random, you won't get an idea of what's up and what's down that well. It's, yeah. Anyway, I think I'll make it not like perspective. Not like perspective? Anyway, so these are the things, and I am quantizing just the activations, RB. So, iteration Y 2 by 12 by 12? Well, I tried 8 by 8 originally, which was really, I thought that was going to be like a lot. I originally was trying 8 by 8 with 28 neurons, and it worked pretty well. And I thought, well, maybe if I just make it a little bit bigger so that it has more context, if you like, maybe it can make better decisions about how to compress it. But I needed to also increase the number of neurons in that case. I needed it to also, be more neurons for that, right? Because it's not fair for it to say, hey, here's 56 neurons. Sorry, here's 28 neurons. I know you're making 8 by 8, but hey, now try and squish 12 by 12 in, you know? So I needed to increase that a bit, but I didn't want to actually increase it by the same amount as the number of pixels, because I was hoping that I might be able to get greedy and squeeze some more compression out. Anyway, it works. TLDR, no, not really. I just tried some numbers and it worked nicely, and now I've got something that works well enough for me, and that's what I want to use. Okay, so this right here is like the representation of this image. And this is before I've done the improvement, right? The improvement that led from it looking like this at 2 bits per pixel to this at 2 bits per pixel. Sorry, 2 bits per neuron, 0.8 bits per pixel. Let me show you. As soon as I had this here, I looked at the histogram here, and I immediately saw, wow, there are loads of values that are close to 0, and there's like hardly anything is being used close to the edges, right? In fact, if you click number of colors on this one, for example, 168 colors, it's literally not touching some values close to these values. It's not just that there are not many, you know, because you'd expect to see 256 colors if it was using everything. So yeah, this, by the way, this histogram, as this is an aside, but this histogram is actually really gives you a really cool insight into how similar the type of image you're compressing is to the type of stuff it was trained on. If it's similar to the kind of stuff it was trained on, you see like lots going on near 0. If you see stuff that's spread quite far away from 0, then it's like, my interpretation of that is that these are values, it's encoding stuff that is far away from anything that it saw in the training data, and you can expect to get worse results. Expect it to look worse. Just as a test. Thank you for the pats. Welcome in, Mr. Saps. That rhymes. Let me just use an image that is, I know, is very far from what it was trained on. What about something really dark like this? By the way, all of these things were drawn by Kat, and I want to give her a shout out. Also, she draws at higher resolution than this, but I've shrunk all these down to a small size because I was obviously this is if it's sent over VRChat at a very low bandwidth, I want these all to be very small images. So when I was training,
Tja. Diri.
cheese.
Ost.
Kasseri.
Cheese.
Yes.
Cheese.
Käse.
Cheese.
Holy crap! I disappeared right as they stopped. Hi, Fab. Video Python logo if you wanted to suffer. Could do that actually.
Ost.
Although a lot of it is a solid color, which it will encode really well. So yeah, I when I was training it, I shrunk down all the images. All the images in the training data are 256 pixels on the shorter side. So I just did the same for this. What is it? The image is very far from anything I was trained on. Trying to get. Oh, maybe something like this. This is a lot of green stuff with lots of detail in it. Let's try this one. Let's try this one. Let me just call this Nekoyuk. Cheese.
Cheese?
We'll run it again. Boop. Okay, and it looks like this. So this is the input. This is the best output possible. No, that's the best output possible. That is got some. Oh. That's terrible. So I guess it's never seen blocks with both green and purple in them because it doesn't seem to understand how to have both purple and green in one block at all. Oof. Which actually is good for my example because I'm hoping that when I look at this, the histogram is going to be... Okay, look. See how there are now spikes that are further away from the center point compared to before where the spikes were much more in the middle? This is like an interesting thing that I noticed. Thank you for the hydration and the posture check, Stewie. So compare that spectrogram there, where you've got like clearly two humps with a dip in the middle, compared to this one, boop, which is much more spiky in the middle. I think this one's also got a big spike in the middle because a lot of it is just solid white, right? Which probably shows up quite a bit in the training data. Part of the reason why I was rotating the 12 by 12 blocks is to bias it away from solid colors to make it so that it doesn't get really good at encoding, solid colors and just doesn't put much effort into, curves and stuff. Train it multiple times per image with a grid offset. That would work as well. Giving it an offset, that's another way to augment it a lot. I can also flip horizontally and vertically. I'm not flipping yet. And only if the contrast is good, of course. Not on solid color blocks. The cheese can't go. Well, unfortunately, I don't know. You need you need one flip if you have the rotations. Yes, true. I wouldn't flip both horizontally and vertically. I would flip horizontally and add that. And then I would also flip vertically on the original image and add that. Yes. One flip and 4 rotations of each? Oh, that's another way of doing it. Wait, really? Wait. Oh, okay. One flip and 4 rotations of each. That's interesting. Okay, I hadn't realized that actually. Is the ultimate goal to send not one image, but multiple images through the bottleneck? If so, have you thought about encoding multiple successive frames at once? No, it's only to send one image. I'm not trying to do any interframe compression, like for animations. This is going to take like on the order of like minutes and stuff to send. So we can actually calculate the best case of how long this might take to send. Vertical and horizontal is identical to rotate 180. Oh, okay. Okay, thank you. So we can actually calculate how long this would take to send. So we've got 256 bits, but we cannot use all 256 bits because I have to still explain a little bit how I want the shader to work. A lot of the bits are going to go into the encodings of the actual values of the neurons. Oh, I never actually got to finish explaining how I actually made this encode better. Anyway, some of the bits will actually go into the values of the neurons, but here's the thing. VRChat, the updating of like all of the parameters is not guaranteed to be lossless. In the sense, the values will arrive exactly how you set them, but they might not get updated at all. I mean, you might not receive a batch of updates. It's meant to happen 5 times a second. One of those updates might be dropped, or one of them might be the same as before. If you're assuming that it's going to update 5 times a second, because there's no synchronization mechanism. VRChat updates at what it believes is 5 times per second. My program is going to be sending to VRChat at what it believes is 5 times per second. But they're not going to have the exact same timing. So sooner or later, I'm going to send one before it sent the previous one, in which case it would get skipped. Or I'm going to send one twice, because VRChat has updated twice when I've only updated once, that kind of thing. So I don't want anything stateful, anything that preserves like a state between updates. So I want every 256, like every update of all 256 bits to be completely self-contained. So I want it to have a full encoding of a 12 by 12 block, or maybe more blocks if there's enough space. And I also want it to have like coordinates of where that block should go in that update. So I'm going to use 1 byte for like X index position, 1 byte for Y position, and then the remaining bytes can go into representing that block. Maybe there'll be some other blocks as well, some other bytes as well, but not all bits are going to go into encoding the neurons. So how did I make use of this? Well, what I've done so far is I implemented a thing that I've just, the variable name is called mid-range zoom, which you can probably imagine is basically zooming in to this middle range of values here, which is what's centered around 0 inside the neural network, because inside the neural network it all centers around 0. There's -1 to 1. And here you could say it's zooming in around the 128, the grayscale value right in the middle, right? The grayest of grays. And then it's just clipping off anything near the edges.
Lactose-filled
Chris!
dairy product.
Hi! Thank you for the pats, but not for the cheese. How do I shorten that phrase? I keep saying it very much. Thanks for the pats, but not for the... Oh god, I'm pressing control, help! I was pressing control instead of shift, let's try again. Thanks for the pats, but not for the cheese. Tuft puppen. No, that doesn't work very well, does it? Trying to
Cheese.
turn it into an acronym, it didn't work.
Thanks for the pants, but not for the cheese.
Oh, that's a good way I could do it. I could do exclamation mark T. Yeah, that's Stewie. It's harder for me to type that. Like, it's faster to just say thanks for the pads, but not for the cheese. Oh, almost. I just made the exact same typo twice. Pads tab.
Pants, tab, cheese, now.
PTCN.
TFTPB and FTC.
Okay, so here's what I did. I zoomed into that middle region. And I zoomed into the middle region more if you're wanting to encode it. Hang on. Oh, hold on. Wait. Let me make her read that.
Tefat Babanafici.
There you go. So the way I've made it look better is I zoom into that middle region of values where there's lots going on, brightness-wise. The more it's being thanks. The more it's being quantized, the lower and lower bit depth you're giving it. Here's another one, by the way. Original best possible encoding is this, and then quantized to 6, 5, 4, 3, and 2 bits per pixel. But then after the adjustment, now with it zooming into the middle, the area with the most activity, more and more, we have 6, 5, 4, 3, and 2 bits per pixel. So this here is how it looks when it's been zoomed in a lot. You can have a look here and see that there's actually a lot being clipped off on the bottom at this point, because this is when it's quantized to 2, so it's zooming in a lot around the middle. So there's actually a lot of values that are clipped all the way at 0 and a lot that are clipped all the way at 255. But still, the values that are going to be at the extremes are the rare ones, right? It's usually the rarer ones that are near the ends. So it's better to dedicate the bandwidth, if you like, the bit rate, the bits, to the values that were close to the middle than the values that are close to the edge. So that's what it's doing here. It's, yeah. Also, what you're seeing here is not actually quantized because it's still 256 colors. If this were to actually be reduced to like 2, no, that's 1 bit. Sorry, this here, I guess would be in. I don't know. Clunk, hi Paperclip as well. Thank you for the pants. But as somebody mentioned earlier, possibly Liquid Cake, I can't remember who. My Bailu, yes, hi Cat. I'm sorry, I'm destroying your artwork. Yeah, let me actually do a proper shout out for Cat. This is the person who was drawing this. I said earlier I wanted to shout her, and then I just got distracted by myself. I know you'll never believe that, but it happened. Ta-da! She was just streaming 27 days ago, according to this. She actually rated earlier though. She doesn't have a VOD uploaded. Pat. Anyway, yeah. Actually a cracked artist. She takes comms. So, yeah, seeing this all squashed down to 256 pixels at most, or at least, it's probably, oh wait, I do have the original size ones on here as well. Okay, never mind, I can show you the actual, you know, the actual detail that the stuff is drawn at. This is a version without shading by the look of it. What's the newer one with shading? This one. There you go. It's pretty nice. By which I mean extremely nice. Shut the fox up. Anyway, this as well. This was drawn for this person's birthday. The Lobotomy Bunny. I forgot the name for a sec. Then I looked in the background and saw it. So yeah. When this is cut down to like a small resolution, you won't see any of these details probably. Let's have a look. Can you see those specks still? A little bit. I don't reckon this will be preserved well at all when it's compressed. But hey, let's find out. It's probably just like noise though, right? So let's delete these. Test Auric. Run the thingy. Boop. And here's what it spat out. Oh, let me just re-enable the thing that makes it print all combinations. Oh, not print, but create. This will give you a sense of how quick it actually is. Ready? Done. Now it's on the CPU as well. So that just created all of these images. So that's the best it could ever hope to be. And then 6, 5, 4, 3, 2 bits per pixel. Well, there's certainly more speckling now. Anyway, somebody earlier said, what did they say? Non-linear quantization or something? You said non-linear. Okay. So yeah, that is another thing that I would maybe like to try. And that will probably get some better results. But I'm not sure if I want to do that right now. Basically, the idea is that you dedicate more bits to the middle than at the end. And I would just use like a curve, you know? So like what would the curve be? I guess it would be like I'd do something, I can't remember. Some kind of power curve, I don't know. Anyway, I have an autoencoder working now, okay? Any plans to do QAT This is a minor thing, but if you're using ReLUs, you could likely get a small improvement in changing to most other activations. I'm using no ReLUs. I'll show you what I'm using. So the input comes in, it goes into a layer with 256, then it goes to another layer with 256. So right there you've got 256 by 256 weights. Then there is a max pool 1D, which I don't think I actually need. This is left over from when I was trying previous things. I should probably have removed that. I might try removing that and retraining it. Then we have the middle layer. And after this, so basically before this, I'm safe to do fancy stuff, okay? Because the encoder is always going to run in PyTorch. After the middle layer, it needs to have simple decoding only, very, very simple layers. So it's just fully connected 256, fully connected 256, and then we're back to this. And all of these have tanh activation. The reason I need these to be very simple on the decoding side is because that's what I'm going to implement in a shader. Outside of the max pooling, the encoder is 100% linear. Not linear in the sense of activations. Yeah, I don't know why, but Torch calls it linear. When what it really is a fully connected layer. It's fully connected. I don't know why it calls it linear. So tanh is the actual activation function. Linear is just, I guess it's called linear because it's a one-dimensional row of neurons. I think that's why it's called linear. But yeah, linear has a very different meaning in my head as well. But that's just what they call it. It calls it linear because it's a matrix transformation, which is linear. Okay, now we're getting onto math stuff, which I don't actually understand, I'm sorry. Thank you for the Patson then. And by the way, the way that I'm going to get the weights into VRChat, onto my avatar I should say, is like this, in the form of textures. Which I'll also, oh, actually for the textures, I made a note of the minimum. Okay, let me explain this, hold on. Inside the neural network, the way this works, okay, let me sketch this out as well. So you've got a layer, you've got another layer, and there's a bunch of neurons. I'm just going to draw 3 because this is going to quickly turn into something that's hard to draw, or time-consuming to draw. Every one of these is connected to every one of these, like this. And each one of these is a connection. A value goes in here, either it comes straight from the image, or if it's a later layer, it comes from the previous layer, like that, you could imagine. And a thing happens here. It's the tanh function, but that's irrelevant. You have a value here. And each one of these lines is, it lets some of this value through to here. It can also negate it, because the amount it lets through can be negative. And the amount it lets through is called a weight. So in fact, this literal connection you can call a weight. So the weights are changed during training, and they represent what the neural network has learned about how to compress an image in this case. And so to be able to decompress it, I need these weights in my VRChat avatar. And the way that I'm going to get the values of all of these into my avatar is not through something ridiculous like hard coding them, but it's through a texture. Because in the case of this, these weights are basically a 2D set of values. Because you can think of it like this is an X coordinate and this is a Y coordinate. And as you read across, you have, actually, I can't remember which, I might be saying this the wrong way around. Let me just double check before I spread false information on the internet. That would be crazy. Training, output to PNG, middle layer. So each X chunk vary 10 middle layer predicted chance. Oh, here we are, show network weights. How does this work again? Height of image will be in neuron curve, width of image will be in neuron prev. Height of image is the current one. Okay, so yeah, in the case of this layer here, which one comes first? The current becomes the Y. Okay, so effectively, you can imagine that this gets drawn to this pixel, This one gets drawn to this pixel. If you imagine that this is an image and you want this to become a texture, right? You want to make a texture of all the weights. And this one becomes this pixel. Then you move along to the... Wait, is that right? I think that's right. No, it's the wrong way around, right? That's the wrong way around. No, that's the right. Oh, I cannot... I was second guessing myself so many times. I might be the wrong way around. Anyway, this, and this then become the values on the next row. The strengths of these numbers become the next values on the next row. And so I build a texture out of these weights like this. This is where Python is actually super, super useful, because in just a couple of lines, you can convert this entire thing into an image. Like all of these weights, like literally 2 lines. And what I do is I take, I make a note of the minimum value of all of the weights and the range of all of the weights. So basically I use that to scale all of those values that are in the weights, which could be like a number that's negative or a number that's positive. And these numbers can be outside the -1 to 1 range, by the way. Yeah, so I make a note of the minimum max, and then I map those to the 0 to 255 range of the image, right? The brightness of the pixels on a texture. And then boop, ta-da, you end up with something like this. So that's not much. There you are. And so I will hard code the minimum and the maximum, I guess, or the minimum and the range. But yeah, so what you're looking at here is like the internal weights. So the encoder is, I've just got the code saving everything at the moment, but we don't actually need all of these. And so for every layer there are 2. There are the so-called weights, which are those lines that are joining the neurons. And then there's also the biases. And this is just an extra value that's passed into every neuron that allows a neuron to... how do I explain this? Imagine that every neuron on a previous layer was outputting 0 into a new neuron, but that neuron needed to have a value of 1. There's no way that it can get a value of 1 if all of the values coming in are 0, right? It can't just magically turn on. It's just doing maths. So it's just summing up all of the values that are coming into it, which will sum up to 0, and then it's running that through some like curve, basically. But the curve I'm using would actually make that be 0 still. So the bias neuron is just a solid fixed value that always also goes along into that neuron, which can be non-zero. So that the neuron actually gets a chance to turn on if it needs to turn on, basically. Or turn off if it needs to turn off, I guess. So here we are. We have all of the weights basically, and they're here as an image. So that's the first. This is the channel where it takes it from like a 400 and something or 432 pixels wide and converts it into 256. So you can see here it's 432 by 256. This 432 comes from the number of red, green, and blue channels of the input. So it is a 12 by 12 region of pixels, 1 for red, 1 for green, and 1 for blue. So that's what's going across. So going across is the first pixel's blue, the first pixel's green, the first pixel's red, and then the second pixel's blue, the second pixel's green, the second pixel's red, etc. All for every single neuron, top to bottom. And yeah, that's the first layer. Second layer looks like this, because this is just a 256. You know, the previous layer outputs 256, this layer outputs 256, therefore this image is 256 by 256. And this one is the connections into the middle layer. And there's something interesting going on here. The values stop at 256. And I think this is because of the max pooling that I'm doing. Max pooling is basically you just take the maximum values. It's a pool of maximum values, effectively. You're taking only the highest out of every so many activations from the previous layer. And it's kind of interesting that internally it internally it's still storing the weights for all of the previous neurons, but it's clearly not actually running training on them because they're best max pooling explanation. Really? I thought it was stuttering. I've only called it pull max. Yeah, that'd be kind of cool. So essentially max pooling is, if you imagine that it's in 2D, because I think a 2D explanation is easier. Actually screw it, let's just do 1D. Maybe 2D is more like intuitive, I don't know. Typically for like when you're dealing with images and stuff, convolutional neural networks especially, you might have something that's activating really strongly here and not very much here and not very much here and not very much here. And then it wants to go through, you want to go through a max pooling layer to reduce it to only one value. Typically you do max pooling because you want to reduce the number of values that you're dealing with, because it might be really, really slow if you want to connect it to like a huge layer afterwards, because you have to have connections. You know, for example here, if you wanted to connect to 2 neurons afterwards, well, you'd only need 2 connections here. Whereas if you didn't have the max pooling, you need 1, 2, 3, 4, 5, 6, 7, 8 connections. So all this does is take the maximum one, the value of the max neuron. That's what max pooling does. And it does this for like every 1 in X neurons, for example. I think. I'm still not super familiar with max pooling in a 1D setting, which is what my thing is. I'm just dealing with it in 1D. Not normalized, it's literally just take the max. There are other ones as well. There is something called average pooling, for example, which takes the average of all 4. Anyway, yeah, this is the middle layer. So this one's really wide because it's coming from a 256 wide thing. And, actually it's 328 actually. So it's coming from one that's 256 wide. Oh! It's coming from one that's 256 wide, but then there's extra stuff slapped on the end. I guess this is related to the max pooling, but I don't really understand how that works. Anyway, the height is 56 because it's going into the 56 neurons that are in the middle layer. That's what makes up the actual encoding. I'm a bit worried about some of these really, really bright neurons. I guess they never really got... Either they're like really overused or like underused, question mark? I hope they're not like wasting a lot of dynamic range that I could be getting. Because effectively the weights themselves are going to have to be quantized to 0 to 255, 8 bits, because that's the format of a texture, right? In Unity, 8 bits. So I will make the texture with compression disabled in Unity, but it's still only going to be able to do 256. Actually, is there an image format that can do 32-bit float per pixel that Unity supports? That's the key part. Because that'd be so cool if I could get the actual values of the neurons out. I don't think so, right? Like, is there a native 32-bit float per pixel or texel, I guess, for Unity? And you know that a GPU can use? Thank you for the positive check and hydration. I think I'll finish off this decaf coffee. It's so cold. For the unrelated question, but why does the decoder have to be implemented as a shader? That's not irrelevant at all. That's actually what the stream was originally going to be about. Or working towards. And pussy check as well, yes. Yeah. Came to a line of pixels. Calls it linear because... Oh, I already read that, sorry. It accumulates linearly before the non-linear activation. Right. Yes, that's true. It does add everything up before it goes through the tanh. Unity does support EXR. Okay. Hope it's not going to be too slow on the CPU. I've lost connection to chat. Oh, I'm back. What was I saying? Oh yeah, right. Because the reason Sea of Tranquility is because I'm wanting to build this onto a VRChat avatar. just the decoding stage, so that I can essentially, just as a gimmick, just a purely nerdy gimmick. There's not any like practical use for this really, but it would allow me to upload effectively, share, display images, any arbitrary image, in VRChat to other people, like essentially making my avatar a kind of monitor that can show anything, but at a very, very slow speed of like 1 image per minute or so. Anyway, yeah, that was going into the middle layer, and then the decoding layers come out of a thin one into a big one, out of a big one into a big one, and there, out of the big one into a small one. Wow, this one looks really different to the others, doesn't it? Wow, this looks really interesting. What the hell? Ah, I guess the reason we're seeing more structure here is because this output, this is the output layer. So reading from top to bottom on the y-axis is the actual pixels that are coming out. So there's like some actual spatial relationship now, you know? These are the actual pixels you're going to see. So like every 3 of these is red, green, and blue of an actual output pixel. That's so interesting. You can start to see like it's not just pure noise anymore. There's like clearly there are little darker lines now and little brighter lines instead of just darker pixels and lighter pixels. That's so cool. Can't wait to watch the entirety of Shrek in VRChat at 1 frame a minute. I have to implement an audio decoder first somehow. I don't think that's possible because of what VRChat makes available. So what I actually planned to do this stream, what has actually just turned into like a nearly 2-hour-long TED Talk about neural networks. Oh, I've got to be quiet as well, actually. Sorry, it's been so long, people are coming to bed now. Hold on, I got to quieten down. 1 sec. Look at the time. It's 10 p.m. Hold on, 1 sec. Going into quiet mode. Oh, my. Just glanced over. Everything says tab crash reporter on Firefox. Nice. 1 sec. Adjusting audio settings. There we are. Okay. Now I can be quiet. Are we making missing though? No. There's no way to decode using the CPU. Unless you can implement CAN-H in Unity animators, and you'd need to do that for well, how many layers of an animator would you need then? 65,536 layers of an animator plus what was the last one? About 110,592 layers of an animator? No, there's not. And like a GPU is designed to do a lot of parallel stuff that'll make it fast. However, what I'd like to do first is do this on the CPU, not in Unity. So what I'd like to do to make sure that I understand exactly what's happening before I go into trying to do this on a shader, which I'm much less familiar with, what I'd like to do is try to make a decoder in C that uses these images right here. So these weights and this image. So I want to just basically try to implement the decoding stage of this neural network by hand in C. That's what I plan to do today. And if that works, then I can be sure that I know what I'm doing and I have a better chance of it actually working when I come to do it in the shader. So that's actually what I planned to do today. So let me just... Because right now everything's being done in Python, in PyTorch, which is like, you know, designed to make everything easier and like, you know, just a few lines and you don't actually need to do any of the maths and the logic. But yeah, PyTorch supports browser, meaning you should just rip its WebGL shader. What? I mean, the shader has to do a bunch of other things as well. I can't just send all of this data at once. So the shader... Okay, guys, I haven't explained this either. But essentially, the only way that I know of to remember something from one frame to another in VRChat is through a kind of gross little hack where you have a plane, like a 3D plane, with some texture on it. Blah. And you have a camera like this. And the camera is looking at the plane. And this plane is using a shader, right? Like this. Blah, 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 blah. And this shader has, as input to it, the view of this camera. So essentially, this shader is getting its own output fed back into it by the camera on the next frame. And it can choose to just show the exact same output, or it can change some pixels, and then those pixels will stay changed the next time it's read. This is like a gross way of doing it, but it is a thing that some people do. And it's, so this would like be an orthogonal camera, so it's like perfectly aligned and stuff like that. It's stupid, I love it. I know, but it's yeah, this is a silly hoop to jump through. But yeah, essentially, because we're not going to be able to decode the whole image on one frame, it's just going to come in, it's going to come in every 200 milliseconds or so. The other data that's coming into the shader is going to be like all of the animator stuff, like basically the avatar, like the what have you called it? Animations? I have a graphics tablet in front of me and I'm trying to use a mouse to draw on paint. So some of these animations the animations will control sliders effectively on the avatar, like values, and some of those values will say like the position to draw at. Like one of them will set the position left to right, and one of them will set the position like top to bottom. And then so it might say, hey, you need to decode what these other neuron sliders are set to and output to this position. So every 200 milliseconds, it should be drawing a patch somewhere on here. And I was originally intending to just go in a loop left to right, top to bottom, but it could go in any order. It might look kind of interesting if you just see it coming in and patches, you know? Almost like an interlaced PNG or something. PyTorch TensorFlow browser implementations of fragment shaders. That's fancy. Yeah, these are going to have to be fragment shaders as well. Can't do compute shaders on an avatar. The thing that came to mind with this is having a Polaroid camera. Well, then you take a photo of the photo, right? But you just change a tiny bit on that photo, and then you take a photo of that photo with the tiny bit changed, and you change one more tiny bit, and you take a photo of that. Unfortunately, there's going to be a lot of degradation with that, but they shouldn't be doing it this way. So a friend of mine who I've mentioned several times before, this same person who I mentioned last stream, I think, Emimin, I'm not sure if it was last stream or not, who's made a bunch of VRChat worlds. She, on her avatar, has, like, I'm not sure if it's a main avatar, but she made an avatar that does this. She has, like, a whole load of butterflies that can fly around her, right? And this is actually a fragment shader, or a vertex shader, that's moving these butterflies around, which is pretty cool. But it needs to remember where a butterfly was on the previous frame, so that it moves to a position on the next frame that's a little bit further on, right? And she used this trick of a camera that's looking at the output of a shader that's, you know, this feedback loop. Bye, Mogadek! Thank you very much for being here. Have a nice sleep. And in the case of this shader, the values that it was looking at were the X, Y, and Z positions and rotations for every butterfly. So it's so cool. butterfly knows where it is, but it knows where it isn't, and
Jeez.
subtracts it from where it is. Kind of. Hi, Psychic Salad. Another way of doing that is valet integration is stateless. Oh, also, she can change the pattern of the butterflies, by the way, at any moment. So she can change it to like different shapes and animations. So spiraling around, and then to like scattered or something, and they can come in and stuff. It's I think one of the other, yeah, I can't remember exactly, but there's like multiple different shapes that they can like flocking patterns that they can change between. It's pretty cool. Yeah, I think there was a way that she made it so you could see those planes as well. I think there's some way you can do it so that it won't be affected by the post-processing of the world, because that's going to be a big deal. You can make the shader be an unlit shader. That's super easy. And that way it won't be affected by lighting, but there's still post-processing that's done in VRChat worlds, like color grading and bloom, and some other things on more obnoxious worlds. I'm not sure if I guess you can maybe set the layer of the camera or something, and the plane to something else so that it won't be affected by post-processing. I don't know exactly how to do that though. Maybe UI. Maybe the UI layer or something, because that... Oh no, because then you'd be able to see it on the UI, wouldn't you? Oh my god. I'll have to ask her how she avoided it being... Or maybe it is affected by post-processing. I don't know. Anyway, let's close a bunch of things that are open and don't need to be open anymore. Yeah, this is for... using this and setting it up again. Let's hope I never have to set this up again. Hi, Kinami! Would you believe me if I basically have been explaining what I'm going to be doing for the past 2 hours and I've just finished? How's the Kinami? Thank you for the pants. No worries, no worries. Essentially, I have made a neural net that can compress images. Something like this. No, where's one where you can compare things? This one. Very low resolution. Well, not very low resolution, 256 by 332. This is the original image. This is the best possible way that it can encode it. And then these are versions where the encoding is being quantized to fewer and fewer and fewer and fewer bits per pixel, all the way down to here, where this is effectively 0.8 bits per pixel. Is what it works out to be. Because as you can probably see, it's encoding in 12 by 12 chunks. Anyway, and the reason for doing this is for making a gimmick VRChat avatar because I think it'll be a fun idea to be able to have an avatar where I can effectively upload an image or share an image that people can see. Thought that was called test on file. Just encoding streams. Programming streams are actually just chatting streams. They are. Let's begin doing it. Let's begin the actual programming part. So right now I'm wanting to implement the decoder part of this, which is currently being done in PyTorch. I've got the weights of the neural net extracted, like this. And yeah, I want to try to read in these and use them as weights. The decoding part of the neural net is as simple as I could. Well, I made sure that it was simple. That's possible to implement fairly easily, hopefully. Now I have made a neural network in the past in C, but I'm gonna that was one that I made. I designed, like I intended it to be like it was an excuse basically for me to use simd instructions to make things really fast. I'm not going to use simd instructions for this. I just want to do the bare minimum necessary to get this to work. Also, hi Cabbage! Hi! You have an encoder network to encode it to some intermediate compressed format and have a decoded network to decode it at runtime. Yes, basically. It's all implemented in one network, but yeah, I can like inject the encoded thing into the middle of it or take out the encoded version from the middle. So effectively it's like, yeah, 2 halves of a network. And I will just use the encoding half in the end, and the decoding half I will eventually implement as a shader in VRChat. But before I do that, I'm going to try to implement it just in C, because I want to make sure that I am correctly understanding everything that PyTorch is doing. So if I get it to work in C, then that sets me up better, you know, for starting to do it in HLSL eventually, which I'll probably need Stu help from if Stu is interested. That's in a long time and probably is never going to happen. Let's just see if I can do it in C first. So, where is Visual Studio? I see, if you're using C to see if it works. Exactly. Inject my... No, you can. Alright, let's make a new project. Any day now.
It's been a month already, Dan.
What the hell? Holy crap. Thank you very much, Perry. Or Perry Winkle Tinkle, because it's very fun to say your full name. Thank you for the resub. Also, hi. I guess by the end of the C implementation, it'll be more obvious why PyTorch is calling the FC layers linear. I mean, I already have made a neural network that is the same type of network as I'm using here, but with different activation function, sigmoid instead of 10H. But I don't want to reuse that because it's big and bloated and I don't have a good way to load weights into it and stuff, so I just want to... I wanna do a minimal thing. I know that it's... I guess it is called linear, as someone said earlier, because it's adding all the things up. Anyway, let's make a console a console? Well, yeah, let's do console. Let's not try and make a goddamn GUI again. I'll just have it write out a bitmap and or PNG, and if the PNG looks good, that's good. What do you want? Console application. This one, right? Console app, C++. Yes. Why is it saying C# here? This is what I want. Where is this? Wait, can I just double click this? Oh, I can. Okay. Don't put in this folder. I've literally never put a folder there in my entire life. I swear to God. And this is going to be called image AE decoder, I guess. Boop. PS 2019 because of Unity? No, it's because it's the only version that worked. So when I tried 20 something else or something newer, I don't know what version it was the newest at the time, it couldn't make a new project, it just froze. And it couldn't load a project, it just froze. So I thought, wow, what a great first impression. Guess I'll uninstall this. Let's try 2019. And it just worked. So I've stuck with the thing that just worked. Thanks for going to my TED Talk. So it's actually going to be C++ rather than C, but I'm going to mostly be using C. Myriad! Hi! What is a terrible time for my chat to lose connection? No, I can't read anything. Okay, it's reconnected. Hi! Welcome in there, Minimum. Welcome. Hi, welcome. Shout out Myriad Minds. I'm gonna see what you're up to. Let's mess around and go. Well, what kind of stuff were you messing around with? Was it related to your avatar with the cool flowy tentacle notification things? That was not your avatar, that's your streaming setup, but whatever. Thank you very much. Hope you had fun. Wait, that wasn't cheese being thrown at me. I've been so conditioned by when I see a thing pop up to have cheese thrown at me after a shout out. Oh no, it's the derpy Yuke eating a burger. God, I wish I was that derpy Yuke. Who the fork is Ted? I don't know, but he talks a lot, I've heard. Thank you for the posture check and the hydration next year. 1 sec. Screwing around, trying to make destructible cubes. I see. Do you want cheese? No, thank you. stick with things that work. Wait, stick with things that work? Well, I hope it was successful, Myriad. I've literally just spent like 2 hours explaining to everybody what I'm going to do. And I'm finally starting, that's why I have a blank screen. We need some cubes that can be destroyed.
Destroy the cubes. Waha.
So yeah, I made a thing that can encode an image to a small size, like this, the original, the best possible encoding, and then quantized, so like reduced bit depth 6. This works out to, what does it work out to? I need to look at my other image. I'll do it with this image. 4 bits per pixel, 3 bits per, 1.6 bits per pixel, 1.2 bits per pixel, and 0.8 bits per pixel. The top one is the new way that it works. It works by encoding each in chunks of 12 by 12 pixels. Can you explain how this works? Sure, my VOD will be up. Do you want cheese with your burger? Inside the burger would be nice, but please don't throw the burger at my face. I'm just trying to work out all the different ways that this could go wrong. So now I'm going to try to implement the decoder part from PyTorch in, I swear to God, Blep, I swear to God. What, you going to explain it again every time? Well, don't worry, this is a super squashed down version. Okay, I'm gonna copy all of these. Actually, I might as well cut them and paste them into... Boop. Boop. Let's put these into weights. So these are these pixels represent the weights of each layer in the neural network. And the biases. And yeah, okay, so first of all I need a way to load in images, and I am going to use the same thing I use every single time when I'm dealing with images because I love it, and that is FreeImage. I'll copy this over here as well. And FreeImage DLL files, and the lib files, and the include files. So just FreeImage, yes it is. Squimshed version. Okay, so I have to do this thing now, which in 2024 or 2019, I guess, was way too hard for it to do. Just automatically add the files that are in the folder to the end of the thing. So I have to manually type it every time because this is, you know, the pinnacle of the C experience in current _year. So include directories is inc, and where's the linker nonsense again? Additional library directories, lib. Additional dependencies, I add the FreeImage library. Is it FreeImage lib and FreeImage plus? I guess it's both, huh? Is this how it works? No, hang on, so I need to change, there's one more thing I need to change, which is I have to add something extra to the end of screw it, I'm loading the project. The other project, I'll just copy and paste. I was trying to do it off by memory, but nah, it's gonna take too long. As soon as Visual Studio loads, that'd be great. Let's do this. Then go into top right Python Uke C++. Oh yeah, right, finally I can change that off Python now, right? This thing which I totally had a logo prepared for. Boop. Okay, thanks for reminding me, Kinami. Okay, so the linkma. Oh, you do just do lib. Okay, that is what I did. Oh, I did it this way, huh? Da 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 lib and blah 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 blah. Wait, why is it only 2 things there? Whereas on here it's like 1,000,001 different things. The fuck? Why does this one need all of this stuff? The other one doesn't. Why is it constantly making me look like I'm frowning as well? Okay, well, we'll see if that works, I guess. Knowing you, you'll soon automate the thing in the top right if she opens a project and it's in Python. I've thought about that for like a long time. I kind of wish it did work. How do I get to the code? Boop. I guess the one standard IO as well as standard int. I don't need IO stream. And that's it. Boop. Nope. Yeah, I had thought about making it automatically switch to like the game, you know? But yeah. Okay, let's see if we can load an image first. Oh my god, Bleb, please. Okay, this one's the only one I need. So let's see if we can load weights. So we'll just try to... How do it again? Free image. Oh, we gotta do free image underscore initialize. Let's see if that even works. Boop. Or if we're gonna get link errors or files missing. If it works first time, this might be the first ever time that it's worked first time. I mean, it worked. I also made my audio stutter for a sec. Just so that we actually get to see it working. Ta-da! It's running. Let's see if we can actually load an image. So we're gonna try to load... Well, we don't need the encoder layers at all. I'm gonna delete these encoder layers. And the middle layers. We only need the decoding layers and the output. Okay, so first of all we'll try to load this one, I guess. Let's make this a standalone function. It's gonna return the... That's great, I'll hardcode it for now. This is just a test to see if it works. For me, I would spend 3 weeks trying to automate it, have a solution that almost works and then abandon it and do it manually forever. Well, I just did it manually forever anyways. Take my eyes off you for 5 minutes and you run off. Oh no. Myriad, please take care of yourself as well. I need to say that. Okay, let's try this. Let's go ahead and make a free image and scroll load. This weights / this. Oh wait, that's the file name. Oh god, okay, fine, I will make this its own thing.
Oi, jeez.
Ah! Let's make it return a image bitmap. Load image. And it's gonna take the file name and it's gonna simply return free image load. 1 second. What is it? FI free image get FIF from file name, sure. Wait, wasn't there a way to get it from the actual contents of the file as well? Free image get FIF from MIME. Then you pass the... Oh, that's not it either. From what was it? From format? Yeah, no, that's not it either. What the hell? What did I do on the other one? I forget. Get FIF...
Take a look at the yolk. Scrunchy yolk. Fluffy yolk. Pat pat. Smimish.
Thank you. We destroyed too many cubes. The police is onto me. Okay, here we are. This seems to work. This returns a free image from it. File name. Okay, there we are. That's what I'm trying to do. What's the problem with this? Oh, right. It returns a pointer. Huh? Huh? What? Okay, never mind. It was just complaining for no good reason. Okay, so let's make a thing, which is a pointer to a bitmap. Let's call this DIB. Thanks. Let's call it layer decoder 1 weights equals load image this, and then let's just try to printf the weights. Let's say loaded bitmap handle %d option p, I guess, and a new line. Okay, let's see if this works. So if we get something that's not like 0.0000000 or something, then I guess this is working. The enum type free image format is unscoped. Oh, not this nonsense again! How do you do this shit again? Hash pragma 1? Is that what it was? Suppress 1 or something? How the fuck do you do this again? Oh my god, I can't believe I'm gonna have to do this every single time. I'll just copy it from this code. Oh boy. It's spooky. Here's a spooky face to go along. Main does not belong. Where is the pragma thing? Why is this empty? Where's the H file? Oh, here it is.
Jeez.
No. Oh jeez. Pragma once. Where is it? Pragma. No.
Cheese.
Stop. Where is this crap? How do you disable this nonsense every single time? Send music, nothing, OpenGL test? No. Rhythm spec? Rhythm spec I might use free image. Yes, I am using free image. There you are, I'll go in nonsense. I don't know if we're gonna need 4996, I'll just have it there, in case. Sloppy chairs, no! Pragma bowls! Dash 1. I don't know. No, it's just a specific warning I want to get rid of. It's so stupid. It's because... I don't know. There's no excuse. I guess it's because it doesn't like that in C++, even though it's fine in C. Anyway, let's have a look and see if we can load the image. Boop. Would you look at that? We loaded a goddamn image. And we never unloaded it. Whoops. Alright, that works. So I think I'm gonna make a function to load the image, read every pixel as like, you know, the grayscale values. Enum class is preferred. Oh, I hate the way everything's a class. Yeah, and just load it into an array, a float array, and the floats will range from this value to this value, which yes, I will hardcode for now because I'm a terrible human being. So let's call this load image to array. So we'll pass in the file name. We won't return this immediately. We will return a byte array, and we'll just store it here, and we'll unload it. Free image unload gimmick, and this is going to be a uint 8t. Not this is going to be the actual weights. Okay, and now we need to actually do something. enum class in C++ doesn't clutter the global namespace like regular enums. Okay. I'm fine with these though because they all begin with fi underscore and stuff. I wrote a thingamajig to allow me to have an enum class that is a literal class. What? I'm still quite a noob when it comes to classes, just in general. What am I trying to do again? Oh yeah, let's initialize some. So I'm gonna copy over my easy alloc and easy free things. Did I use them in here? I'm not sure if I used them in here. No, probably. Or did I? Easy alloc? No, I didn't. Performance counter test, you exempt. Where did I use them recently? I know I used them recently. It bothers me that I'm having to look so far back. Oh, music DLL maybe? Or did I make a separate folder for them? No. I don't know where it was that I made them. Let me just quickly search the contents of these files, one sec. Downloads, risk, yes, okay, switch view temporarily. Okay, it's safe again. I mean, it was never unsafe, but I thought it might be. And we can search for easy alloc. Oh my god, it's gonna take a while, holy crap. Boop. Off it goes. We can limit it to CPP files now. Boop. That's a bit better. Okay, the most recently used was... Wait, I used it in performance counter test? Oh, right! Perf counter test is something else from what I was thinking of. So I also made a program that I don't think I ever showed on stream called to test getting information from the Windows performance counters. Not the performance counter, which is a different thing, but the performance counters, which are like a way to access statistics about the, or information about the Windows currently running. 5 years later I'll be able to show you. Oh my god, my computer's grinding to a fucking halt just trying to load Visual Studio. Boop. 5 years later. Ta-da! I was thinking of having this stuff, be displayed on like actual physical gauges somehow. Let me just freeze it. All of this stuff. So this stuff is like all GPU related, and then there's the CPU usage, some memory access statistics basically, and upload and download, or download and upload actually. Speeds, which is pretty cool. I was thinking of having those be displayed on maybe my long Uke circuit board. Yes, physical, but also maybe in Unity. This is a thing where it's a bit annoying about being a VTuber who actually likes electronic stuff as well, even if she's not good at it. Finch. Yeah, anyway, apparently in here I used... X! Hi! Welcome, welcome! Hi, how are you doing as well? Thank you for the raid. Exodrifter underscore. Let's find out what you're up to. What are you up to? Working on your game. 2.5 hours. Yeah, for those who don't know, Exodrifter is making a game. like an actual game, like an actual thing that's actually going to be actually on Steam actually, and in Godot. And how did it go? Welcome in everybody. I am on a tangent of a tangent right now. I'm very sorry. I'm gonna get back to it. I promise.
Pat, you smart cat.
No. Ah! Oh no! I turned into Skippity Toilet for a second. Or just a long nuke, I guess. Where did I put my easy out and easy? Where is it? Easy out there. Yes. Okay. Where is it? Oh, I moved it into its own file. Oh my god! I actually did a good thing. What the hell? Yeah, thank you very much for the raid. Why is she looking back at her tail? Yeah, Exo, if you have something you want to show off, feel free to DM me. One second, I'm not sure which screens are going to appear on. I actually realized I forgot to test something before I started streaming. Oh my god, a flipping... No, that can't be right, because my bandwidth was low. My upload speed was low. My download speed was low, sorry. Give me a sec, I'm just doing all the things I should have done before I started streaming. Clicking every single thing, making sure it's on the right screen. Exit, minimize, minimize. Blah 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 blah. Close Photoshop. Why the hell's Photoshop still loaded? I loaded it for something. Anyway, yeah, if you have something you'd like to share, you could put it in the media share channel on my Discord, and I'll share it if you want. On stream. Regarding the your dev stuff. Also, I've lost OBS. There it is. Okay, I'm going back, but I haven't put the right stuff back on the screen yet. There it is. All of above was slow. Wow. Also, Exo, take care of yourself, please. Please. You don't have to stick around if you don't want to. Uke. Oh yeah, easy. Wait, what's it called? Where is it? Oh my god, I can't find the... Ah! Uke easy alloc.cpp. Huh? Uke easy alloc. It's right here. Why are you expected a file name? Hello? Why is this like running at a snail's pace? It's just not even realizing that I've typed something sometimes. Anyway, I'm not adding it into the... there we are. Into the project correctly because I'm coming both. Okay, so easy outlook. So we're gonna... we want a... You said bandwidth, then download, then upload were slow. Oh yeah, I mean, they are all slow. Well, download's not too bad. 100 megabits is perfectly fine, in my opinion, for myself, but our upload could be a little higher. It would be nice if my entire stream didn't die every time, you know, Ubisoft wants to update. Okay, so we want to return a handle to an array. Oh, that's a pointer to an array, which is going to be called, let's call this, what do we call this? Array? Vowels? Or vowels, I guess. Vowels. Data bytes. What do you even call it when it's literally so generic that it could be anything? And then we easy alloc that. So easy alloc is just a wrapper that I made, where all you need to do is pass in the pointer and the number of elements that you want, and it automatically works out what the data type is, does the size of on it, and that stuff. Send to media share. Okay, let's have a look. It's getting the game ready for a public playtest. Ooh, okay, that's exciting. there's a title screen now and a bunch of sounds. Tanuki is taking it to an event in Ottawa right now. Right this moment actually to get it play tested. Interesting. Nice. Wait, hang on a second. Let me reread from the beginning. There's a title screen. I see. Version 0.1. A playtest on version 0.1. Interesting. Is this like... I can't quite tell. I thought that was like some dithering at first. Which interests me. Really caught my eye. Hi, small block boy! STM shut down the other parts of the station because of declining funding. Your card! Oh no, never mind that. I was gonna put a stupid effect on my voice, but I couldn't decide on one. Now the moment's passed. Your card, any of ours really, won't work. Welp. Nice. Holy crap, that's a lot of drives. I mean, it's not nice that your card won't work. That sounds fun though. That is made in Godot, yeah. But yeah, hi small block as well. I hope you're doing alright. It's a bool? A bowl? A bowl? The music. Oh yeah, right, the music is still this, so I should change it. Okay, so how big does it need to be? So, let's get the width. Let's just get a bunch of things. UN32T. Width. It equals, free image get width. No. Did I ever type diff time? I typed DIBK. There we are. The height? What the fuck is diff cur anyway? It's not a variable I've made in this thingy yet. Is it just using variables from past projects of mine? Height. It sounds like something I would name, but I would have it actually have capital letters. And this is gonna be numbytes is gonna be width times height, and also we need we need to know the what's it called, the pitch, right? The pitch of the image, I think it was called, of the bitmap. Let's load up my favorite docs again on the correct screen. So I think it was called pitch. Get pitch. Returns to the width of the bitmap in bytes, rounded to the next 32-bit boundary, because each scanline starts with a 32-bit boundary. So, okay. So essentially, we need to copy the image. Wait, actually, first of all, we want to force it to be grayscale. Because I'm not sure what format it loads in, but, well, let's actually, you know what? Let's check tweak PNG. Let's see what format OpenCV, the Python library that saves that PNG file, saves it in. Let's have a look. Tweak PNG. Let's do some spying on the internals of these PNG files. Mwahaha. Zip. It is 8 bits per sample grayscale. Okay, it actually is grayscale to begin with. Nice. But I feel like, numbytes, yes, it would be. But I'm assuming grayscale, so I want this to be grayscale first. So I'm gonna force this to be grayscale. Equals free image, convert to grayscale. There we go. Let's call this DRB temp, I guess, or DRB new. Actually, this is FI bitmap star again. What is going with capitalization right now? And then we'll free image unload. DRB. I swear to God. DRB new. And free image. And then DRB cur. equals, sorry, not we unload the old one, and then we consider the old one to be the new one from this point onwards. Usually I wrap this stuff basically into a function to like replace an image. A for example, I ate mine in 1 bite. I have to go cook food, but I'll be back later if you're still streaming. Yeah, no worries, have some nice food. Thank you for the raid again. Welcome. I should probably have introduced myself. I'm a strange cat, and I made an autoencoder for images, and I'm trying to implement the decoder part of it manually in C right now, so that I can eventually implement it in the shader to use in the VRChat avatar. Looks like this. This image up here, this top right one, and also this one, but this was before I made an improvement. But these two on the far right are an equivalent of 0.8 bits per pixel, which I am extremely happy with. I don't know if I'll use a compression that high. I might use some where it's not quite as high, but anyway, fun stuff. Thanks. Look, you might ask, how can it be less than 1 bit per pixel? Because it works on a chunk of 12 by 12 pixels, and the equivalent, it works out to be that if you divide it by the chunk size. Okay. I'm actually gonna make a function to do that. UNAT star, no, fi bitmap star. DIB replace. Yeah, I did not make this. Oh, actually, yeah, let's do it this way. We'll just do it this way. It won't return anything. It will just modify this. So what it will do is DIB new. So first of all, we're going to set DIB. No, first of all, we're going to unload DIB car, and then we're going to do this. But we're actually going to be modifying the thing that's stored there, and blah blah blah, and that should blah 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 blah. Yes, okay, nice. Now we only need to do this. So these three lines can now become one, like this. Ta-da! Oh, I have to pass it like this. Okay, so improperly terminated macro invocation. What? Oh yeah, right, I haven't finished yet. So the number of bytes is what I want. I guess we'll if this is, yeah, we need to make sure this is not null first, I guess. So if this fails, does this return true or false if it fails? Returns whether successful. Okay, so true if successful. So if not easy alloc, then we'll just return null pointer. Otherwise, we'll go ahead and actually try to store stuff in it. Okay, width. So we'll say width in. Let's call it. Okay, let's literally just call it pitch. Free image get pitch. So this is width as visible when viewing the image, and this is width as stored in file. Might have some padding at end of row. And this is, yeah, stuff. Oh! one important thing, actually. I wonder... I think images were stored bottom to top in free image. I'm not sure if the same thing is true in CV2, OpenCV. So I think I might also want to flip vertically. Free image, flip, vertical. I think this works in place. Why does it keep doing that? Luke, when will you take a burger break? I don't have any burgers! This is not a thing I keep on hand. Or, you know, in freezer. Or fridge. Oh, it looks like my chat has lost connection. Oh no, it's back now. Bones and tops are reversed. Yes! I know. No! So what is the best way to copy this memory over? I guess it would be using the memcopy function. I wonder actually if that will always be faster than copying byte by byte or not. Because for the small images, like or the really narrow ones, like this, it's gonna be like a huge waste of time to do like a mem copy for a single pixel, right? But for the big ones, like this, in one command copying 256 pixels, that will probably be faster. Sometimes Y is top left, sometimes bottom left. I hate it. Yeah, well it goes back to bitmaps and how they were stored in memory historically, and for bitmaps at least. They're stored upside down, like the BMP file format. Meme copy. Nice. Okay, honestly, screw it. I'm just gonna do... Hi, Kakadi! Welcome! Hi, I'm waving with both hands. I always wave with both hands, but it very rarely sees both nowadays. I think I'll just do memcopy. For... int y equals 0 to height... Sorry, this is... not to be me. un32t and y equals 0. And y is less than height, and y plus plus. I've also been using Python recently, so I'm all messed up with the stuff. Easy a look. Or is all you GP? Wait, what is GP? Grey Peacock? Grayscale Peacock? Got 40k miniatures recently and he named the captain of a tank after you. What the hell? How cool is that? That's so cool. Meme copy. Where do you get the code from Reddit's backend? That sounds disgusting. I don't know, does it have anything to do with Reddit's backend? Wow, that's cool. I'm honored. Man, I hope I can get, you know, my head back together to be able to play distance again. Okay, so we're just gonna mem copy into the destination. Okay, I need to keep track of... Why am I being clapped? Oh, for getting a figure named after me or captain named after me? Okay, let's have one which is the... I guess I can just call this UInt actually. Not care about... Oh wait, no. No, I would need to type. Wait, was it size T that you use? Yeah, okay, let's do this way. Thank you for the posture check and the hydration. That's great, I'm just gonna use this. This will only work for images up to 2 gigabytes in size, but I think it's gonna work. The gunner got named Cereal. Nice. Was Cereal the one who was giving out all the gifted subs, if I remember rightly? Like gunning people down with gifted subs? This is It's a pretty good name then. So we have an index for the pixel, and also it starts with 0, and an index for the data, which starts with 0, and these are not going to go up in the same speed. We're going to copy from data. Oh, actually, you know what? We'll just have a pointer to. This is data byte cur, which starts as this, and then a pointer for the current pixel, which let's just call this. Let's name it this way actually, and this is gonna be current pixel equals free image get pixel. What's it called? Get pixels? No, it wasn't. Get data? Get bitmap? Oh, get bits? Is that the one? Get bits. Turns the pointer to the data bits to the bitmap. Yep. Define meme copy free. No! I was like... sorry, this is a pointer. Why am I... So... we're gonna copy destination into the current data bytes position from the current pixels position. The number that we're gonna copy is width. And then we are going to increment cur data byte by the width, and we're going to implement cur pixel by the pitch. Ta-da! That should copy them all over. Then we unload the original image, and we return the data bytes, the very first one, not wherever this ended up, which will be on the last row. It's quite a nice function, actually. I quite like this. What are you making? Thank you for the pants, Neil. I'm trying to implement the decoder part of an autoencoder. So basically like a neural network that encodes, like compresses something. In this case, an image. So I'm trying to make something that decodes an image, basically. I've already made it in PyTorch in Python. Is it still loaded? Yeah. But I'm wanting eventually to implement it in a VRChat avatar as like a gimmick to be able to very, very, very slowly share images over VRChat through the limited 256 bits that VRChat lets you use on your avatars, only updating 5 times per second. And yeah, that's why I need it as a way to like compress the image way down. And yeah, I want to eventually implement it in a shader using uninitialized memory data bytes. Oh shit, whoopsie. Now how long does it take to realize? Yeah, so I'm trying to, like, eventually I'm going to try to make a shader to decode this, but I'm wanting to make sure that I understand what PyTorch is doing first. So I'm trying to just make a program in C to decode an encoded image. Oh, right, I want to... So this is loading an image to an array. So this is to... This is going to read it as a byte array. But actually I want it to be a float array. And you can... FreeImage does support grayscale floats. So let's do that as well. And then I'll scale the floats afterwards, which I will have to do one by one, which is, yeah, sucks, but means there's probably not much point using memcopy at that point. Yeah, that sucks. Okay, so DIB car. I'm going to do free image, convert to F, float, convert to float, is that it? Let's double check. Convert to, where's the, that nice table? There it is. So convert to float is this yellow one. So whenever we are... Okay, convert to float. The input is first converted to an 8-bit grayscale, and then that becomes 0 to 1. Yes, okay, that's exactly what I want. Wait, it's first converted to 8-bit grayscale. So I don't even need to explicitly call convert to grayscale. I don't even need to do that. Huh. I mean, I guess there's no harm in doing it twice. Done automatically by free image convert to float. Okay, but I then want to change the scale so that it's not ranging from 0 to 1. I want it to range from this to this. And if I were a real masochist, I would try to extract this from the string, but screw it, I'll just pass them in manually as extra options. So float, let's call this val min, I guess, and float val max. Wait, what are you complaining about? Oh, no, you're not. Okay, so this becomes the minimum. This becomes the... Oh, it's not even a max, it's a range. .png. Wouldn't you be able to add a load image link call to specified space for loading? Huh? Add a load image link call to... I don't know what a link call is. Or a load image link is. Specified space for loading in images. I'm sorry, I have no idea what you mean. I made a programming challenge at some point that was just a bunch of redefining everything to nonsense than the actual code. Nice. I approve. Encodema. Yes, hi Fartingle! Welcome! How are you tingling? How are you farting? This could be val range. Genesis! Oh my god, this copy paster.
I'd just like to interject for a moment. What you're referring to as Linux is in fact GNU/Linux, or as I've recently taken to calling it, GNU plus Linux. Linux is not an operating system unto itself, but rather another free component of a fully functioning GNU system made useful by the GNU core libs, shell utilities and vital system components comprising a full OS as defined by POSIX.
Holy crap. She actually managed. Also, hi Genesis. I'd just like to interject for a moment, just makes me laugh sometimes. I have a friend who just said that when someone was just talking about really nerdy stuff. Just randomly would just say, I'd just like to interject for a moment. Didn't even carry on with the rest of the copy pasta. Just that first sentence just became a meme. And it was very funny. But I have a strange sense of humor, so you know. Okay, so floats now. So this needs to be a pointer to floats. Let's call this data floats. And the pixels are in floats as well. Current data float. We're trying to allocate floats. Num bytes. This is now num floats. I could actually just call them pixels. We can keep that the same. Even if I change things in the future. Don't know why I would, but current data float starts as data floats. Current pixel starts as get bits for the DIB car, and this is actually a float pointer. What the hell? It's undo's behaving weirdly. Okay, so instead of mem copying, we're now just going to go into a loop because we need to work on every single pixel itself. So we'll do 32 and x equals 0 and x is less than width and x plus plus. And at the very end, we'll increase pixel by the difference in pitch minus width. In other words, if the pits and the width are the same, it won't increment it at all, and they'll just move along together. I swear to God, my hand tracking is so bad right now. So what we're actually going to do is the floats, and this is the float array, and this is a float star. So we're going to say that data, the current data float, moving on to the next one afterwards, is equal to the current pixel, moving on to the next one afterwards, minus the minimum. Wait, what's the problem with this? Wait, what? Expression must have integral. Expression must have integral or unsquared enum type. Expression must be modifiable at all value. Huh? Thank you for the patents. Hand not tracking. It's true. There's another copypasta about a guy concerned. But yeah, thank you very much for stopping by, Kakeri. Thank you for telling me about it. That's pretty cool. I need to stop by on Grayscale People's video again, stream. There's another copypasta about a guy concerned about how he can't find a girlfriend that cares about free software and rants how Netflix is proprietary. These are just fun. I see. Okay, so hold on a second. So this is fine, right? No, actually. Oh, wait. I need to get the right. I'm not trying to change I'm trying to change the value stored at that position. There we are. Wait, is this going to increment correctly? No, that's wrong, isn't it? We want the value of this. No, we do want no. Yeah, we do want the value stored at this position, later increasing this position. And then we subtract the minimum, and multiply the entire... Well, actually, first of all, we multiply the entire value by this range. And then we subtract the minimum. That should do it. Interesting how you find solace in TVP, which is not a common sentiment these days. So, yeah, I know. I feel... I don't know. I like... It feels cool to be able to more accurately control what's happening at a low level, or at least like have less bloat. Just work a little closer to the metal, you know? I guess the reason I kind of like it as well is because I started using it for Arduino stuff, which obviously is very limited in terms of speed and memory. And it's just cool to know that there are things that I can actually do to affect how things would usually, like, affect what's happening internally, have the same effect, blah 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 blah, low level, blah blah blah, something. Let's see if this works. Let's make a test image. The test image is gonna be 2 by 1. The first value is gonna be Actually, let's make it 3 by 1. The first pixel is going to be black. The second pixel is going to be white, and the third one's going to be hello. Sure, 127. And let's save that inside this folder. Test. And test weights. Test.png. Let's make the minimum be minus 0.69 and this one 0.42. And then I'll set a breakpoint and have a look inside test weights. Actually, no, that's stupid. I'll just printf it. There's only 3 values. Printf. Test weights. So what we should end up with is minus 0.69f first, because that's a black pixel. That is what I did, right? Yeah, and then 0.42, and then the value that's between those. Well, we'll see what it says. %f, 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 backslash. Alright, let's see. Boop. Welcome back, Exo. Oh my god. So we've actually ended up with this minus, I have no idea what this number is, holy crap. And then 0, and then minus another thing which I have no idea what is, holy crap. Alright, we're gonna set some breakpoints inside here, I think. Can I? There we go. Boop. Please survive, Exo. And please don't die from the spice. Okay, so int y is gonna go from 0 to 0. That's good. And huh? Wait, what? Oh, wait, it failed. The height turned out to be 0. Wait a second, why is it failing? Oh, because it's not even loading the goddamn... I think I should put some checks to see if this is even working or not. If it fails to load the image, then we'll return a null pointer. If test weights is null pointer, printf failed to load test image. Else. I don't like the ++y part of C++, by the way. It's the only thing I like about it is the way you can do the initializing of certain elements of a struct by name, but not necessarily all of them. And I think that was the thing that's only in C++, a late version as well. Yes! It's like, yeah, mostly. Yeah. C++ minus, yeah, exactly. Okay, let's see what happens now. C++, thanks for hanging out. Bye. Dude! It nearly worked. We ended up with 0.69. Oh, whoops, I'm subtracting min instead of adding min. Let's try again. Now we have minus 0.69, which is what it should be. Then we should have 0.42, but we do not. And then we should have the value that's somewhere between them, which it is. This is halfway between here and here. But this value here should be 0.42. Right, we nearly got it. We nearly cracked it. What vintage? I do not know, I'm afraid. Whatever version has what I want. I really like the shit, what was it? Whatever the compiler that the Arduino uses. Something, I forget the name of it. G something. something. Anyway, it has an extension which lets you do switch case ranges. So you can do switch something like 2.s GCC. It has an extension that lets you do switch case 0.5 : and then any number between 0 and 5 matches. Or from 0 to 5. I just feel like this should be standard, and when I learned that that was not part of the official C standard, I was very upset. And then I got over myself. You don't want to write them all out? No, right? Imagine not wanting to... If you just wanted to match some values 0 to 5, when it's type case 0, case 1, case 2, case 3, case 4, case 5, case 6, case 7, case 8. I would hope that behind the scenes it's automatically doing a less than or greater than comparison, you know? Larger than equal to and less than equal to, rather than actually checking every single one. But... Happy exo. Ah. I work plenty with Julia for data science, and the concept of opaque injections gives me shingles. In singles, and he said. Hope you're enjoying the spicy nudes though. Exo. Okay, so this value here has a range. You're watching a grade stream. Oh, I thought I read that as grade storm for a second. I was gonna say, oh wow. Wish I could be in a storm right now, but not like one that does damage. This one is visually and warily fun. AU. Okay, so why is this not doing what I thought it would do? Oh no wait, this is doing what I thought it would do. The range is 0.42f. That's exactly what it should be doing. This is exactly what it should be doing. This isn't a max, this is a range. So no, this is working already. Just being stupid. I told it to do a thing, it's done a thing. I think. Thank you for the posture check. And the pants. You're very kind though, Exo. A little bit confused by this. It's making me wonder if these values 0 to 1 are actually not ranging 0 to 1, but are actually instead ranging like the equivalent of 0 to 255 out of 256. In other words, 255 out of 256. Let's have a look. Let's see if the raw value, before we modify it, is this. Printf. Raw. That's just flipping. Who cares? Raw value. Percent F. New line. The value of current pixel. What's wrong with that? Nothing. Stop confusing me. Boop. Hi, Lane. No, it actually is precisely 0 and precisely 1. Okay. Oh, right. Because you can't precisely have halfway between 0 and 255. That would be 127.5, so it's slightly below that. That's why we get this. Okay. Let me just double check that 69 minus 42 is indeed 27. And half of that range is 13.5, and then 69 minus 13.5. No, wait. It's minus 69 plus 42, so that's like 69 plus 6.69 plus 0.42. Right? And then half of that. No, that's not right either. What am I doing? I want to get the range from 0.42 minus 0.69 negative. Wait, that is correct. and half of it is this. And then to get halfway between these two things, you'd want 0.69 negative plus this. Which that is not. Am I being really stupid here? I think I'm being really stupid. Oh, not again! This is the range, not the max. How many more fucking times? I'm bamboozling myself so much. One sec, Lane. Hi, Lane. I'll explain in 1 sec. Right after I finish being an absolute idiot. There we are. That's yeah. Okay, so it seems to work. At least it works for a single row of values. Not sure if that works or not. Hopefully. It probably always will, right? Because I think it was if the new row starts on the multiple of 32 bits and floats are 32 bits, so the pitch and the width, that is like width on screen and width in memory, are probably going to be the same. There's probably going to be no padding, but just in case, we're doing that. Okay, let's try and make it load the full size one now as well. See if it crashes or something. We'll just show the first 3 values. Boop. It crashes, nice. Well, Lane, I've made like an autoencoder in PyTorch, which is a thing that basically tries to compress something that's put in. It's a type of neural network where the input, it tries to aim for the same output as the input, but it has to go through a tiny bottleneck in the middle, and then you can yoink from the middle and say, hey, thanks for the compressed image, sucker. And then that is the compressed form, and you can put that back in and say, now decode it, sucker. Or you can just be polite, but I'm really bad at being polite. Which can compress an image down to the equivalent of like 0.8 bits per pixel. Which would look like this. Wait, I lost the test in and okay, I'll just use this one instead. Boop. So that's the original image, and this is as good as the compression can possibly be. And then this is how it looks at the highest possible way I can quantize it right now, which would be the equivalent of 2 bits per pixel, which is 0.8 bits per pixel, which is crazy to me. 3. So the reason I'm saying this is quantized to 2, whatever, it's a long explanation, I'm sorry. This is the old way of doing it to 0.8 bits per pixel, and then I made a slight improvement, and now it looks like this instead. So I'm quite happy about that change. That's just a thing I whipped on myself in PyTorch. Because I want to try to make a gimmick avatar in VRChat that can like show an image, essentially upload an image as like, how do I explain this? People will be able to see an image of my choosing, and it very, very slowly is synchronized between all of the players at VRChat's speed of 256 bits every 200 milliseconds. Where some of these updates might be skipped or duplicated. So that's why I was trying to compress it down as small as I could to try to get the best speed. It's still going to take like a, minute or so to upload, but it just tickles my brain in the right way to think about this being a thing that can happen. Okay, so how far did this get before it crashed? It reached 179 with an x of 0. And the image we're using is... which one are you loading? Play deck 1, wait. Oh, this is huge. 256. Yes. So I'm like trying to get it down to like less than, I guess. Yeah, I don't know. Really, really small. Smaller than JPEG can hope to get. And you know, a better quality than a small image, small JPEG, whatever. Okay, so wait, the problem is reading or read access violation? Yes. Okay, so I guess this has gone blown way past its. Let's just end this and leak some memory. Data pixels. Let's call this data. Data. Wait, how do I do this? Data floats, current data floats. Current pixel, and I'll call this pixels then. It starts at this, and then this is this. Sorry, this is this to begin with. Okay, this is gonna crash again, but when it crashes I'll be able to check something about how far it's reading past the end. So hopefully now if I add to the watch list current pixel minus pixels 40768, and if we divide that by the width, okay, we've blown way past the end of the image somehow. I'm not quite sure how this happened actually. We're somehow trying to read row 728 out of 256. Alert! Fimsh in your area! Oh no! Not the Fimsh! Yeah, sorry Lane, I kind of went like explaining it in more detail and demonstrating stuff for like 2 hours before I eventually started making this. So yeah, I've already made the like an encoder and decoder in Python PyTorch. Oh no, the Fimsh is slapping around on the floor. And but now I'm trying to implement the decoder myself in C, because eventually I'm gonna try to implement it in a shader for VRChat. And so I want to make sure I'm understanding stuff correctly, which apparently right now I'm not, because I can't even load an image. But how are we blowing past the end of the... Oh, right. This is... Wait, no, this is measured in floats, right? When we're doing plus plus here, this is incrementing by the size of one float, right? Width, pitch, height, these are all correct. Number of pixels. Decode in C, encode in ocean. Wait, I'm very confused. I don't get it. Oh, in C. Oh my god. Hi, Pilot. Welcome. I'm waving with both hands, but none are tracking. Okay, one was tracking. Let's just add one to... let's just have an... How far are we actually getting? Oops, no. Boop. It thinks it's trying to... Oh, oops. And pixel equals 0. It thinks it's trying to read... Pixel 10,080. Which should be 180, but it's actually trying to read pixel 720. Which is very sus, because if you multiply that by 4, it's 720. Or maybe that isn't sus. Maybe this is always measured in bytes, actually. Yeah, this is probably already measured in bytes. So wait, why is this... Huh? This should be floating point at this point. Pun not intended. Free image convert to float. Does that return its own DIB? Okay. Can you tell me about free image yes, it returns its own... Bytes. That's adorable. That little fang is so cute. I love it. Okay, I don't know what's going wrong here. Thank you for the hydration. Give the pants as well, Alexia. Yeah, I do not know what's going wrong. This is incrementing this pointer by 1. We know that there are this many pixels, and by doing something height, width, blah blah blah, we shouldn't try to go past this many pixels. We know that it's stored as float. When we increment this, we're incrementing by 1 float. I guess there's something I don't understand about how pointers work. I thought this was gonna work. Man, what a bummer. Let's just access it in the noobish way where we literally just do data floats at index multiplied by the width. Oh, sorry, multiplied by the height plus the width is equal to curve pixel at index multiplied by... Wait, and I've swapped them all around. And y multiplied by the pitch plus the index. And then times the thingy. Boop. Huh! It's still crashing. Interesting. Also, I actually meant to make this be pixels rather than curve pixel. Also, what the Oh! Oh no, wait. Okay, we don't need to do that anymore. Why still crashing? What the fuck? Huh? Look, it's crashing at the exact same position as well, in Y.
Yes.
Hi Omni, hi Omni, hi Omni. My 3D print keeps hi Omni fading, so have some cheese. Well, don't worry, Omni. My thing's fading as well. Okay, so it's crashing at the exact same point when it's trying to read the Y. By the way, what is the pitch? 224, and the width of this is 56. Oh shit! The pitch is always in bytes, and the width is... Oh my god. Okay, I see the problem. The pitch is always in bytes. Well, I found the problem. The pitch is always in bytes. Let's just call this pitch bytes, just so that I'm not mistaken. And then pitch in floats would be... You had nothing. Would be pitch bytes divided by 4. Ew. And this obviously would need to be a whole number, but I'm quite sure that it will be. I'm quite sure that width and pitch are it's the same damn thing. Just, you know, obviously pitch is multiplied by 4. pitch is undefined. Okay, so now we do times pitch floats, and this is going to be pitch floats minus width. It should just work now. Oh shit, we actually don't need this anymore. Wait, actually, let me just double check that these are the same as each other. They must be, otherwise that would have caused a crash. But 56 and 56, okay, nice. Oh my goodness, thank you very much for the follow. Misanthropist forever, hi. Welcome. Okay, so that now works. So, I realize every time I run this, I'm mallocking more space and I'm never freeing it. Okay, so now I should be able to put this back and it should just work as well. Yes! It works! Nice! Let me just see if these values are the same when it's running the way it's working now versus the way it's working when I do this. Boop. I feel like I'll end up like Terry Davis. I don't know who that is. I don't know whether it's a good thing or a bad thing. Exact same values. Hell yes. I just made my own 3D engine in Python with lighting and FOV. Holy crap. That sounds like an accomplishment. We can get rid of all this crap now. Automatically converts to grayscale to... And at the very end, I'm gonna free this. I don't actually need semicolon, but I'll do it anyway. Because it's a macro that already has a semicolon, I think. Alright, so we can load a float now as an array. Nice. Terry Davis wrote Temple OS, so... I see. His lifestyle drove the guy to madness. I see. Yeah, one interesting thing that was, it's quite amazing that like it was actually an OS as well, that like functioned and stuff. I kind of, if this fails, I kind of want the entire program to exit. So I think at this point, if this fails, I'm gonna error and exit. We're gonna do let's error text. So this is gonna be a function that just shows an error message and then stops. How do you say it? Exit, was it? Is that the right exit? Looks like it. Let's return some non-zero error code as well. And we'll just printf error plus this error. That's it. Oh. Error text. What is going on? There we are. So in this case, couldn't open. Wait, what's the? How do you do the thing where you pass many? Thank you for the pants. There was a way that you could like just pass in a bunch of arguments. I forget. Actually, I think a hash define would be better for this one. Okay, hold on. Because oh man, how did you do this again? Was this a thing that was inside here? Wait, I just opened up the same... What? Why can't I drag this over there? What? Okay, this is behaving very weirdly. That's it. So it's void, hash define error, and exit is printf semicolon exit 1. Oh, whoops, I didn't open. Does that work? Return value type does not match the function type. Oh god. I think I think something's wrong with this. Printf this exit 1. Wait. Parent exit VRX __ VRX __. Wait, what? How is this happening twice? Expands to printf couldn't open semicolon exit 1. What's wrong with that? Oh, whoops! I didn't want to return anymore. Whoops! My god, that was confusing. Couldn't open % as file name. And here we put. Thank you for the pants, by the way, Siri. And thank you for the posture check as well. And hi, Fox Finale! Hi! Is that a Yuki Pookie? It is. I need to do the object and texture parser now so it loads stuff. Oh my goodness. Are you going to be using GLTF as the model and texture format? Looking off the tail. Having a good time, or is it lack of sleep making things difficult? I finally got some sleep today, thank you. Out of memory while trying to store floats of image. Okay. Okay, so by the time we've reached here, we know that it's worked, because if it hasn't worked, it should show an error. Let's see if it shows an error when I just put at the beginning. Boop. Oh, it's going to exit immediately. It's not going to pause, is it? Whoops. Boop. Couldn't load image. Blah, blah, blah. Press any key to continue. Oh, I didn't / in it. So maybe I can force / n. Well, I can literally just print f / n, I guess. I like to have my macros at the top, so let's put it there. There it is. Nice. And now it should succeed. No error. Nice. Okie dokie, this is all working, so let's load in all of the weights now. Now that we have a system to load these weights correctly, let's load this one as well. This one's minimum is this. I know I'm not. I should be able to read it from the string, but I don't feel like, you know, bashing my head against a wall today. String handling and string manipulation in C sucks. As much as I like C. Put the / n in the error message itself. I mean, I could, but then I'd have to do it every time, right? Next one be the layer 2 of the decoder, and then the layer output. I think that's all of them. Deck 1, deck 1, deck 2, deck 2, out. Okay. So layer 2 weights. this. Hang on a second. I done goofed. Boop. This one ranges from this to this. The bias is... Oh my god, I should... This is layer 2 biases. Can't wait for this to be done. This is just a test. And this will have to be hard-coded eventually in the shader as well, so... I guess I should get used to having to do this. And finally the output layers. Bias values are these, and the range is these. Oh! I should change how this works, because I'm going to want to know that... Oh no, I'm not. No, never mind. Ignore me. It's fine. .png. Which one was I doing? Layout. Wait, it's this one. Boop. 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 Oh my goodness. Right, so you should have all these stored now. Oh my god. Wow. Now the fox is being bitten. Damn. Layer 1 biases. Deck 2. Deck 2. And output. Output. Alright. Let's see if these can all load in correctly. Boop. Okay, let me just add a printf to confirm that stuff's happening. Loading. %s. Oh, I keep forgetting to actually put the string that I actually want to print. I mean, it looks like it worked. If it had failed, it would have exited at this point, and it could also have exited at this point, but it reached the end, and it loaded those in nice and quickly as well. I mean, alright, I guess we're ready, question mark? I guess now we want to actually load the image that we want to decode, which, you know, in the forms of the weights. Let's copy this over. Let's encode an image. Let's use this historic. And we're just going to do this one image. We'll see, test the decoding of it as well. Boop. Ta-da! Okay, so this was the input, this is the best possible output, and this is it after it's been quantized, so we'll have very slightly more noise. Very, very, very slightly. Let me do this kind of comparison so that you can actually see it on stream. Slightly more noise when I do that. It's very slight. Okay, and so yeah, the image that makes this... Oh no, actually the image that makes this, technically. Yeah, this. Thank you for the Pat's Cabbage is the output from this. Oh, that's without the fancy thing. Alright, fine, we'll do this without the fancy thing. So this is what I'm going to need to decode. So let's copy this over to here, I guess. Oh, it's not weights, there isn't. Is it weights? No, it's not weights. Let's make this called test. Let's call this test components commit. Sure, let's just call it that. Thank you for the pants. Ah! So many pants. Oh! I can actually make it do the scaling. Make it change it to be -1 to 1. Here. Hell yeah. And the image is this. I thought I was gonna have to make another little... This is test / blah blah. I thought I was gonna have to make another function to do that for a moment, but no. So this is mid vowels, I guess. What's wrong with this? Oh, do I actually have to do this? I do. Alright then. So we now have all of the data loaded that we need to do, that we need in order to actually decode it. So, should we try to decode it? Does tan H exist, by the way? Tan H does exist. Tan HF exists as well, which gives you a float when you pass in a float. I think we've got all the functions we need. Let's try to do a thing. Okay, so... Oh, I might... Oh, this is gonna be a bit annoying, actually. All H functions are just a bunch of X in a trench coat. It's kind of true. Decoder. Boing. I think I'm gonna make a... Oh my god, Centralex! Hi! Welcome! Hi everybody! Welcome in 5th function and Fanny Slab. What a great name. And Lucci as well, hi! I don't know if I'm pronouncing that name correctly. Probably not. I can see multiple ways to pronounce it. Lucia? Hi. How's everybody doing? Welcome in Cento as well. I have... Thank you for the follow, Dog Fox, as well. What are you up to? What are you up to? I'm gonna find out. Exclamation mark. Shout out. Centralex. Oh, wait. I gotta wait for the fly. Thank you very much, Patry. As soon as that flies away, a new one's gonna come up. Ta-da! A few Bracky's game jam entries. Wait, I don't know about this game jam. There are so many game jams running right now. I'm patting the S. Then dev. Alright, what were you up to? How did it go? What were you deving? Thank you for the, thank you for the raid and wow, 5 hours. Take care of yourself. Yeah, for those who don't for those who don't know me, I can't speak right now. I'm a strange cat. The stuff moving around me is like a thing that I made in Unity one time. I don't even know why I talk about that anymore because I don't even work on it on stream anymore. Because I don't work on it off stream anymore either. But what I'm working on right now is not a Unity thing. This here is a project that I've decided to try to make like a gimmick VRChat avatar. I want to try to make it, so those who don't know, in VRChat, so this is related to Unity. In VRChat, you make your avatar in Unity, and every avatar has 256 bits to spend however it wants. You could use those bits to decide which outfit you're wearing, like the color of this, for example. For example, my VRChat avatar, I can change the color of the glow on my wrist and the brightness as well. And I want to spend those avatars. This looks so good. What the hell? That looks so good. Why do you whisper? That is because... Oh yeah, right, I forgot to even mention. That's because... Ta-da! It's just gone midnight. No, it's fine. There are people trying to sleep like in a room like 3 hours behind me. It's, yeah, I can't wake them up, otherwise I'll be slamming on my door saying, hey! I was about to knock on something to make a knocking sound, but that would be kind of a stupid thing to do since they're trying to sleep. Yeah, that's why. Like 3 hours ago, I was talking. 3 hours behind you? Do you live in a black hole? Wait, did I say 3 hours? I mean 3 meters. 3 meters behind me. Whoops. They're on the other side of a wall, though. Thank God. But yeah. Also, welcome, Patreon. Thank you for the follow. One day I'll swing by when the uke is chatting. One day I'll flipping be able to stream earlier anyway. Hi, Obscure Cloud. I need to call you Obscure Time for a sec. So I'm wanting to make a gimmick avatar, right? Which can like I thought it'd be cool to, if I could display an image on my avatar, any arbitrary image, and that's represented in those 256 bits somehow. And every time VRChat updates those 256 bits to my avatar on other people's systems, a little bit more of the image is decoded. And VRChat has this way that you can control the bits of your avatar parameters and some other things as well via from external programs via something called OSC, which is just a network protocol on top of UDP. A very inefficient one, but let's not get into a rant about that. I didn't question it when you guys said they live 3 hours behind me. Sorry, I meant 3 meters, sorry. And so, but that's really, really slow. That's effectively like it's not even a 56k modem. It's like a 1.25k modem. Oh no, it's not. But it's 1.2, yeah. No, it's slightly slower, right? Because when someone says a 56k modem, they mean k baud, right? And like 10, where there are 10 bits for 1 byte. This is actually less. I don't even know. Can you direct me some info on VTubing avatars and stuff? I don't know. Thank you for the follow fifth function. I don't know. Information about avatars? I mean, I'm not sure what you mean. I built my thing originally from my VRChat avatar project. I actually bought it from it was so my avatar started as like the base of my avatar is a model that was being sold on Booth. Booth is a website and where you can buy stuff, like digital stuff especially, but I think also some physical stuff. And a lot of people make VRChat avatars that you can like buy and customize and set up and stuff and then upload and use. This started as one. And I ended up like combining a bunch of other things, modifying it in Blender and changing textures and stuff. And this person who made this is cool with that, but I would double check the license stuff before you do that. They're also fine with using it for VTubing. I can link to the website though. By the way, hashtag not sponsored, but the website is this. It's in Japanese. I don't know if they have an English language option, but anyway, that's it. It's like owned by Pixiv, I think. Or what do you call it? A subsidiary of Pixiv? I don't know. Which is a huge art. Just the sites. I'm a shrew cheesingus cat. Am I? I haven't even googled anything, but I've seen a lot of Twitch streamers and considered streaming my programming. I kind of want to stay anonymous. Well, you don't actually need to build your whole setup. If you haven't, so first of all, you can make an avatar in a free program, also by Pixiv, called shit, my mind's gone blank. VRoid Studio or VRoid? Just VRoid, right? VRoid. And that can save in a format called VRM, which has kind of started to become like a de facto standard for avatars. I mean, it was designed to be, but finally people are catching on. Then you can use this program called VCFace. And if I scroll down and turn that off, ta-da! Look, it's me. It's a more basic version of me or an older version of my avatar. And you can just use this totally for streaming. This can be captured on OBS. And yeah. But there are some other things I did, like if I smile and close my eyes, then look on here versus here, like down in the corner. Do you see how my eyes are like looking happy in the corner, but they're not up here? There's a bunch of other things and like this, for example, on my streaming setup, I made it trigger this toggle, but it doesn't on there, and this one. And probably some others I've forgotten. But yeah, you could totally just use this program, VC Face, this program that I'm trapped inside. But I'm just using it to track me, and it's sending the motion data over to my own Unity thing. By the way, my avatar was not made in Booth, in VRChat, so yeah. If you do get one on Booth and you want to, you can convert it into a VRM file. In fact, maybe people are even selling VRM files. But by the way, there are also free avatars. But it's a bit annoying. You'll have to be modifying some materials for your avatar if you want to use it as a VRM file, because VRMs only support a few simple predefined shaders. And a lot of the shaders for avatars that you might buy on Booth use much more advanced shaders. So you'll need to tweak things around to get stuff to look not awful. This is in fact a mushroom, I think. Yes, it is. There it is. Yeah, no worries. So VRChat and VC Face, I would recommend looking into for 3D VTubing. Otherwise, there's also 2D VTubing, and there's also PNG tubing. I know some people are working on like something that's a little bit halfway between PNG tubing and 2D, like live 2D. It's so like it's like an image that's made up of multiple different layers, and they can move a bit, but it's not quite live 2D. Okay, it's spelled like that. Let me just double check. VRChat. Oh, I think it is VRChat Studio. VRChat Studio. Yeah, no worries. Wouldn't it be any fun if things just worked out of the box? So yeah, for the VRChat avatar, I wanted to get the for this gimmick where I want to be able to like get an image to slowly transfer from my local VRChat to other people's ones. Firstly, VRChat avatars can't run arbitrary C# code, thank God. So you have to, otherwise anybody's avatar could like run amok on your computer, right? So you have to, the only logic you can, for defining like what an avatar does, has to be done through Unity animators and animations. Which I'm sure Setlix can realize is gonna be a bit of a pain. So I'm probably gonna want what other people have done, and what I am probably gonna want to do, if I'm gonna want to do complicated stuff, is make like an editor script for Unity that can set up a Unity animator for me and animations. Because screw trying to set up probably dozens of layers by hand. If you already know about Unity, then some things will be easier probably. But you don't need to touch Unity to go from having no avatar to having a new avatar inside VC Face. So you can do that just with VRChat Studio. But you can load VRM files into Unity and customize them in there, like setting up bones and colliders and swapping out materials and textures and stuff. No worries. You're welcome. What was I gonna say? Oh yeah, so 256 bits is really tiny, so I wanted to be able to compress an image to a really small size, right? So for that I made something called an autoencoder in PyTorch, which is Python language for like machine learning stuff. Nice to actually get some info, unlike some cube bots stream now. Oh no, hey now. No attacking the Settlix. Oh wait, why is Settlix? Okay, never mind. It looks like Settlix deserves it. They're doing a angry face or like a mwahaha face. So an autoencoder is an architecture, like a type of neural network, a structure, whatever, where you have an input, an output. They're the same size. I just can't draw the same size. You've got some layers. They go smaller, then there's some middle one, they go bigger. Usually this is smaller. The goal of the neural network is you put in an image and out comes the exact same image. But look, it has to pass through this little bottleneck in the middle. So what you can do is put in an image, it starts working its way through, and then you go, mwahaha, thanks for the mid-layer representation, sucker. And you steal it, and that's your small encoded version. And later on, when you want to decode it, you can just put this image in here and it decodes that. And so yeah, the way this one works is it splits an image into 12 by 12 pixel chunks, and it tries to encode them down to 56 values. That's just a somewhat arbitrary value that I picked out of the air. And so I guess I'll show this one again. But yeah, so this is the original image. And this is it after it's gone into the neural network, where it gets encoded into and out. So this is the full in and out straight, like after it's gone through the middle layer, where it's had to be squished way down. And then this is it after I've specifically tried to make that middle layer, the representation of that middle layer, into like a smaller format made up of a few number of bits that I could actually put over VRChat. So essentially here it's 3 channels per pixel, red, green and blue. And here it's 56 channels per 12 by 12 pixels. And then here it's the same, but instead of each channel being a floating point number, it's a quantized to 6 bits. Quantizing just meaning you snap it to the nearest possible value. So the values are no longer like the ideal floating point number. They're going to be... There's only so many different numbers you can represent in 6 bits. Welcome in, Deflux! Or that's why it makes V shapes. It was fed too many cat ears. That'd be funny. So you can quantize it to a fewer number of bits, like this. 6 bits, 5 bits, 4 bits, 3 bits, 2 bits per channel, which works out to about 0.8 bits per pixel. But this was a few days ago. I made a small change, and now you can get this quality out of it at 0.8 bits per pixel, which is absolutely really cool in my opinion. So this is like way squishing it down. And I purposely made the neural network so that the decoder stage is as simple as I can make it. Because in order to decode stuff, I'm going to, on my VRChat avatar, have to make it a shader. It's going to have to do the decoding in a shader. And so, yeah. I wanted to keep it simple. Hi, Stu. Yeah, it's gonna be good for certain types of images. So this one, for example, is the original, and that's decoded with 8 bits per pixel. There's some other ones. So this is the original. This is the ideal output, like if it's allowed to use floating point. And then if we use the fancy pants new way of making things smaller, that's 6 bits per channel, 5 bits per channel, 4, 3 and 2, which is the equivalent of 0.8 bits per pixel, which is kind of amazing to me. By the way, this is drawn by Kat. I should shout out Kat again because she's letting me use her stuff. Ta-da! She draws really nice stuff. she's drawn a whole bunch of stuff, and she takes commissions, and she drew all this, and also she draws NSFW stuff. But all of this stuff is actually safe for Twitch, but it's yeah, it's also a lot higher resolution than the 256 by 206 that I was using. But yeah, this is only the safe stuff. Anyway, so I tested on a bunch of other images as well. This was before the improvements, and this is after the improvements. Anyway, I don't know if I'm going to use such a super... Oh, she also drew this. Oh, and this here. Okay, so this what you see right here. This is a representation of the... So this is the actual values of the neurons scaled to 0 to 255 so that they can be like grayscale values for an image. Written out for the whole image, which is pretty cool. And the reason it's so much wider than it is taller is because you're seeing all 56 values left to right, end to end, for each single pixel. So effectively it's like 56 times wider than it should be. If I were to shrink that down to be 1/56th of the width, what the hell is 160? 100? No, 1 divided by 56. No, 100 divided by 56. Boop. Wait, why can't I paste this? 1.7857 roughly. This should now be the correct aspect ratio. Yeah, there it is. That's pretty cool, actually. So this rough shape here is like this, I guess. Anyway. And yes, so each pixel vertically is one chunk, one of these 12 by 12 chunks. Don't want the 1 day Twitch ban. Why did it look like the derp? Did it? Hold on a second. 1.7875. It kind of does, doesn't it? This looks like one of the eyes. Oh, that's actually kind of funny. What the hell? This also looks like a weird Doom sprite when I scale it down. So what I'm doing right now is, because I'm going to want this to eventually be a shader, I'm now trying to make the decoding part in C first, just to make sure I'm understanding and that I have correctly been able to extract like all of the weights of the neural network, which is like the actual stuff that it's learned. How much of each neuron's value it gets passed down to the next neurons on the next layer, which is this, hopefully. Yeah. So I'm trying to make sure that I've extracted all that stuff correctly and that I am understanding what it is. If I can write this decoder, then I'll be able to put these textures into the the slash me thing. The slash cubed up. How does... What is going on there when it's doing that? It's like it's not counting the length of the text action, isn't it? Or something like that. Took out from before it had to. Yeah. Cubed up. Okay, so yeah, if I can get it to work in C, it's gonna be, I'll know I'm on the right track for doing it in the shader, that's what I'm trying to say. So right now we're loading in everything. All of those weights and the biases images and the mid-vowels. And these are all of the weights and stuff. So these are like the connections almost. But I also need a space to store the intermediate layers, which I could do by making a struct. Let's make a struct. Look at this mess of things. Alright, let's make a struct, which is going to be called a layer struct, and it has a pointer to some weights. It has a pointer to some biases, and it has a pointer to the actual neuron values. Let's just call it neurons. And we will have a layer, and we'll call it a layer struct. Layer struct? Let's call it lay deck1. And we'll also have a lay deck2 and a layer output. And let's maybe screw it, this is just a test. Let's do it this way. Lay deck1 dot awaits equals this. Oh, it's actually shorter, huh? Lay deck1 dot biases. Hang on, what's the problem here? Identifier blah 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 is undefined. Oh, down here, yeah, sure. Weights, biases, weights, biases. And then I guess I'll make a struct called free layer, where you pass in a layer struct pointer, I guess. And it's just gonna call free on the weights and the biases inside and the neurons inside it. So easy free is a macro I wrote to automatically free an array and set that array pointer, that is, to point to null pointers so that you can tell if it's been freed or not. Oh my god, that clapping is so fast that it was almost in sync with the music. What the hell? We'll free that one and we'll free the neurons. And then we can just say layer free, lay deck1, 2 and 3. Oh, there is no 3, there is a pass them in by reference. Okay, I think that works. I also want, I guess I will make a layer struct for the middle layer as well. The middle layer is the input of the decoder, and I guess you could say the output of the encoder. So these values, I'll just put those into lay mid.neurons. And I should free these as well. Oh, actually, yeah, let's do this. Layer, free layer, lay mid. Let's just make sure this still runs and doesn't crash. Nice. Oh wait, it's crashed. Shit. It's not nice. Hold on. Oh, right. I should start these off as being a null pointer. Something I can actually do in C, but not in C#. Or C++ at least. Boop. Alright, nice. No longer crashing. So that was crashing because when Easy Alloc was running, my companion to Easy Free, it was automatically trying to do Easy Free because the pointer was not null. But now it's null, so it's not trying to free it. Fault mistake. Okay, so we have everything loaded now. So I want to make a function that can just take in 2 layers and pass the values down from the first layer through the weights into the second layer. So let's make a function called what should I call this? What's the word for passing values through propagate, right? Propagate neuron vowels, I guess. There we are. Sounds super high tech. Layer struct. Thank you for the pats. This is going to be a pointer to a layer struct. Okay. Propagate. So how we're going to use this is we're going to say propagate. Am I spelling propagate correctly? Am I spelling that correctly? Propagate. Is that right? Propagate. Yes, that's a great word. Okay, nice. Propagate so that it doesn't close. Yeah, so the Derpy Long you can still slide her way back home after she's finished going out for a slide. Okay, so what it's gonna do is take lay mid and lay deck 1. Thank God I'm not having to implement back propagation in here and just forward. So this is going to go from the middle to the first layer, and then the first layer to the second layer, and then the second layer to the output. And at the very end, the values inside layout should be the actual pixels that we can write out to an image file. Oh, wait a minute, I'm being silly, hold on. Wait, hold on a minute, I'm being silly, I'm being very, 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 very silly, hold on, shit. These layers are to decode a single block, so I actually need to call this entire area effectively once for each block. So I shouldn't actually be storing these in the neurons. This is this is like the whole thing. This is like image mid, I guess I'll call it. Or floats for the mid? What should I even call this? I don't even know. I swear, naming something is the hardest part. All mid vowels, let's call it that. So the implication is that it's something different. Hold on. Hang on, I must satisfy OCD, please hold. Okay, done. Zooming. It looks like, yeah, it's like there's a little wind vortex coming off her tail. Does this work? That does work, nice. Okay, then we also want to easy free all mid vowels. I need to make sure this still runs. I changed some things. I don't trust myself. No crashing. Okay, so this needs to be repeated for each chunk. But let's write the logic to actually do the propagation first, because I think this is where the juicy stuff is happening. I just send a normal message with the U plus 0001 and the action thing directly. Interesting. Nice. Okay, so we want to take the values that are currently in this layer and move them into this layer. I guess you could call this source and destination as well. Let's do that. Source and dest. Okay, so the way the values were stored, what was that again? Where is the thingy? I've lost it. There we are. The way it's saving them out is height of image is in neuron cur, width of image is in neuron prev. Except this is no longer 2D. I guess it's been stored in that way. Okay, so if we want to set one neuron in the next layer, then we need to access the current neuron on this layer and the all previous neurons on this layer, because so if you want to set this one, then we need to access this one to write to it and all of these ones, because these are all going to connect to this one as well as these. Reminder, I have a graphics tablet in front of me and this is the best I can do on my mouse. Okay, so int neuron cur is going to be like one thing, so int 32t, u and 32t is, so we're going to go through a loop where we're setting each of these. Exactly. So this equals 0. Oh, we need a way to store the width and the height of the images, huh? Or the width and... Yeah, we need a way to store the width and the height of the layer, I guess. We'll call this UN32T. And call it num neurons. So neurons are like, when I'm saying neurons, I'm meaning like what might be called the activation of the neuron, the value that it ends up as after it's taken in all of the values from the previous layer and run them through tanh to squeeze them. Hi Evelodfem! What a first message. What is my mic bumping against? Oh, hang on. What's it bumping against? Hold on. I can't work out which part is touching the... Sorry about that, stuff. Anyway, okay, so we need to go from 0 up to... Thank you, Siri! Up to the number of... Wait, what? I just said Control-Shift Backspace and did... Does that like center the current line on the screen or something? I'll do that in 1 sec, Stu. Okay, so this is for each neuron whose value we need to set, and this is going to go in neuron prev, because 0 and neuron prev is less than the source number of neurons in neuron prev plus. This is so much space being taken up. This is why I normally have it down at a smaller size. So for each neuron to set, for each neuron prev layer, I guess. Prev neuron to read, I guess. I'll call that. Okay, posture check. Thank you as well, Siri, for the fans. Friendly reminder to stay hydrated. Yeah, I actually had to change my theme from the dark theme to light theme on here as well because it was just straining my eyes so much trying to read the darkness when I was working on this off stream in the dark room. So, but I actually made sure to turn it back to the dark theme before I streamed because I don't want people crying. But this one's always been on the light theme, so I don't have any, feeling of obligation to make this one dark. Okay, so we need to store the width and the height in the oh wait, which is it? The height or the height, right? The slowly changing Y is the current one, yes. So that means the height of the weights. That's a weird thing to say. For this one is 256. For this one is 206, and for this one is... Ah, screw it, I'm just gonna hard code it. The mid dot num neurons is 56. This is kind of gross, but I'm kind of gross as well, so let's do it. 256 neurons on this one. 256 neurons on this one, and the output is the a lot. I don't know how many. Hi, Cobalt, thank you. 432. So this is each neuron on this layer is one channel of 1 pixel. So it's 12 by 12 pixels and 3 channels, red, green, and blue. So that is like 12 times 12 times 3. I think I'm going to define somewhere the chunk size as well. Because where I'm breaking it into chunks, I'm going to need to know that. So I'll just define that to be 32, and then I can say chunk size times 3. Have you tried Grav Box color scheme? It's really warm, it doesn't strain your eyes. I have never heard of that. I'm not sure I want to look for it now. Is this on Visual Studio? As opposed to Visual Studio Code? I guess I can do this here as well. Okie dokie. So, what do we want to do? We want to work out, well, these two things here correspond directly to X and Y pixels in here, but we've just got one big array. So, annoyingly, we need to need to calculate an index for this. There might be a way to do this more efficiently. Actually, yes, there is a way to do it more efficiently. We need to calculate an index up here, I guess. And pixel. Highlighted message. Yeah, I have on purpose not implemented that. Wait, what? There's just a theme? Like the abstract notion of a theme that exists regardless of the program that it's been made for? That's interesting. But yeah, I purposely have not implemented highlight message. I just left it. I left it enabled so you can see it on Twitch chat, but it doesn't do anything on my thing. I don't want to allow people to, bring attention to something that might be a bad thing. I feel like people would only want to bring attention to a message if it was a bad thing. I don't know. Okay, so here's the thing. We do need to calculate the index of the pixel in the float, where it goes across from left to right and then down a line, then left to right, then down a line, then left to right, etc. However, we're going across from left to right at this point. Thank you for the pat, Sexo. So we can very simply just increment this by 1 in here, and then not have to like do the full calculation of converting width and height, or x and y into Bikes, no worries. Thanks for the raid and thanks for stopping by for a while. Vim, Emacs and VS Code has it, I guess Visual Studio also has it. Interesting. Gravbox. What am I doing? Gravbox Visual Studio theme project. Wait, theme and project? What does that mean? I need to make a new project that uses it? Let's have a look. This looks like a very dark theme to me. Colors on grey. At least the colors look fairly saturated, but it is a grey background. I would much rather have high contrast, meaning a black background. That's interesting to know it exists though. Okay, so the index of the pixel, different versions. Index of the pixel is gonna be this multiplied by the... Oh boy, okay, hold on a second, I need to get my head around this. Different versions? Well, the only versions on here seem to be... There's Gravbox material, a port of Visual Studio's codes, Gravbox material theme. Oh, whoa, I almost just went to download it without checking it. Oh my god, this looks even lower contrast. Oh wait. Dark custom. The other one was just this one. Gravbox material dark in turn is a variant of the original Gravbox. This is the syntax from Gravbox material dark with a dark. I think I'm alright. I much prefer stuff on white for what feels like real code to me. I don't know. Theming VS 2019. I don't want to theme it at all. I'm happy with what I've got. Links will be swallowed though. Also, hi, Annan! Hi! Okay, so the width is according to IndNeuron Prev, so we want this to be the source. Why am I calling this... Why am I calling this current and previous? I'm just used to the time when dark themes were not like a thing, and those times are associated with... I don't know how to explain it. better days. But anyway, do I want source and destination? I guess there's a better name than previous and current. But then I have to say IndNeuron source. But that's not the source, no, it's a destination. I'm just gonna call it D for destination. And this is IndNeuron source. IndNeuron source. The ind pixel is equal to IndNeuron source times the source num neurons. IndNeuron source is not specified. Oh my god, wait. IndNeuron destination is slowly changing. Okay, so I guess it's this one then. Why? I don't understand why I keep on struggling to get my head around which one's X and which one's Y. This is really silly. I feel like I must be able to name it something better to it'll stick in my head, but right now I'm having brain issues. I mean, that's like all of my life. A neuron S equals 0, blah, blah, blah. And we don't have to do this by index. We can actually make a pointer to the float. That's probably a better thing to do. Let's make it a float star and call this weight. The current weight is equal to and these weights are stored on the destination layer, right? Weights between source and dest are stored in dest. Okay, so that's the destination layers, weights at this location. Actually, we don't need to do any of this nonsense. We don't need to do any of this nonsense. We just need to get the very first one first, and then we're just going to automatically go through. This is basically X, and this is basically Y. So this weight X, and this is weight Y. So this can just become a pointer to the first of these weights, and then we'll just increment this each time we access it. Float star can be used to initialize into your float star. It's already a pointer, so why was I complaining before? I'm trying to implement the decoder for an autoencoder neural network. I've already made it in PyTorch here. It's to compress an image down to like a really small size. For example, this top right is the equivalent of 0.8 bits per pixel. Bits per pixel. Yeah. And yeah, it works on 12 by 12 regions and stuff, and I'm trying to make a decoder for it. But in C this time, because I've already got it working in PyTorch, but I want to try to make just the decoder in C, because eventually I'm going to need to implement just the decoder in a shader for VRChat, because I'm trying to do something, make a very silly gimmicky VRChat shader, which can like share images, display images, any arbitrary image. I don't know if I'm gonna get that far, but if I can do it in C, then I'm gonna, and then it's like and I'm on the right track for making it in a shader in HLSL. Okay, so the weight current. So we need to take, so after we've gone through all of this, we set this one neuron, so we need to accumulate all of the values. So let's make a float. Let's call it val total equals 0 to begin with, and we add to this the value of this current previous neuron, the source, which is, oh yeah, right, let's make a, I guess we'll make a pointer to the values of this as well. Let's call this neuron prev equals layer source, or neuron source, I guess I'll call it, equals layer source neurons. So these are all the values that are stored in the previous layer, and we'll just, the value is going to become this, and we'll move that pointer on to the next one, and that's it. So we're just adding up all of the values of the previous one. And this is basically just making sure we repeated the right number of times, the same number of times that there are values in this array. And this is just a faster way than having to do this. There. It should be equivalent to this, and then, yeah, it should be equivalent to that. But faster because it's not need to recalculate the index each time, it's just moving on to the very next one. And so by the end of this, we have reached a total to go into here. So we set this neuron to this value, however, not directly, we set it to the tan h of this value. Basically what that does is, these weights, so each of these values can be, if this is like, zero and one, minus one and one with zero in the middle. That's what any of these values can end up as. And in order to, when you're adding them all together, it's quite possible you might end up with some adding up to like a way higher value, right? It's like higher and higher and higher. Wait a minute, let's make this something more like, yeah. So all of these totals might end up like way too high, way outside like the 1-to-1 range, like in this little inner part here that you want it to be, right? So we run them through the tan h function, which outputs always a value from -1 to 1, which coincidentally is why each of these neurons individually ranged from -1 to 1 in the first place. Which takes... Wait, am I drawing this the wrong way around? I think I'm drawing this the wrong way around. So values that are really close to 5 are going to be really close to 1. No, I'm not drawing this wrong way around. So it's like something like that. So values that are really close to -5 become really close to -1. Actually, this might maybe a bit too sharp. Maybe something more like that. I don't know. There's a lot of changing going on in this area. Something like that. Like, I don't know the exact shape. But it's sort of like a weird fancy S. And then the values in this area have like a lot of change happening like this. Whereas values in this area... Okay, that's really badly drawn. Values in this area have like not much changing. Anyway, so we need to pass it through the tan h function. Do you lose any information decoding the compressed image? Yes! A lot. It has its velocity encoding. You can see the original image looks like this on the left. And the absolute best case possible after encoding is this. So it's already lost a lot. But once it's in this form, you can start throwing away bits in the representation of each of these little 56 channels, you could call them, or the neurons on the middle layer. And that has this effect. Obviously, you save a lot of space and the quality gets worse, but it still resembles the original. But yeah, it's very, very lossy. I mean, neural networks are... I don't know how you could possibly make a neural network that's not lossy. They're like analog in nature. They're working on floating points all the time, so... I feel like it'd be a miracle. I don't know. I don't know what you'd have to do to make a neural network that is somehow lossless. What does it even mean to be lossless in the sense of a neural network? I don't know. Just sort of thinking out loud right now, sorry. Questioning myself. Neil! Thank you! Thank you. Thank you for the pats. But yeah, VRChat only lets you synchronize, basically upload, if you like, 256 bits. Every, like, 5 times per second. So it's, I need to squeeze this down to stupidly small sizes. I know, no worries, man. Thank you for stopping by. Take care. Okay, so the place where we're storing the destination, the destination neuron is the layer destination neuron. We set this value to this value passed through tan H flute. I think that's actually it. Wait, hold on a second. The value at this one. Oh, yeah, right. So the value here becomes this. And then, after we've done that, we want to advance to the next one. I think that's it. I think that's actually it. Wait, sorry. That's just adding the value from the previous neuron. We actually need to modify this according to the weight that connects this current neuron to this previous neuron. So all we do is we multiply that previous neuron's value by the weight. And the weight is this. I should be able to advance to the next one like that. Hopefully that will just work. That should just work. If this works, what an amazingly short function this is for that. I thought it was going to be so much scarier. Holy crap. Let's add some comments to explain what the hell's going on. Clear running total of vowels for dest neuron. Get pointer to first source neuron. For each source neuron to read prev and current make more sense in my head, kind of. Add source neurons val weighted by this to source. Wait, there's no way that I can squash this description down to fit in the screen at this large font size. Pass dest, so pass running total through tan H. So set dest neuron to running total squashed by tan H. Fine. Alright. If this actually works, that's quite amazing. Let me add a comment for this as well. I feel like this needs its own comment. So, weights are stored with triple check or quadruple check. I don't know how many times I've checked this now. I feel like the rest is still selected. So height of image will be neuron kern, width of image is neuron prev. Okay. Rates are stored with
Shut up!
rates between source high quantum neuron and dest neuron are stored in an image where X, quickly changing value represents in neuron D, and Y, slowly changing value, represents in neuron S. Since we need to read all of previous read weight for all of previous neurons every time we set the value of one current neuron, we can just increment this pointer every time we access it, and it will point to the next value we'll need, i.e. the next neuron on the previous layer, and eventually it'll wrap to the first neuron on the previous layer and the next neuron on the current layer. Holy crap, okay, hopefully future Yuke's gonna understand that. I wonder what kind of results you'd get with a more hard-coded math thingy like the DCT stuff JPEG uses. Well, a problem with that is that you need to like... isn't the point of that you can like quantize the values that are like low frequencies less aggressively than you quantize the ones that represent the high frequencies? I thought that was like dynamically chosen, or maybe it's not. Yeah, we'd need to like dynamically... No, I guess not. Isn't it basically just going to be like a low pass filter then? If you don't dynamically change how much you're quantizing it by? And if you do dynamically change how much you're quantizing it by, then you need to like store the amount that you're quantizing it by, which will need to be made up of several bits itself, I guess. I don't know. It seems much harder to me. It's easier to just throw the problem at the computer and say, hey, do it, make it happen. Okay, so let's pretend this is working now. We now need to pass the individual chunks, or the neurons for each individual chunk, into the middle layer. We also will need to build an output image to store the decoded values in, the ones that end up here in the output layer. So let's go into a loop. We'll have... I'll need to actually store the width and the height of the image. This is a thing that's going to need to be stored. Now this will be passed along into VRChat, I guess. Let's call this chunk... how did I do it? I called it width chunks or something, right? How did I do it before? Width pixels and width chunks, yeah, okay. In that case, let's call it the same thing. Width chunks equals... oh my god. This will just have to be read straight from the terminal, the console. So its size in chunks is 14 by 14 for the... Wait, what image am I even using? Let me just run something through this. Okay, the image I'm using is this. Okay, I'll just copy this and make sure that the thing I have sitting here is the same. The file size says the same, so it probably was that. So that's 14 chunks by 14 chunks. 14 UN32T height chunks equals 15. It's not 14. What the hell? Why did I type 15? Throwing away the high frequency detail. Yeah, I see. So these are stored from top left to top right and then down by one. So again, we need the height to be looping around on the outer for loop and the width to be looping around on the inner for loop. So it's going to be int chunk y equals 0 and chunk y is less than height chunks and chunk y plus plus. And then same on the inner one, but we do x instead. X less than width, and then chunk x Okay. So, wait, what's I complaining about? Nothing. Nice. So we need to do this, but at the beginning of each loop, we need to set the values on this neuron. So we need to read those from here. So let's call this current mid, or all mid vowels cur, which is going to be a bit weird, isn't it? Let's call it mid vowels cur. I guess we can do a mem copy for this, to just copy a chunk of the values, 56, straight from here into the middle layer. So at the very beginning, this is going to be a pointer to the flutes, and it's going to be called, what is it going to be called? Mid-vowels cur, yeah. And it's going to point to, or yeah, point to the same thing that's pointing to. And we're going to mem copy from, should I type from first? I'm going to mem copy this many values times the size of a float from here into the middle layers neurons. Yes. And then next time around, we're going to want to increment this by the by the number of this. Okay, so we should now be copying chunk by chunks worth of neurons from this image, and this will again wrap back around when it reaches the end into here. So now we need to take some out of the output and make an actual image. We find it can't escape it any longer. We need to actually make an image now. Let's make this a... this is where stuff is likely to go wrong, by the way. Because this is where like pitch and stuff is going to be a bit of an issue, I guess. Pitch and width of the image. These differently changing things. Width that's stored when viewing the image and width that's stored in the file, which might have some padding at the end of a row. I guess I'll store these again here as well. Okay, so we'll make one. We'll call it dib out, I guess. This is going to be a brand new free image allocate xt, I think it was. Okay, free image type. So free image type. Where was it? Free image type. Oh, it's not there, is it? Boop. Free image type. So we want a bitmap. And the width of the bitmap is going to be the width in chunks multiplied by the chunk size. And the height is going to be the height in chunks multiplied by the chunk size. And what else does it want? The bits per pixel. Okay. Shall I make this 24 or 32? I guess it doesn't really matter. 24 would be easier. If it's actually stored that way in memory, that would be so nice. And... oh, wait, if it's... okay, I don't know if this is stored blue, green, red or red, green, blue if it's 24 bits per pixel. I know that if it's 32 bits per pixel, it's blue, green, red, alpha. But I'm not sure if it's just 24 bits, if it's red, green, blue or blue, green, red. But we'll soon enough find out. I think everything else is optional, right? Let's have a look. Wait, where's the docs gone? Here we are. Wonder what each individual component looks like after the training, as in the output of each individual input channel. Hang on a second. Ah, Right, I see what you mean, yes. So, like, you first look at the 0th pixel of each, or the 0th neuron, and then all the 1 neurons, and all the yeah. Let's find out, shall we? I think this is easiest to do here. Okay, so where are we visualizing it? Turn middle layer itself into an image. So what's an easy way to select out every 0th? How do you do this? This basically has 56 12x12 images. And it's combining them to make the final image. It has it has... In the case of this image, it has 56 14x14 images. So each chunk is split into 56 parts, and there are 14x14 chunks. So you could look at index 0 of 55. For each of these chunks, index 1 of 55. The size of a single chunk. The size of a single chunk is 12x12 pixels or 56 neurons, yeah. The size of a single chunk is either 12x12 pixels where each pixel has 3 channels, or it is just 56 neurons without the concept of a pixel. The chunk itself is stored in 56 neurons. But I think it'd be pretty interesting to look at a 14x14 bitmap of all of the in neuron 0, a 14x14 of all of index 1. I think that'd be really interesting. I'm sure for certain, well, maybe I shouldn't say that. So each chunk is like a weighted sum of 56 12x12 predefined chunks. I guess you could say that. But the weight of the sum is not the same for every one of those 56 things. In other words, as you're combining some of those 12x12 predefined chunks, you could be... Well, basically the values can go negative. So although it's called a sum, you're actually going to be subtracting some things when you're summing and adding some other things when you're summing. Also, when you say weighted sum, that's... I guess it's technically true, but it's like a sum... It's going through tanh as well, as it's making up the sum. It's... I guess you could say a non-linear sum. Because, yeah, there are multiple layers between the middle one and the output, and at the end of each layer, it's tanh-ed. I don't know an easy way to... a squished weighted sum. Yeah, it's like a sum of squished weighted sums, I guess. Which is itself squished at the very end to... yeah. A squished sum of squished weighted sum. What a ridiculous sentence this is. What's an easy way to select every other value in a NumPy array? Let's have a look. NumPy... every x values. Is there like an easy way to do this, or do I need to go into a loop and build one up myself? Subsampling every nth entry in a NumPy array. 1, 2, 4, 1, 0, 1, 0, 4, yeah, that's exactly what I want. You can use NumPy's slicing. Simply start, stop, and step. This creates a view of the original data, so it's constant and also reflect changes Okay. So XS134, blah 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 blah. Okay. Yeah, we can totally do this. We can totally do this. So we reshape it to height or chunks and then this thingy. Okay. Let's make a new section. Turn middle layer itself into 56 different yeah, I'm tired of shouting at this point. Into 56 different images, each one looking at a different every X neuron. I'm not sure how to explain that. In the chunks. E.g. every 0th neuron in all chunks, then every 1th neuron in all chunks, etc. 1th neuron, there you are, you heard it here first. Is squished squared or cubed? Besquated some. Okay, so we already have this. Okay, so we need to reshape this array so that it's linear and we can easily take out the ones we want. We're going to reshape it to be one-dimensional, and it's simply going to be height chunks times num neurons mid times width chunks. Okay, so at this point we have a one-dimensional array. And then we'll just do the slice function, which is apparently, let's call this X neuron equals... Did you do this again? Oh, you literally just do encoded CPU. Wait, how's this working? So this is starting at this index. And we do colon 4. So skipping 4. So we want to skip by the number of neurons every time, I guess. Where is OBS? Here it is. Num neurons on the middle channel. And the first one is, let's go into a loop, 4 end neuron offset in range 0 to, wait, I need to do that, num neurons mid, and then we write the image. Oh, we want to resize it back to 2D, otherwise OpenCV is going to be very confused about that very long one-dimensional array. So X neuron becomes np.reshape X neuron height chunks and width chunks. So effectively this many times smaller than the full 1D array is, because you know we're skipping that same number of pixels each time. Let's see if this works. And then we'll write it out to, what should I call this? Mid. This is like the middle layer. X underscore. And I'll just add the string of the neuron that we're currently looking at. And this is Xth neuron. Okay, let's see if that works. It's done. It didn't crash. Oh my god, it works! Look, we've got a load of tiny little images here. I don't know if this is actually correct. 0, 1, 2, 3. Oh, they're all the same. What the hell? Hold on. Oh, whoops, I didn't actually add the offset in there. Okay. Run it again. Please don't crash. Nice. Okay. Okay, nice. Now the difference. So this is the 0th channel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a minute, is this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, 0? Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it is. I can't count. Wow, there's a lot of these channels, huh? 56 of them. And somehow they make up this. That's interesting. And so I'm seeing like a big patch that's roughly the same color over here in a lot of these. And that corresponds to like roughly this area. That's weird, isn't it? Is it meant to be this area? Is this like accidentally rotated? Have I swapped? I have. I've swapped the... Oh no, I haven't. No, I shouldn't have swapped. It does look like it's rotated though, like it's reading X as Y and Y as X. Let's make a test picture. Let's make a small picture. Well, let's make 256 by 256, I guess, which could be a lot smaller. We'll put a dot around there and a dot around here. This is a little bit cursed. Oh my god, that's fucking awful. Fine. No, not fine actually. I don't like that at all. This looks like a moustache when I like draw it this way. Okay, let's save this into the test folder. As this. Boop. Nice. Out of curiosity, what does it look like? Really fucking good, holy crap. Yeah, look, it's rotated! Why is it rotated? How did that happen? It's actually rotated the other way to what I expected though. This is each of these channels. Wow, look at this. There's like different background colors as well. Blah, 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 blah. Why is it rotated? Wait, what have I done? You're kind of in the opposite of this. Okay, I don't know what you mean then. I think that's quite cool. Was I having to, when I was doing this? I mean, I can swap them around. I can transpose it. I just couldn't quite realize why I need to transpose it right now. np.transpose x neuron. Swap them around to 1, 0 instead of 0, 1. Guess that'll fix it, but I don't know why I need to. Which I don't like doing things without understanding why. Anyway, now it looks correct. Ta-da! You have 56 channels for every 12 by 12 chunk in the compressed format. No. Yes. If one of those channels is 1 and the others are 0, what does the chunk look like? Ah, I see what you mean. That will be interesting. Yeah, but you can't easily tell the influence of one neuron because in the presence of other neurons being on, it can like have different effects. But I actually did something similar to this once for like when I trained a neural network to generate like to autoencode a spectrogram into like a small size and into a big size. And I made a thing where every column you could essentially override. Oh my goodness, thank you very much, Vance. Hi, Vance Model. Welcome. Very much appreciated. I made a thing once where, you could override the values of certain neurons, not with constant values. I mean, you could. Cheddar. I knew Eta. Or Eta. But with like a value that's changing in like a sine wave pattern. So like over a certain number of columns, the value gets higher, and a certain number of columns, the value gets lower. And you could just populate like overrides for a whole layer set to random speeds and stuff. So you'd have like each neuron like twinkling on and off at different speeds, and that made some very interesting stuff. I'll see maybe if I can track that down, or even I could just do it again at some point. But that wasn't in PyTorch. That was the thing I coded myself. Yeah, that's interesting though. I mean, that's super easy to test though, right? I mean, I can just make an image in Paint and run it through it. Although, yeah. Could be also interesting to force some of those channels off, I guess, and see. Anyway, this worked. Sorry for doing exactly the opposite of what you wanted. I now understand what you mean. If I don't want to do that by manually doing stuff on Paint, though I guess I could make everything grey by default, and then what's the way to do this? So 56, 1, 56. Then for each of this, you could turn this to full 1.0 or to minus 1.0, right? Whether it's positive or negative is kind of arbitrary because the weights for each of them can be positive or negative as well. Once you have the decoder in C, you can just feed the data manually. True, that's a nice rhyme. Wait a second, I just realized a really easy thing I can do. Watch this. Whee! Let's save that. Mid-line. And let's decode just one of those. Midline.png. Boop. Okay, it's done. And the output is this. Nice. When you look at that, obviously it's rare that one of these neurons is at like really high value. So I guess I could draw this. No, not that. I guess I could draw this at the darker color. Like maybe this value instead. No. Man, wouldn't it be interesting to just put a random picture into here and try to decode that? Hello? Second update? Oh my god, what's happening? Why am I suddenly being laughed at by myself? Stop this. Oh, I guess it looks paler now, huh? What if we just, like, we do one that's darker than normal as well on the other side. Do you have a dark grey in the palette? Apparently don't. Wait, what? Hello? That's weird. You're very ambiguous. Garbage in, fun out. Yeah, I guess so. Now we have something that looks like this. I guess, what is the true neutral image? What is the most neutral image that you can look at? This. I don't actually know whether 127 or 128 would be the closest one. Close to white. Yeah, that's not much of a surprise, because there's a bunch of pictures that are like a manga pages. I trained it on, so like white background. Let's draw something. Let's say let's make this the most cursed thing possible. What am I fucking drawing? Okay. Oh my god. Okay, nice. Yeah, and these are all like really, really high contrast things as well, because I'm drawing with pure max black and white as well. We could have to make a new hit retro game. No, horror retro game, sorry. Retro horror. I'll get there eventually. Let me use a... You know what? Let me use a brush, because you can easily make gradients with this. This is way too big, holy crap. There we are. So not everything has to be like the extreme values. Some of them can be even. Once again, my graphics tablet being put to good use here as I scribble stuff with my mouse. Right. What? Alright, what is this absolute monstrosity coming out as? Ooh. You can actually see something blending here from one kind of block to another kind of block. It's kind of nice. Huh. Isn't it interesting? Graphic design is my passion. Yeah. I could actually stretch this across to be the same height as it is wide as well. But like, well, it needs to be 56 times wider actually. Yeah, I guess I can't do that easily. You can't stretch above, like, what is it? You can't stretch it that wide in one go. I think you can only do like, what is it? 500, alright, fine. Arbitrary limits. Oh no, come on. I was hoping it would do it with smoothing. Wait, why is it not doing the smoothing? What the fuck? Huh? Or is it doing the smoothing? No, wait. No, it's not doing the smoothing. Is there some arbitrary threshold? If your selection is bigger than a certain size, it won't smooth it? The fuck? Oh, there we go. There we are. Why was that so hard to get it to do? Again. Fine. This needs to be a multiple of 56 though, but it will be at this point. So it's gonna be 5 blocks wide. 5, 10, 15, 20, 25 if I make it wider still. Man, this song is such a bop and I say it every time and it never stops being less of a bop. Alright, fine. Boop. Hello? Oh, can I reshape something rather blah blah blah? Hang on a sec, are we correctly on multiple? 1410 divided by 56, so we are not. Slightly off. So 27 by 56 should be 1400. 1400. Boop. Why is this not dating? There we are. Oh my goodness. Surprised it looks that samey, to be honest. Why does that look so samey? Does the encoder have a width or height limitation to accept any size of image? Well, right now I'm putting stuff into the middle layer, and the middle layer does have requirements. The width must be a multiple of 56, because the way what it's expecting is 56, the values of the 56 neurons that makes up one block, stacked end to end horizontally. So the horizontal size must be a multiple of 56. But if you're putting actual proper image into the input, not into the middle layer, then no, it can be any size, but it doesn't handle multiples of 12 in a graceful way. You'll just get the edge of your image becoming like black like that. I should fix it. Oh god, I just found out something. Oh no, what? What? Not even the power of 2 is on the limit. I know, I'm sorry. I thought 8x8 was interesting, but I thought 16x16 would be asking too much of it, so I went evenly between them. Oh yeah, that's what I was doing. I was trying to look up this function like 5 hours ago. Okay, how to allocate xt color. Pointed to the color, the memory pointed to is assumed to be at least as large value, but never smaller. And can I? Is that? It's not saying that it's optional, is it? Do I actually have to define it? What if I pass null pointer? Is it gonna die? Let's find out. Options. What are the options? Options that affect the color search process used to palletized images. Okay, that's completely irrelevant. Someone's discovering the wonderful world of JavaScript. In JavaScript, the default array sort behavior is to convert everything to a string. Oh god. And do alphabetical sorting. What? So if you sort and okay. Oh my god. And you don't even get those strings. Yeah. Holy crap. So it converts it back afterwards into the original format? Wow. Wow, but not in a good way. Okay. So, once we've passed a whole chunk through, we need to copy into the output bitmap the values here. Now, if this is ordered blue, green, red, blue, green, red, blue, green, red, then this will be easy because that's how it's stored internally on this output layer. It's stored top left to top right. And then next layer, I think. But if it's not, then blue is going to become red, and red is going to become blue, and green is magically going to stay correct. So I'm going to try mem copying it. Oh wait, this needs to be inside here. Copy a chunk of... yeah, literally a chunk. 1 chunk's worth of neurons into the middle layer and run them through the network. Oh, just to the middle layer. Run the neuron values through the network to the output layer. And finally, copy this, the output layer, blue, green, red pixel values packed left to right and then down a row, etc. into output bitmap. So we're gonna have another 2 for loops inside here. First of all, one that goes... Well, actually, we only need... Well, since we're mem copying each row, we only need a loop for each row. So we're gonna do for un32t and pixels... Going to pixel y, I guess. Thank you, devil. Hi, devil. How the devil is the devil. So if you sort 1, 2, 10, you get 1, 10, 2. Oh my god, this sounds so Microsoft. Oh yeah, byte-wise sorting, that'd be fun. Although in before it's stored differently on different architectures, so sometimes, you know, big endian, sometimes little endian. Thank you for the posture check as well. Oh my god, that's a crack. Oh no, you're getting twitched. It's also magical because string a8 null doesn't work, but a8 null.sort does. Okay, in pixel y starts at 0, and pixel y is less than chunk size. Hold on. I'm not just wanting to copy... Oh my god, how am I going to do this? Int pixel y equals 0, int pixel y less than chunk size, int pixel... This is like end pixel of chunk y. This less than chunk size, this plus. And then what we're gonna do is, so end pixel y is equal to the chunk multiplied by the chunk size plus this. And this is the actual y coordinate on the image. And at the very end, this is all going to be upside down, so I'll flip it the other way around. Let's not worry about that. Just because that's how his free image stores in. Doesn't sound very Microsoft, but what does sound Microsoft is that it's based on UTF-16 elements. Oh, I just meant that the sorting of file names when Vista was introduced or something, or XP, I can't remember. At some point they changed from sorting like not based on alphabetically into sorting alphabetically, and I was very annoyed when they did it. I don't think it was always alphabetical. Or at least there was some area where I saw it changed, I don't know. Anyway, let's see if I can sort this out. The X position is gonna be end pixel X. It's gonna be the end chunk X multiplied by the chunk size. Okay, so we want to so the way that we convert, how do we do this? The index of the array then, or the pixels actually as stored, is gonna be this multiplied by the pitch hold on a second. Let me rename this to pitch pixels, I guess. Pitch pixels. And this is size of float. And this is this one is going to be divided by 3 because of 24-bit color format. I guess I could also do divided by free image get BPP. Gonna be out. There you are. It's a really better way of doing it. It should be 3. Wait, this is divided by 8. Okay, and so we also want to get access to the pixels out. So that's going to be we need a 24-bit data type, huh? I feel like there is one defined somewhere in not this place. In one of these files. BGR? The specified order of color components, red, green, blue, affects 24 and 32-bit images. Okay, nice! Nice! My biggest language pet peeve is still C designed to use 0 as a prefix for octal numbers. That is horrible. That is absolutely horrible, yes. It does as a way to enable and disable the numeric sort. Really? We have the sane way and the crazy way. but you decide. I didn't know you could do that. Wow. Okay. I hope that affects everything, not just Explorer, but like the standard file browsing dialogues and stuff. Little engine, BGR, beginning RGB. You can always define this to any of the known orders. Okay, where is the... I thought it'd be like a... Oh, here we are. Oh, wait, no, it's not that. Oh, yes, struck to RGB quad. Hold on a second, why is this not being defined? It's not an RGB quad though, it's an RGB triple. Why is this not defined anywhere? Why is this not defined? If not defined windows. Define windows. If not defined... MS EVA? Wait, so wait, is RGB triple? Oh, it has tag RGB triple, not RGB triple. Oh, there's RGB triple. Wait, so does RGB triple actually exist here? RGB triple. It exists? Wait, where's it defined? In Win GDI. Interesting! Okay, this is stored in Win GDI. So free image automatically realized then? Wow, okay. That's pretty cool. So this is gonna be pixels equals RGB triple star free image get bits. So we can now simply say mem copy into the address of pixels at this index. Wait, was that source or destination? Hold on a second. This is complaining. Wait. Oh, I never finished defining this line. One sec. Oh, writing this line. So the pixel is going to be the y times pitch in pixels, I think. Wait, pitch in pixels makes no sense at all. Why am I doing it this way? I think I'm gonna go about this a different way. Actually, I don't think okay, let's go about this a different way. The index is... This is index of a pixel... Oh no, I do need this, don't I? Get me out. Divided by 8. Or bytes per pixel. Bytes per pixel. Okay. Bytes per pixel. But now I need these to be multiplied by, oh my god. So is this multiplied by the bytes per pixel? Multiplied by the pitch in bytes, I guess? So that this is in pixels, that converts it to bytes. And this is in bytes as well. I'm gonna put this in brackets just so it makes more sense to me. And then we're adding int pixel x times bytes per pixel. Holy crap, I did not think this would... There's gotta be a better way to do this. What's this complaining about? Oh. It's meant to be getting bits. And that's a pointer as well. Expected of this. Oh no. Is this real or is it fake? Nope, it's fake again. Nice. Someone who spent all of college years programming Linux, all those Windows being said quirks are new to me. The sorting stuff? So, I mean, it is, yes, that is. It's nice if you don't have to deal with that. What's a better way to do this? Thank you for the follow, Apollo. Hey, that's a nice rhyme. Hi. Let's. Oh, this is so gross. Maybe I should just do RGB 32 instead of RGB 24 and just manually copy every single value in, because this is what is actually happening here.
Cheese.
Maybe I will make this uint 8t pixels thingy then. Equals that. That's a cute wave. Hi, Gundorf.
Cheese.
My. Also, hi, 2D Teddy. I like that name. I don't like the fact that you threw cheese at my face, though. You gonna eat that cheese? What? Was it a bait? Like a literal bait? Because, you know, like food in front of my face? I guess I will try to now. I can't get it though. Okay, no memory copying? Why? Why no memory copying? Okay, so this is not index of pixel, this is index of byte. So y converted into bytes times the pitch in bytes plus the x position in pixels times bytes per pixel. Why? I'm here. Yeet out of jail free card. Thank you, Chris. I'm back now. Hey, but look, it's opened up. I thought I was gone. Okay, mem copy. Into the destination is gonna be pixels, starting at this byte. I guess I need to do the address of that. What am I gonna thank you for the follow? Raining day? Welcome. Welcome. The source is from the output layer's neurons. Starting.
Share.
Bye. Starting at. Oh, I have to get my head around this now. So on the. Well, it's going to be the same number of pixels as a whole line takes up, I guess. So the pixel of the chunk, y-wise, is also going to be used to determine which position we're starting from here. So this is int maybe I should name this int image byte and int image pixel y int chunk. Oh, this naming is getting so bad. Holy crap. So this is int image pixel y and image pixel x, and then I also need an index of the neuron byte, which is going to be the y position in the chunk multiplied by the number of neurons in the no, irrelevant. We're not on the middle layer anymore. This is how wide a chunk is. I should also make let's just do it this way. Numchans equals 3. And now I can just do this. I can probably hash define this actually. I should probably I could hash define all of these. And then pixel of chunk y. Okay. And byte is the image byte. And that'll do that. And the number it's going to copy is the width of the image multiplied by the number of channels. And the byte in the output layer is also this multiplied by the width. Oh, bytes per pixel works as well. Bytes per pixel works as the... bytes per pixel works as numchans, huh? In that case, I guess we could just define... Well, we don't need that then. But we'll just do this times 8 here instead. Bytes per pixel is the same as numchans. And the byte in here is which pixel it is, multiplied by the number of channels, multiplied by the width. The address of this. Is this real or is it fake again? No, it's fake again. Oh my god, I think that's it. What did I see? I don't know, what did you see? Me having cheese to myself, I guess? Oh, I'm being thrown out of the jail. Duality of man, cheese on face and a head pat. Wait, you have to do both? Also, it keeps on making me look angry right now, which I'm a little bit ironically angry about. Though my ears keep on going down like that, even though I'm not frowning. Let's restart the tracking. 1 sec. Boop. It's the restart head tracking hiccup. Okay, we'll see if that makes it happier. In games, which ones do you play? I have played A Dance of Fire and Ice, Mustache, Stepmania. I haven't played Stepmania in ages. I must have played more of them games on stream, right? Oh, Rhythm Doctor. That's what I can think of right now, sorry. It's perfectly balanced as all things should be. Am I gonna go blind, or the ID you're using is a bit grey? It is a bit grey. Yes, it's darker. I'm actually darkening things that I really... Watch this. I'm darkening things when there's a lot of bright pixels to avoid like stuff blowing out white, because my streaming setup has a little bit of bloom on it. So here, Watch the brightness of the stuff here when I drag this interview. You see the colors going darker in the background? Ever played Osu? I think well, a long time ago I tried. I don't know, it wasn't as satisfying to me, but I was not doing like the tapping with fingers thing. I was actually like clicking, so maybe if I'd actually used the keyboard instead, it would be more satisfying. Okay, all of this area here, there's so many ways that this could go wrong and just like crash it. So if this works on the first attempt, I'm gonna be absolutely blown away. What's this rabbit hole? Is that you play Osmania like crazy? Wait, Osmania is the scrolling, right? The scrolling notes. Okay, let me do the old switcheroo. Free image flip vertical. Jazzin! Hi! I'm waving, but my hands. Wait, what? That was weird. I was waving for so long, but my hands were frozen. Hi, Jazzin. Thank you very much for the flipping 15-month resub. You don't have to fake being happy. Just do yourself. No, I'm not. What annoys me is that I look. It thinks my eyebrows are going down like this, but it's not happening, and it's annoying. It makes my ears go down. I look very, very angry when I'm not. Alright, free image. Right. Now how do you do this? Save. Yes, that's the one. We'll save. In FIF_PNG, we'll save a PNG file of this. And why does it keep doing that? I swear to God. Now I'm angry. And I'll save this out to test/out.png. I think that's everything. Okay, let's see if this works. I'm sure it won't, but let's try it anyway. Boop. Surely somewhere around here we're gonna get a segfault. Yeah, sure enough. Oh, actually it's happening earlier. Access violation writing location 00000. I mean, that'll do it. So we're trying to write into... What's the location? Oh, this is the destination. Oh, whoops. Wait a second. No, wait, that's correct. Oh, I never prepared a space to store the neurons in the middle layer. Whoops. Whoopsie. Lay mid dot neurons. Wait, I haven't prepared a space to store any of the neurons on any of the layers. Whoops. Whoopsie. Okay, so this equals easy alloc lay mid dot num neurons. I'm gonna change these lines here to be a happening in one of these things called init layer, init dobrav. Alright, this music needs to calm down. Neurons plural? Must be nice to have so many. I know, right? Chat have only one neuron. Hey! Some of them have two, I'm joking. I have one. Also, it's hard. Was she cooking? We're sharing just the one? Hey! Let me have a go sometime as well. Mum says it's my turn on the neuron. Okay, so... Oh my god, I need to turn the music down just... you know what, I'll wait. It gets loud and then it quietens down for the rest of the song. I'll just wait, and then I'll explain. One second, sorry. Let me just, before I forget... again, before I forget, Leica neurons equals easy look. Neurons. Oh wait, that's not how it works. We just do this. And where we do the free layer, we also want to free... Oh, we're already doing the freeing of the neurons, okay. And then I'll just do it this way instead. Wait, can't I just pass the... Actually, I don't know if I need to... I'll just pass it this way just in case. And then 56, 256, 256, and this. Okay. I guess I'll define those up here as well. Height, yeah. This is for the image that we're gonna decode. So I'll put those over there. Okay, so what I'm doing is I'm writing a decoder for an autoencoder that I've made. An autoencoder is like a type of neural network that tries to encode the same thing as, like, output the same thing as its input, but it has to pass through like a bottleneck in the middle. And this bottleneck is like a really compressed representation, is basically what it ends up representing. If it's able to manage the task of recreating the output close to the input, and it's had to have passed through the tiny middle layer, then like almost by definition, the middle layer, the tiny one, has to be some really compact representation of the input. So I trained an autoencoder to compress chunks of an image, 12 by 12 pixels. And, wait, why does it say 32? This should be 12. And, yeah. And it works, and I did that in here, in PyTorch, and the output, an example is this. So the original image is this, the encoded version is this, that's, yeah. And then when I like tries to represent the values on the middle layer, this compressed version, with fewer and fewer bits, it starts looking like this. This is 6 bits per value on the middle layer, 5 bits, 4 bits, 3 bits, and 2 bits. So this here, the middle layer has 56 neurons. So the way you can think of that is the image starts as with like a 12 by 12 pixels in each chunk, right? And each pixel is made up of 3 channels. But in the middle layer of the network, the 12 by 12 chunk is stored as what you can think of as 56 channels. So rather than it being 144 pixels, each with 3 channels, it's just one chunk, each with 56 channels. And the equivalent of 2 bits per one of those channels is, what is it, like 0.8 bits per pixel. So like this. Oh god, I didn't mean to double click that. This. So 6 bits per pixel in the middle of the screen there. Per channel. 5, 4, 3, 2. This was the old way of me doing it, which didn't work as well. Then I made a change to make better use of the limited space of only 2 bits. Instead of it trying to encode like values that are mostly grey, like roughly mid-range. No, hold on. Where's the real? No. Oh, I've lost it. Oh wait. This one? Yeah. So the values are like very greyish, so I made it effectively zoom into the middle area and just encode that area where there are lots of values. And then, yeah, suddenly those two bits were encoding more useful values instead of them encoding like a value here that's never used and a value here that's never used, and then only having two values left. Anyway, so I've already made something that can encode them and decode them in PyTorch, but I want to now, I'm trying to write the thing in C to do it. And if that works, then I understand what's going on, and I'll eventually be able to write it in a shader for a VRChat thingy. Wait, did it just... No, it's crashed somewhere. What's the problem? Can you tell me what the error is? What's the problem? Hello? Oh, there we are. Access violation reading location 0000000. Why are we trying to read zeros? Why are we doing that, huh? The source location is this. Wait, what's the problem? The output layer. Huh? Did I not initialize the output layer? Whoops. I'm initializing the same layer every time. Whoops. Is that effectively compression? Yes, it's compression. It seems that she's evolving. I'm evolving? Like, maybe. Maybe. Also, it's a game that makes me thinking that I cannot even control my hands with free will. Oh my goodness. Okay, it's crashing again. Now what's the problem? I have to click continue before it tells me for some reason. Or maybe I was just blind. Okay, right. Now we're trying to read something that's not zero, but it's bad. It's trying to read byte 2520. Now let's see if this is... yeah. Okay, this is way past the end of this. Oh no, wait. Not necessarily. Hold on. Okay, so... the number of values on this layer should be 12 times 12 times 3, right? For blue, green, and red. That's a lot of hours of playtime. Your background music is coming in handy. I was like, wait, that's just like compressing your low and high frequencies. Oh, background. Oh, your music background. I see. That was very confusing for a moment. Turns out if I read the message better, it makes more sense. Thank you for the clap. Okay, so yeah, we only have this many values on the output layer, but we're trying to read the 2520th value. So yeah, that's a problem. Why is that? Wait, why is the width 168? Oh, that's the width of the output picture. Okay. Okay, I'm gonna name this image width and img pitch bytes, I guess. Img pixels as well, maybe? I guess. Width chunks, I could call this width pixels. Actually, you know what, I'll just call this width pixels. I just spelled it this way. That's a funny looking spelling. Boop. And now I can see that this should be chunk size instead. Okay, let's see if that works. Breakpoint? Huh? You're in breakpoint. Unhandled exception. A heap has been corrupted. Nice. Nice. Okay, so... let's not try to do all this stupidness anymore. Let's just try to... let's just do it manually, copying one by one, because this absolute mess, like I said, there's so many ways this could go wrong. Let's just... well, let's not try and do any of the copying of stuff at this moment, actually. Let's just see if these lines trigger an error. Let's just see if this propagating through the network works. at all. Yes, that apparently works. Okay, so instead, let's just go into a loop where we're manually copying every single thing. Every single pixel. I'm gonna change how this works. So this is, instead of being pixels, this is like pixel bytes. And a pixel would be an RGB triple, which is going to be pixel bytes as well. But it's, imagine that it's this instead. Okay, so let's just go into a loop where we copy everything one by one. Index image pixel of chunk x equals 0. And while this obscenely long variable name is less than the chunk size, we increment the obscenely long variable name by 1. And now we explicitly set, well, let's access this, int img pixel is equal to this times pitch oh shit, that's why I wasn't doing it this way. I swear, dealing with it being 24 bits instead of 32 bits is such a pain. Thank you, Chris. So the pixel is gonna be... Thank you. Is gonna be... Well, we don't know what the... Oh, no, we do know, actually. We do know what the... No, we don't. Don't fuck off. The pixel in the image is gonna be the... And this is just reading anyway. This isn't gonna corrupt the heap if we try to read something out of range. So it's gonna be... So this is the chunk times the chunk size plus this. That's the chunk x times that. Okay, sure. Well, this here is gonna become... this. And wow, I just copied a plus sign. Oh, that saved a lot of time. So this times the number of channels times the pitch in bytes plus this times the number of channels. Okay, I think that's correct. So the pixel bytes at this location are let's set those to... This is, by the way, this is just a single, the first byte of the blue. So this is the blue byte. 0 plus 1 plus 2. So this one is the neuron val on the output layer. So layout. Layout. Neurons. Oh, right, we need to calculate the neuron thingy now as well. So the byte of the neuron...
The vtube noise collection consists of hacking, nyan, and the hey.
Oh my god, the delay made it even better. Okay, so the neuron byte is the chunk. The index, the index like y-wise. Wait, I'm never even adding the... Oh no, it's correct, that's right. It's because we were just copying it in one go. But now, because I'm doing it x and y separately, I need to add the in-image pixel of chunk x. This plus 0. Okay, let's see if this works. I'm purposely making this as simple as I possibly can. Okay, it's complaining about a fake thing, probably. Yep. Alright, let's see if it works, I guess. Heap corruption? Yep. I don't know why that's happening. It could be a problem in here, it could be a problem anywhere, basically. Sheesh. Oh, I guess at this point I can also do free image unload DIB out. Wow. I don't know. Let's just follow this through step by step, I guess. For every single pixel. So, the image byte is 0, and the neuron byte is 0. Now it's 3. Now it's 6. Why do I have to like move my mouse pointer away and then move it back if I wanted to tell me? Okay, so at this point, we are out. Hi. That made me jump, by the way. I hope you know. Can't believe you, Chris. So where are we now? Y and X. So this is, so we're moving across. This is now 1. Oh my gosh, if you could just tell me things when I mouse over, it'd be so useful. So, the pixel X is now this times this, which is 0. Sure would be nice if you could tell me that though. Plus this, which is 1. And the Y is now 1 as well. So, the location in the image is now 1 times 3 times 504. Wait, why are we at 504? Oh yeah, right, we skipped a whole bunch, huh? Is that correct, I wonder? So the width in pixels is 168. 504 is that. And we're now writing at pixel index 1. This sounds a little bit wrong, actually. So if the pitch in bytes is 504, so this is how many bytes each row takes up, each horizontal row takes. Hi, Elk. Thanks for rolling on in. Oh, I see the problem. The row takes up this many bytes. It doesn't care how many channels there are. It's that many bytes. That would definitely cause a problem. Okay, let's try it again. Also, what is this equals thing? Oh, right. So the neurons range from -1 to 1, but I want to rescale those so that they go from 0 to 255. So for each of these, let's add 1.0 and then divide it by... So now they range from 0... No, yeah, now they range from 0 to 2. So we're going to divide by 1 to 7.5, right? Or multiply, sorry, multiply by that. And then this needs to be cast to a uint t. Oops. I reckon that was the problem. This part here. I'll if this works, I'll try to go back to this mem copy thing. Boop. Dude, the program finished running. Should we see what the hell we've just ended up with? In before it's noise. Or just like completely black or something. Where's the actual project? Here it is. It's 11 kilobytes as well, so this is like believable. Wait, that's the input, sorry, the output. Oh, interesting. Interesting. So you actually do have something with like a shape to it, huh? Thank you for the posture check. Thank you for the pads, Stewie. I need them right now. And hydration time. Thank you. Oh my goodness. The pad stacking. I'm a little suspicious about this. You can kind of see that there's like what looks like chromatic aberration, where there's like the reds and then the greens and then the blues, and the red and then the green and the blues. Like something is probably not being stored how I expected it to be stored. But now let's just see if the same thing happens when we do the memory copy. If it does, then we can probably just stick with that instead. So this is out X and Y being set. Let's just run this again. Let's see if this now works now that I removed this little multiplier thingy. And image pixel X times numchans. Wait, what? Hold on, what? Wait, what? End image pixel Y, end image pixel X. That's probably a fake error. Yep. Alright, run. Does it still crash? Yes. Same problem. Okay, that's very interesting. And why that is. So we know that this works and this doesn't. And every pixel of this image does seem to have been set. Although, maybe not every channel value has been set, because some are like... let's have a look at this in Paint actually. Okay, red and green and blue are all set there. It's not like it's not setting one of them. Yeah, they are all being set. It's not like I'm skipping the thing outright. Yeah, even there, the blue value of 1 is there. Okay. Which makes me think that that's kind of safe. Let's have a think. Items chunk size plus this, X times chunk size, the index in bytes is this times pitch bytes, which is what I'm doing there, plus this times this. Okay. And I'm writing that into... Wait. Wait, I actually don't know what I'm doing wrong here. So this line here is like absolutely identical. And we're just writing to something starting at this position. You know, let's go one by one. This is now only going to repeat for each row, so it's not going to go. It's not so many things to have to step through. Okay, so for the start, we copy into pixel byte 0 from neurons. Wait, is that the right destination and source? Yes. Number of pixels is 100 and... Oh. I see the problem. I see the problem. The number of pixels should be the size of a chunk, not the size of the entire image. Okay, let's see if it works now. Yay! Okay, now let's compare the images. Holy crap, they're completely different. Oh my god. There is something changing in there. But wow, I clearly don't know what I'm doing. Well, clearly something different is happening because I thought these two would be completely equivalent and they're both wrong in different ways. Let's go back to debugging. Okay, so the number of bytes we're copying is the chunk size times the num_chans. Can you tell me what that is, please? Chunk size is undefined. Alright, I'll work it out for you. 12 times 3. 12 times 3 is 36. Wait. No, that's correct. That's correct. So if we do 36 times 12 again, right? Then so it's 12 by 12 by 3. Then we should end up at... Yeah, that's the size of this channel. 432, right? 12 times 12. Yeah, okay. Okay. So I think that's correct. So next time we go around, we're now storing at byte 504 from the byte 36. So what we're doing is we're skipping through this, the neuron there, by the width of one chunk size, basically, times the number of channels. But for the image, we're having to go on to the next line. So the 504 here should be the entire width of the image measured in... Yes, measured in bytes is 504. Okay. Yeah, so this just keeps on going up. And what can I say? It looks like it's doing what it should do. Let's wait for the next block. So we copy into the neurons from this position. Can I see where this started? This minus all mid vowels. 56. Wait. Wait, yes, correct, I think. Wait, is this right? Is that how pointer arithmetic in C works? If I subtract one pointer from another pointer, I get the difference in units of the data type instead of in bytes. Okay, well this one is 00999D30. 999D30. And I want to subtract 999C50, which gives me decimal 224 divided by 4 is the 56. Yeah, apparently it gives me the... Okay, that's doing what I thought it would do. So it seems we are copying the correct stuff. The correct... moving on through the, this picture by the correct number of pixels. And it looks like the value stored there is like very sensible as well. Minus 0.3, minus 0.3, minus 0.3, minus 0.3, minus 0.4, minus 0.4, 0.3, 0.2. But I'm gonna be honest, this picture here looks a lot nicer than this picture here. I don't have any faith that this is like correct. This one, I reckon the problem is, I don't know, somewhere here maybe. But this one, this just looks bizarre. Okay, stuff is not working how I thought it was working, huh? Let's follow the logic through this again. This part that propagates the values down through the network from the input to the output. So mid to 1, 1 to 2, 2 to out. Okay, so imagining this is the mid and this is layer 1. We start with the position of the first neuron on the destination layer. And every time we set it, we advance it by 1. And it's tanh of this. So let's see how this gets set. Oh, this as well. Okay, and I was manually copying those over as well. Oh yeah, I had to get those into the correct range. Okay, so on the destination... We're never actually using these values, are we? No, these are just like counters. We repeat it a certain number of times. I don't think there's likely to be a problem with this or this because the layers are sometimes really narrow and sometimes really tall, and we're never getting an error that we're accidentally blowing past the end of one of these arrays. But yeah, it's like if one of them was wrong, that would be likely, I would expect. Okay, the source neuron comes from here. And we take its value and we multiply it by the current weight. We add that to the total. But again, I doubt that there's something wrong with this because... Well, actually, I haven't looked at the values on the middle layer. Let's set a breakpoint and see what the values are. Oh, I mean, they're not going to be crazy, are they? Because they're going through 10-inch. But whatever. Okay, let's have a look. Neurons. 0.18. Yeah, that's believable. Minus 0.38. Yeah, these are all going to be sensible values because they're going through 10-inch. I guess I have to double check something, huh? Oh, wait. Did I did flip this. Do I need to is OpenCV also doing the same thing where it flips the image? Hi, Foxelf. Thank you for the pets. I wonder, let me try not flipping the image on all of the images that are being loaded. And let me put it back to this old way of doing this because this... Well, the simple way of doing this because this will look a lot more promising. Boop. Mac. Hi, Fox. Why, what is this? I feel like I'm being mocked. Have a nice look. Okay, this looks much weirder and this looks much... They both look weird though. Why are they splitting out into this red, yellow, green, red, yellow, green, red, yellow, green? I don't think there's anything. Like, I didn't, it wasn't trained on anything like that, so something's going wrong somewhere. Obviously. Not really sure where to look. I guess what I could do is get PyTorch to output what is on the next layer as well. Not just what's on the middle layer. And then I can try to match that up. Let's, sure, let's try that, I guess. Is there an easy way to do that? Not really an easy way. No, that's gonna be annoying. I think I might leave this now because this is like... This is gonna require quite a lot of looking into, and I feel like if I start now and it's coming up to 3 AM, it's probably not the best. But hey, at least we have the images loading in, and we have some image being created. Why is it? Is this actually for real this time? Is this a real error? Nope, it wasn't a real error, it still compiles. Wow, okay, it's just convinced that there's an error forever now, huh? A for error. Let's exit this and then reload it. But at least we have an image being output. It's not correct. But I mean it's not crashing. But in a case like this, a crash might actually be useful. It would help point me towards areas. Guess I'll do a tiny bit of sanity checking as well. This image was 12 by 12, right? I mean, each of these repeating things. We just measure from these over to there. That's 12 pixels. Well, that's a 12 by 12 pixel region. Interesting. There is also the possibility that I'm not writing this correctly from PyTorch. Although it is being loaded in back by my Python thing correctly, it might just be that I'm writing it out wrongly and reading it in wrongly in the same way. Do you know what I mean? Actually, there's a way to test. There is totally a way to test. Let me just, I said I was going to stop. I'm just going to do another quick test. Let's use this image, but I am going to turn off all of the blocks apart from the top 12 by 12 region. So starting at pixel 8, 9, 10, 11, 12. So this should be a 12 by 12 region up here now. Oh, it's 11 across. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we are. Thought I did that the first time, but apparently not. And 12 down. Okay. Because this should... Well, it'll help a small amount make sure that I'm doing what I think I'm doing. I still could be writing those 56 values wrongly though. Oh, hold on a second. Am I applying the extra fancy thingy that I'm not... Where's my thing gone? Python? Python will get it because it went away. Okay, so that is set to true at this point, but down here I set it to false. Okay. Let's run the thing. Boop. Dribble index out of range. Oh, this should be called test org. Test org. No, not tense. Oh my god, I can't even type anymore. Oh my god, I actually can't type anymore. Maybe this is about time that I end. I think it. Dribble index out of range. Huh? Huh? Can't open... Oh, whoops. I have it set to the mode where it's trying to read a thingy. I should be doing this. Okay, nice. So the original was this, and output is this and stuff. Yeah, okay. No, this looks exactly how I'd expect it to look. Just the first 56 values here are, set, and the rest are all the same. Yeah, I mean, it looks how I'd expect it to look. Let's just count the number of them. From here to here, 56, yep. Aww. That's a cute high. I think I've seen that high one before. Well, maybe I have and I just have no memory. 56 is typed there. It's loading them in, meaning -1 to 1. Oh shit! That's not the maximum! This is a range! This is a range! The range should be 2.0, not 1.0. Okay, let's run it again. I don't think this is magically going to be correct, but let's see what it looks like now that the range is correct. Let's at least get a correct wrong image. Hi, Albert! Where is the... Oh, it's this. Whoa! Whoa! Look, if I rotate this to the right, you can actually see the face with the mouth and everything. Oh my god! This is so cool! And look, now it's all grayscale and stuff, which is really weird as well. Okay, this is so much better, holy crap. But again, there's an issue with the right and left, like width and height. Okay, holy crap, this is suddenly a lot better. Also, it's like repeated 3 times in each block, which makes me think that I'm doing something silly with the blue, green, and red channels and stuff. Wow. Okay, this is interesting. Hi, did you know what the fuck am I staring at? I'm trying to make a decoder for an autoencoder. Blah 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 blah. I'm sorry. I've explained it so many times, and I don't know how to explain it in a short way. Also, I was meant to be ending stream already, but I just suddenly, right now, made a breakthrough. So, I guess I don't know if I'm gonna continue. It's so suspicious that it's like +0 plus that it's like 3 times repeating as well, and yeah, basically for VRChat to be able to make an avatar, upload, share an image. Upload is like a weird word because when I say upload, it makes me think that it's being stored somewhere, like on a disk or something. But it's more like to display. It's almost like to stream an image to someone. It's not like being stored anywhere, really. Beam it to the interwebs. It would only be being stored in VRAM. Wait! This should be multiplied by 3 as well. Let's try that. This should get it a little bit closer again. Still won't fix the rotation though. I mean, it looks different. I'm not sure if that's better or not. I'm seeing like 3 by 3 errors now instead of just 3 error. So it's like I'm making a mistake in 2 areas now instead of just 1. Oh, wait, sorry. Hold on. Bytes. Oh no, that's correct. That was correct. So the byte is... Oh, that's a neuron byte. Whoops, sorry. I fixed it in the wrong place. This one should not be there. This should be for the... Oh shit, no, I am doing it correctly. Oh, god damn it, I'm doing it correctly. Fuck. God damn it. Fuck. Why do I have to be doing it correctly? I thought I was fixing it. No. Thank you for the hydration. Pixel X is the chunk X plus the current blah blah blah. What the hell? That was right. Why was my other arm going up? Thank you for posting check as well, X. Out of curiosity, I want to see how this super wrong one now looks. I know it's gonna look like worse, but you know, I just want to see how it looks. Boop. Ah. Hi, Wise. Yeah, it's so hard to see anything correct in that. What if I rotated this way? Yeah, I can't really see anything in that. But, I mean, there's structure to it in some places, but it's so noisy. I really don't know why though. I really don't know why. I'm gonna be like kicking myself if I work this out and I look back in my VOD and I'm like, fix it! It's so obvious. Y times this plus this times this. That's the same as this. Times the number of channels. Oh, wait a sec. It shouldn't be the number of channels for the neuron is not 3, is it? It's the middle layer. Non-neurons mid, I think I called it. In the Python side. Let's try that. Boop. Okay, never mind, it's crashing. I guess it was correct. Oh, wait a second. I've got both still enabled. Boop. Okay, it's still crashing. Where's it crashing? Reading location. Where can I see it? I want to see. This line. 201. Okay, never mind. That's, yes, not right. So the byte on the output layer is the current position vertically times the number of neurons. So this basically converts this a pixel into 56 times the chunk size. Yeah, wait, why is that? How is that wrong? Bye bye, Tingu, thank you for the luck. Bye bye. Have a nice luck. I'm waving with both hands, and there it goes. Neurons mid should be 56. Chunk size is... Sure, it'd be nice if it fucking told me when I moused over, but... I don't know why I can't when it's a define. Anyway, so we start at 0.
Käse.
And then cheese gets thrown at me. I boom! Next time round, it becomes 672? That's way higher than it should be. So a chunk size is... Oh. Right, we don't care about how big the chunk is in pixels, we just care about how big it is in neurons, huh? Okay, let's try again. Boop. Okay, no crash. And now it looks like this. What? This looks even worse! Like, even less structure to it. I mean, it's just some stuff is repeating all the time. And there's some kind of weird optical illusion going on here, because I keep thinking I see stuff, like, waving, like, going... Oh, I see it. I keep thinking I see stuff going across, and then up at an angle, and then down at an angle and stuff, but when I look at it, it's really hard to make out. Every other row is the same. Every other row is the same. Every other row? I actually don't even know. So I'm assuming this is a 12 by 12 region. Yeah, that's a 12 by 12 region. So like... I'm probably reading past the end of the array or something there. Okay, let's check this again. I'm silly. There was not a problem with this. This is the output layer. This is the output layer. This is not the middle layer. There's nothing wrong with that. That was correct. That was correct all along. So the problem with it is not because of that. This compiles again now, right? This is how you... Oh wait, it's got all of the other crap still enabled. Somehow it did just work, but... Yeah, that's how it used to be, I guess, roughly. Yes, it looks the same even after it's... I really don't understand why this is different to this. I wish there was something that could tell me and analyze it. I wouldn't trust... I don't know if I'd trust ChatGPT, but also I don't have access to it, so... I mean, to be able to do it, I don't know if I'd trust it. This times pitch bytes on the output. Yeah, I think I might end the stream actually, because although I did just have like a big breakthrough, I don't understand. Like there's some fundamental thing here I'm not understanding, because this and this should be identical and they're not. So I don't really have much hope of being able to work out, you know, why it's wrong if these two things that I think should be the same are not even the same. X is X of chunk. Y, oh, this shouldn't even be there anymore. Y. Oh god. No! Wait! Why? What is a Troops Fest? I don't know what it is. I'm back. Y equals chunk times the chunk size plus the thingy. Also, onion for the cobalt. Hi. Sorry, that was a bit of a sudden yan. Should have warned you. Also, it's 311. I had to look up the word because I didn't even know if it existed. It's the word for sharply. That took so long for it to start tracking my thingy. Ah! Jeez! Ah! It's the word for sharply sucking in air, the gasps. Oh, like that. Hi, Dara! Why are you throwing cheese at me, Dara? Just because I'm trying to decode a thing and it looks like... It looks like... this. So this here? Can you make out what it's meant to be? Dara? If you're here? Okay, I guess it kind of is spooky. It's this emote. This one. I'm motioning towards it. Yeah, that one there. But it's not quite right, huh? It's flipped horizontally. Yeah, it might be. This is it flipped the other way. Yeah, I think it was flipped horizontally, yeah. It was also rotated, so maybe there's a better way to fix it. So would it be better to do a vertical flip and a horizontal flip? A vertical? No. How do you do this? I thought there was some way that you could do both that. So it's like rotated and horizontally flipped. I'm pretty sure it was flipped. This way is unflipped. And this way is flipped. Wait, how do I explain this in English? This is what it originally looks like. Now I rotated. to the right. This is what it looks like. But I think that this should be this. Anyway, it's this doesn't help me. This rotating and stuff. I really don't understand at all how it's coming out rotated. Is there a problem with how I'm storing the image? No, because I'm just working my way across the image. I'm just starting from the very first pixel. And the pixels go across horizontally. I'm not rotating the image. I think something is going correctly with some of the neurons, because in the area where my mouth is meant to be a solid color, it looks fairly solid. And in the areas where there should be outlines, there are outlines. There are many of the outlines repeated, but there are outlines. So I'm almost tempted to say that at least most of the layers this is working for. Maybe the last layer it's not working for? But it feels like the problem is happening later on. Let me just do a quick sanity check. This image is 784 wide, 784 divided by 56 is 14. Okay, that is 14 chunks right to left. So that's correct. I'm loading the correct images in right deck 1, wait, 1 bias. I'm never adding the biases! I'm never adding the biases! Whoops! Oh shit, I'm never adding the biases. But I mean, that's not going to be responsible for it like repeating many times. But this will help. Okay. So, after we've added all of the previous... Wait, what am I doing? After we've added all of the source neurons, we also want to add the source. Is it the source? Is it the source or the destination? Hold on, let's have a look. So on the output layer, there are 256 thingies coming in. Okay, no, so it's the previous layer. It's on the middle layer. Wait, on the middle layer? Where's the middle layer? Middle bias? Is it not a middle bias? Wait, what? Deck 1 waits. Or are these biases applied to the current one? Okay, yeah, must be this one then. So, destination, so this is bias destination equals layer destination bias is. So we need to add, after we've added all of these input neurons, we also need to add val total plus equals that, and then we advance this pointer, and it's the that. Okay, let's see if that helps. Didn't realize I was still running. Let's see if it runs first, I guess. Yep, it runs. Let's see what image we got. Okay, nice. That is much better brightness now. Nice. Okay, so the brightness is kind of fixed now. This is like the actual correct grayscale values now. But why is it grayscale? Am I creating a bitmap of the wrong type? It's the width and the height is set correctly. The bitmap type is set to bitmap. The number of channels Sorry, the number of bits per pixel is 3 times 8, so 24. Width, height, color as a null pointer. Is it that it doesn't like, I wonder? That'd be crazy. Everything about this seems to be right. Why is it grayscale? You know, it's grayscale in most places, but in some places things are misaligning just slightly to prove that the bitmap is a color bitmap. Isn't it weird that it's like decoding to like grayscale? How is that even? I'm writing, like, I'm setting the values of this to different output values as well. Let me set a breakpoint here. Also, what is the color of the top left pixel of the Keku image? Okay, it's hold on. Oh, it's very dark actually. It is not black though. Okay, so can you like tell me what it is? 13 and 13. So this is, it's really annoying that it doesn't just tell me when I mouse over. Oh, because I'm no longer inside there, okay. No, I don't want to stop. So this is 1 plus 0, 1 plus 1, 1 plus 2. Isn't it so weird that it's decoding to like grey? That is so bizarre. Source neurons always gets reset to the beginning, that's fine, but the weights never get reset. Yeah, I'm starting to... I feel like there's a problem somewhere here probably, and a problem somewhere here probably. Or I should say maybe a problem somewhere here, and in how I'm interpreting the bitmaps that... these bitmaps that PyTorch wrote. There's probably something wrong with both. 0.11, just making sure these values match. Range 0.7, 0.3, 0.4, 0.24, 0.68, 0.20315. Yeah, these are all correct. When you're writing the output pixels, you're writing index plus 0, 1, 2, but incrementing the loop only by 1. Incrementing the loop. This loop? Yeah. Well, the value here is a thing plus... Well, okay, this x is based on this, which is going by 1 every time. This has this added, so this will be having 1 added each time. But this one is based on this multiplied by 3. The number of channels is 3. So this value itself should be increasing by 3 every time. Also, hi Snowcone, thank you very much though for trying to help, because I need all the help I can get right now. So 0 and then 3 and this. Oh shit! Well, there's a problem here. This one is only increasing by 1 each time. Oh! Oh! Huh.
Cheese.
Cheese. You know what? You know what funny thing is? I was trying to add this to some other area, and I accidentally added it to this line first. But now I realize I maybe should have added it to this line in the first place. Also, hi Maradona. Welcome. Wait, is that it? Has something changed? Wait, did something change? Wait, have I run it yet? I don't know if I've run it yet. Okay, I've run it now. And yeah, it looks the same. I mean, I guess it's closer to being right. Wait. Each chunk is... It might be that each chunk... It looks like each chunk is rotated almost. Obviously the entire image is rotated. But look, where there's meant to be a vertical gap, it's like horizontal. And where there are meant to be things running nearly horizontal, they're vertical. Obviously it's also repeating 3 times. I don't know why that is happening yet. Whoosh. Looks fine to me. Sorry. I'm gonna calm this music down. This music needs to relax a little bit. Shush. Shush. Relax. Relax more. Okay, so I think that is correct now. But I might be reading... You know what? Let me just swap this. Let's swap the X and the Y of these to hopefully flip each chunk's X and Y, if you know what I mean. Okay, now it looks like this. Hold on a second, I just screwed it up. Okay, that looks even closer. Now look, we actually have vertical lines at the edges of the mouth. Basically, we've got all of the outlines. There are like 3 outlines now. Okay. Why are there 3 though? Why are there 3? And why is it grayscale? Okay. Let me make a note. We swap X and Y below. I guess also if I swap the X... Wait, which do I want to swap? Hold on, let me just try an image that's not square. If something goes very wrong... Okay, 3 color channels. Yeah, red, green, and blue. Or blue, green, and red as they're stored. Let me yoink an image that's not square. Let's... Okay, this one's not square. What is this? No, it's still got extreme stuff. Okay, let's run this one through again. Historic. Oh, that's the wrong command. Terminal prompt window, blah blah blah. Boop. Okay. So this now describes this image. So let's copy this one instead over to the test. Yoke. And I need to tell it that it's 30 by 21. So 30, 21. Okay, it's done. Yep, so there is some issue where it's doing like width where it should be doing height. This correlates with when I drew something on paint on the middle layer in the order that I expected it to work in. It actually was like rotated sideways when it decoded as well on Python. Either new weights and biases. No. I didn't just retrain it. It's fine. I just ran an image through it. But the weights and biases remain the same. Training takes some time. Maybe half an hour or so. Which granted, in terms of training a neural network is not particularly long, but... Okay, so I think I know what the problem is. And it's that in here, where I'm loading the chunks from a file... Yeah, why am I doing it this way? Why am I adding the chunks in Y order instead of in X order? Why am I doing that? I'm sure there must be a reason. Let me swap these around. And run it again. Hang on. Sorry about the multiple flashbangs. Okay. Size and chunks still says 30 by 21. Let's copy the file from here into here. Okay. And now the output. Oh god! I just realized this is now scrambled. But it's correct here now. Okay, so some other part of the code where I'm doing this. I'm putting the images in the wrong way. Okay. So I'm storing X going across and then down by 1 and then X going across and then blah blah blah. So when I read an image in, it's getting stored in that way. And just every time I'm reading it, I'm reading from... If I'm not mistaken, this image is Y:X. I guess we can double... Well, yes, it must be. Right? Are any of these chunks big enough for us to work out what we're looking at? Okay, let's see if we can see the tip of this. It's really hard to work out where it'd be. It's somewhere around here. Yeah, it's really hard to tell if it's been rotated or not. I guess I could temporarily increase the... Oh no, that'll crash. Well, let's just make a test image. There's no law that says we have to draw something nice. Let's make this 24 by 24. And in the top left, I'll just, what is a letter that always reads the same each time? Doesn't have symmetry. I guess the letter P. Let's write that P1, P2. P3 and P4. 4. Yes, this is meant to be a P. There we are, now it looks like a P. Are you convinced now? Okay. This doesn't look like a 4 there, but whatever. Let's save this as historic. Boop. Boop. And the output is this. Oh, right. This is showing the stupidity of how it's loading images. You know what? Maybe I should fix this now as well. So if it's a perfect multiple of the thingy, it is not loading that chunk. And I need to remind myself why that happens, because I wrote this code really quite a long time ago. This neural network code. I just only now recently finished it the other day. That's why I'm seeing this again. Okay, so rearrange from chunk yx call to chunk call yx. Uke has outlasted all the chatters. Eyes off. Okay, so it goes up until the height minus the chunk size. Oh, I see why, yeah, right. So I wanted to actually go up to this inclusive, so I have to always add 1 there, because range never goes up to that. I guess I'll just put +1 in there, and it should just be okay. Somewhere else it might crash though. Okay, where's it crashing here? Wait, why is it saying size in chunks? Where is this? Yeah, so we don't do this anymore. That's what I was worried about. Okay. So now it says it's 2 by 2. Nice! So this is the input. And the output is... Oh my god, that's kind of hard to read, huh? God damn it, I can't quite make out what it says. God damn it, I don't know what it says. Let's compare this. Let's compare this one. Oh my goodness, there's so much going on. Oh, I'll get to it in a sec. Oh wait, no, it's clearly the same. It's clearly the same when I do this and I overlay them. Okay, so you can see now it's changed to P1, P2, P3, P4. Whereas the original was P1, P2, P3, P4. Okay. Okay, nice. This is actually really cool. We're getting somewhere. Also, Nyan! Thank you for the pets. I hope the Nyan was to your liking. Sorry for the delay. And sorry for the delay of the posture check as well. Hiya squared, or A squared. 31415. Was it 3.1415926 or 265, right? 265. I don't remember the rest of it. There was a time when I memorized pi to quite a few digits. I can't remember how many, 20 or 30? More than I usually would. I know that's nothing for some people. Or it might have been even 40. The way I did it was I remembered shapes on the numpad. I just kind of split the number into certain shapes. Yeah, I was just looking at the numpad and doing it with my hand. But that was a long time ago, and honestly there are better things for me to spend my limited brain cell on. My limited singular brain cell. Okay, so now the chunks are being stored top left, top right, then down by a line, bottom left, bottom right. But when we're getting an output, it's coming out in a different way. So, let's have a look at the size and the width and the height. Yeah, number of chunks is great. So what we do is we prepare these chunks which are now stored. Oh, right. We prepare the chunks. So here's the thing. Internally, images are, when you're dealing with them as an array, they're sort of stored in yx rather than xy. Because as you're defining the shape of an array, the first things you define are the things that change the least often. So, for example, you might have, it's like you're gradually looking deeper into the array. So it's effectively like you have, like, maybe you have a huge array that is like each separate image, right? Something like this, and then the array finishes. And inside this is like an array of y positions effectively. So you've got this, and then you've got this line, and then this line, and then this line, and then this line. And if you zoom into this line here, itself is an array of pixels going across like this. And so X is like the innermost one and Y is the outer one. And then the image itself, which image it is the outermost one. And so when you're addressing that, it's like outer, then next inner, then this one. So it will be image, Y, X. Thanks for going to my TED Talk. You had 50 digits? Holy crap, okay, it's definitely more than I had. What have I done? Oh. So, the way in which we're going to be passing this array, where we've stored it horizontally first and then vertically, it's like, it's as if the horizontal chunks... Yeah, you can kind of see why this has happened, can't you? I think
cheese.
Cheese. Hi, Jia Young, by the way. Very good talk. Thanks. Let me think. Shit. I choked on myself. Hi, Street. Welcome back. Thank you for the pats. Okay. So the height in pixels, the height, width in pixels, height in chunks, the width in chunks. So how are we doing this? We are... Oh, okay, well that's the only reason why we're reading it backwards that way. We'll do... the wide... Wait. Wait, what? Oh, I see. So they're stored horizontally, but they're going down vertically, yeah. So we want the X to be changing. Y pixels goes across. X pixels goes across. So don't I just need to do this? Yeah. I should fix that, I think. Yeah, okay, so the original input is this, and now it's outputting it like that. So that's the same. Okay, so that's fixed now. So when I run it on the Baidu pick again, or, yeah, I do pick, because I was about to say, oh, I could just do this, but no, because that's square. Now we've got this stuff again, and it does decode correctly here. And when I copy this... Wait, does this still decode correctly? I hope this decodes correctly. Let me shrink this down to the width of how many chunks was it? 30 by 21. Hopefully we'll be able to hopefully we'll be able to see something in it this time. Sure. Okay, nice. And let me just optimize contrast. Okay, that's maybe a bit too much. But yeah, you can see that there's an empty area around here, then there's something going on at the top right, and then some stuff going on here again. So this correlates with this. There's some text up here, there's a shape here, there's a little something going on up here, because there is there as well. Let me just give it some contrast, but I don't want too much. Yeah, there you go. So you can see there's something going on up there, and yeah. Alright, nice. So this now works. So if I were to do a really silly thing like I did before, then yeah, it should just... I can't bother to do it again. Okay, let's copy this middle layers picture back over to here, and this should make the same thing as is already there. It's just finished running, and yes, okay, we've got the picture. Like, literally. Okay. So now we're back where we were, but stuff is laid out how I expected it to be. And it's not rotated and flipped anymore. How's the going? It's getting there. It's no longer rotated and flipped. It was rotated and flipped. And yeah, it looks like this now. So let me just have a close look at this. So that is 4 pixels, that's another 4 pixels, and that's another 4 pixels. So again, this is splitting into 3 here. It's so suspicious. It's super sus. Like, we're forcing it to grayscale and float, so the problem shouldn't be here. I don't think the problem's in the loading of the image at all. It could be here, and it very easily could be here. Okay, let's set this now to be doing the now correct thing that I should have been doing before. So we just swap this for this. See if the memcopy version can work now. I doubt it very much, but you know. The byte. So we only care about what the index of the byte is at the very beginning of the copy. So we do... Let's spend this one. We swap X and Y below. Wait, do we need to... Yeah, I guess we... Do we need to do that? Still? I mean, yeah. No, wait, let me try and not... Yeah. All I've done is change the order in which chunks are loaded. I haven't changed the order in which... things inside the chunk are loaded. I think this looks maybe correct still. Let's just do the switcheroo again. Boop. And it's done. And it looks like this. I actually don't know if that's better or not. Yeah, I'm not really sure which is better or not. But I really want if I could just fix the repeated streaks. That would kind of yeah. So I just switched the X and Y of the pixels inside a chunk. Sorry, of the kind of how I think I'm reading it from the output layer. Okay, let me just put this back to here. So in pixel X now should be equal to. Wait, there's the pixel X here. The pixel X is the same, I think. But now this is something different. So we're not caring about which pixel we're at inside the chunk, because we're just copying everything from 0. Hold on. Yeah. And the pixel of chunk Y. Like the number of channels times the chunk size. I'm guessing this is just going to be nonsense again, because I still haven't worked out why one's worse than the other. Yeah, look at that crap. But hey, at least you can kind of make out a shape now, because, you know, it's reading correctly, in terms of X and Y. But holy crap, how does this happen? How does that even happen? Like the weird thing... Oh! Wait! Am I being stupid? I'm being very stupid. Do you know what the problem is?
Cheese it.
The problem is that I'm copying floats into an array of bytes. So I will have to go through them all one by one anyway, so it doesn't really matter, I guess. Thanks, Stu. I definitely deserve that.
Cheers.
Fine, I'm sorry, God. So this is like a commented out comment. Stop! Okay, but why are we getting like the 3 repeated things each time? Thank you, Boom. Sorry, thank you, Stewie. Not Boom, you cheesed me. I have been cheesed. I'm trying to touch it, but it's difficult. There we are. So we're scaling it into range there. It's so bizarre that it's grayscale. I cannot convey how bizarre it is that it's grayscale, but just not quite. There are like some colored parts showing through. Like that is so weird to me. How it? I was like, there's some red. I was white. I was very fishy. I just don't understand how this can be happening. Like, how can it be fading in such a perfect way that it becomes grayscale most of the time? I feel like it's grayscale because it's the same value repeating across all 3 channels instead of them all being unique. Yeah, but like sometimes it's not. That's the weird thing. It's so weird. It's like it's almost fading in a perfect way, but it's not. I mean, like the perfect way to confuse me.
Grayscale.
Hi, Cobalt. Why grayscale you? Grook? Why the Grook? I mean, I would have even more doubts about this. No, never mind. I would have more doubts about, well, not that, but this. If it weren't just working in the exact same way as you know, the this. If I weren't writing it in the same way. But let's have another quick look at this. So this here is input is along the x-axis and output is along the y-axis. So we're outputting to many color channels across there. And yeah, you can see that there are like some vertical lines that are running up, which would imply that those are similar to the red, green, the blue value is similar across all of those, but like it's not all of them and they're not all aligned with each other. Like I would expect some correlation between in like every 3 or so, because you know, it's red, green and blue and it's unlikely that one neuron is magically going to control only the red channel. It's probably going to make them all a little brighter, a little darker. So this doesn't look sussy to me. This doesn't look suspicious. So I'm not sure where it's going wrong, apart from the fact that this is like, I'm clearly fucking up somewhere here. So my maximum suspicion right now is on this area because, stuff. Although wait, no, now I know why this was failing actually, so I know why that was failing now. So I'll just remove that actually. These are floats. And this each time should be increasing. So this is 0, 3, 6, 9. This is also 9, 12, 15. Hold on, wait, why is this? Oh yeah, right. So when this goes past 11, 10, 11, this should wrap back to 0 plus the entire width of one row in bytes, and this should just go up by 1. So this is now 1080, and this has just gone up by 1 indeed, or well 3. So wait, isn't 1080 more than it should be? The width of one thingy is... Oh, it's 1080. Oh, right. Okay, never. Right, because we're on a different image. This is a wider image. Okay, no, that's correct. 1080 is correct for the Baidu image. Okay. Okay. And this value is 0.01004, 01004, 01004. So yeah, it is like, it's grey. Even though we're looking at +0, +1, and +2. So the actual value in here is like roughly the same for every 3 for some reason. I kind of think that this is working for visualizing things. I feel like if I want to be able to debug this further, I should make an image like this. I should get this program here, this program, the new one. I should get it to output an image like this for the intermediate layers. Layer 1 decoded and layer 2 decoded. Because I want to see what's going on in those middle layers. And I also want to get the Python program to do exactly the same thing. Exactly the same. So then I can compare what the values of those neurons should be with what they actually are. Okay, it's almost morning, go sleep. I know, I'm sorry. Actually, I could literally just for the. I could just make an image that's. Actually, just take a tiny chunk of the Baidu picture. Like, that's not Baidu. I could just, although it is cat, that's actually probably a nice thing. Actually, let's take a piece of cat. I'm gonna purposely take a piece where there's not much black. Sure, let's do this part. How does that look when it's encoded, by the way? I forget. Okay, it is still red. Which part should I take? Maybe this area. 12 by 12 region here. 12 by 12. Just get a bit of the blue as well. Okay. Okay. Boop. And save that in here. Put this again. Wait a minute. Where am I? Close this, close this, close this, close this. Close Tweak PNGs folder. Close the searching for a file thingy. There, I've got more space now. I've half ended my stream. I've like closed some of my stuff now. Okay, let's run this. 1 by 1, nice. So that's a nice edge case test as well. And it output this. Yeah, this all looks fine. So that's its output, and that's what's gone in. Okay, so none of that's like grayscale at all. I really like these colors. I like both of them. It's like a sunset almost. So let's take the middle encoding, which is just one row of 56 pixels. And let's give that to this. And I would expect it, well, I don't know. I don't know what I expect at this point. Let's save this as Baidu before I copy over it. Or instead of copying over it. And run. We don't crash. Hope this handles. Oh, it's crashed. Okay. Okay. This is interesting. Nice. Okay, I actually really like the fact that this has happened. Oh, wait, is it just because it's failed to load something? It managed to load all the images, right? Thank you for the hydration. Grr? Did I say, was I like hesitating when saying grayscale or something? Thank you, Ixia, and thank you for the pasta check. Oh my god. There were some cracks. I think my noise gated the noise. So what's the error? Is it from reading or writing? Reading. Okay. So this is the source. So it's trying to read from mid vowels. Which is 672 pixels further ahead than it should be. Okay, hold on. Wait, int chunk x is 12? What? Okay, hold on a second, there's something weird going on here. Wait, what? Oh, right. Whoops, I still have this marked as being 30 by 21. Let me make that 1 by 1. Wait, it should be able to work out the number of chunks, actually. From the mid vowels. Although... yeah, it's not actually... okay, whatever, I'll just hardcode it for now. But look at cat girl sick folded yet. Yeah, I just did. Okay, that works. And the output is this. Again, we've got like these 3 repeating sections and it's mostly grayscale. Okay, so what we can now do is we can breakpoint at here, and we can like poke around and see what the values in here are. And if I change this, I can printf the... Oh, sorry, not printf, but print the values. Mid propagation, wherever that happens, forward, here we are. So we can actually just say that blah equals x dot, put it onto the CPU, dot detach, dot numpy, and x at this point should be just the values put into a way that we can actually read them. And I want to like just printf. Wait, can't I just printf? Sorry, can I just print this? Then we should get all of the values on this of the neurons. So 256 values. That is the values on lay deck 1 after it's gone through 10H. Let's see if that works. I don't know if it's going to be happy printing this in the middle of... Oh my god, it is! It just fucking doesn't! Wait, why is it printing 2 sets of values? Oh, it's printing it twice. Oh, right, because it's... I'm calling something twice. I'm calling .iter twice. I'm calling it once here to output the image exactly how it would be with floats, and I'm calling it once here. That's not it. Yeah, that isn't. Actually, so that it outputs exactly the same values, let me just make it decoded from a middle image. Test org mid. What if you open it in Photoshop and look at it in channels individually? I'm gonna pass on that one right now. Test comp. Right, this is a compressed version. You should only get one. We do only get one. Okay, so these are the values that we've got. These are the values of the first 4 neurons on the layer decoder 1. Here we are. And there should be 256 of them. 1, 2, 3, 4. Oh, is there an easier way that I can... Oh my god, not the song of the children shouting. Let's go over here. Boop. It tells me that there are 64 lines, and 64 times 4 is 256. Nice! Thank you for the pats, by the way, Devil. Can't remember if I said that already, but I'm saying it again. If I have. Okay, so let's run this and see what the values on lay deck 1 are. How do I... Can I like... Here we go. Neurons. 0.447575. 470505. Okay, these values are not the same. I mean, they're close. 0.5 something here? So the next value... Wish I could like just look at the values. Lay deck 1 dot this dot really neurons 1 50087. Oh my god, can I please alt tab? 50073. So they're close, they're not the same though. But this isn't enough to make wildly duplicating things. 13907 141. Why are they not the same though? They're close, but they're not the same. 0.5254 5259. So they're really similar, and they're like changing at the correct frequency going through it. So that's something. That doesn't explain how we're getting like duplicate every 3, you know, like the thing split into 3, you know. Next 5667, but it's actually 5683. 598, but it's actually 597. 6779, but it's actually 6733. Okay, so this is already raising a red flag. I don't understand why these are different at all. But they're close to each other, so that is not the reason why we're getting the 3 shadowed copies, if you like, shadow copies. That's something else. I wonder if the bias is applied after you've done the 10H. Surely not, right? Surely not. I mean, there's one easy way to find out. No, surely not, because then the neuron could get outside the -1 to 1 range, which should never happen. Yeah, I'm sure that's meant to be inside. It's weird that the values are different, isn't it? Let's look at the very last one, 2178. Actually, let's... I'll quickly have a look. Oh, I removed the breakpoint. Boop. 255 2145, and over here it is 2178. Yeah, okay, whatever. They're not the same, and I don't know why. I think, yeah, I don't know. I'm not sure what the next stage will be, but I think I'm gonna call it there for now, because, I mean, we've made a lot of progress. Let's just remind ourselves how much progress we made. We now do have, if I decode the Baidu one, let's call this cat block. Baidu, let's put that back to this file name. We do have, wait, oh, I didn't, Snowcon! Thank you for the follow. I don't have the width of this. Was it 30 by 21? If I remember rightly? Let's see if that's correct. If it's not correct, we're probably gonna get a segfault. Or just a terrible looking image. No, I remembered correctly. I can make it read this directly from the image, but I don't have a good way to do it right now. I'd have to like load the image twice or somehow pass values out through this for width and height, which I don't care about for most of these, only for this one, so yeah. Although I guess it could determine the width and height based on this, huh? The width of the image, the height of the image. Well, yeah, so we've got this close, but the weird thing is that it's this close and that it's, yeah, not wildly different. But hey, maybe in the future thingy, I will fix that. I'm so glad that I'm doing this in C now, rather than trying to do this in the shader to begin with. Oh my god. This is such a good decision to actually do it in C first. If I do say so to Past Duke. Good job, Past Duke. I can't hear her response though because she's in the past. Why does it keep making me look like I'm angry? I'm not angry. Ah! Okay, I'm gonna pass you on to somebody, but thank you very much for being here. In a particularly weird and obscure, nerdy way. Looking at the individual channels just shows they're misaligned, but hard to say why. Yeah, and it's not just that they're misaligned. There's like 3 copies. Like I'm doing something 3 times, or in the space of 1 block, while it should be happening over the space of 3 blocks. I'm not sure why that's happening. I'm gonna pass you on to somebody now. I think I'm gonna pass you on to... you know what? haven't raided Lane in a little while. I'll pass you into Lane. She's working on a level editor of hers for her 2D game engine. I think? Wait, is this for a 2D... Is this for her own engine? I have not seen this game of hers at all. The only game I saw was when she was using her engine to make a game for Nova's Game Jam, but that's finished. So I'm not quite sure what the game that she's working on right now is. Time to pass on. No, not like that. Not like that. But yeah, here's where we're going. Look at this cutie. I'm gonna poke the horn gently. Poke. Wait, that didn't really work. Okay, fine. Pats. There we are. Poke. Oh god, it's so hard to do. It's like flipped, and then also when I move my hands in a certain way, it kills my tracking, which makes my whole body move around. Anyway, thank you all very much for being here. Thank you for the pats, Stewie. That's gonna be all for now. I would like to do 2 more streams this week, but it's I don't know if it's gonna happen because I've been having big sleep issues, but we'll see. We'll see. It'd be nice if I could at least do a small stream. You know what? It's been a long time since I've done Trackmania with an open room, huh? Could do that. Could also do Zipkist in online mode as well. Nyan! Pat. Oh god. Pat kavat. Also Nyan. Also goodbye. I'll leave you in Lane's capable hands. Let's go over there now. Let's go. Oh god, I'm still there. Bye! Wait, I've got to come back to disappear. I'm back. I'm gone. Ah!